আৰু কোন আছিলে মানে নগলেও দাদা কামবিলাক তই কৰিবি মানে ৰিপ্লেচ হৈ গ'লি আৰু চন্দ্ৰপ্ৰভাত ৰাখিমতো মই এতিয়া অকণমান তই থাকি দিবি মাৰ লগত মানে চেণ্টাৰৰ লগত তই থাকিলি মানে মই এইটো মেলি এই কাপোৰ এইফালে সঞ্জীৱনী দেখাম সেই ঘূৰা ঘূৰি কৰোঁতে মানে এটা মাৰ লগত থাকিব এটা লগত যাব লাগিব চন্দ্ৰপ্ৰভাতে 2-3 বাৰ চেক কৰি বহুত দেৰি লগাই দিয়ে এইফালে নহয় ইফালে ইফালে নহয় মই আকৌ নহয় এইফালে যদি অফিচলৈ যাওঁ এতিয়া অফিচলৈ নাযাওঁ বুলিয়ে ভাবিছোঁ অফিচলৈ নগৈ কৰিলে পইচাকেইটা ফচি থাকে ৰিইম্বাৰ্চমেণ্টটো তোৰ মানে 60-70% পাম মানে আৰু সেইটো লাগি যাব 3-4-5 মাহ ডাইৰেক্ট কৰিলে মানে ডাইৰেক্ট নহয় ডাইৰেক্ট কৰিলে মানে তোৰ এটা তাতে দি দিয়ে সেই হস্পিটেলটো আমাৰ আণ্ডাৰত আছেতো তাত দি দিলে সেইটো তেতিয়া পেপাৰ চাৰ্জটো নলয় আকৌ দৰমহাৰ কাৰণে উপায় যায় তেনেকৈ হৈ যায় মানে চন্দ্ৰপ্ৰভাত সঞ্জীৱনী চবেই আছে সুবিধা মেডিকেলত মানে খেলি মেলিটো হ'ল কি আগতে অফিচটো আছিলে যোৰহাটতে যোৰহাটৰ টাউনতে আছিলে এতিয়া কৰোণাই খতম কৰি পেলালে কৰোণাৰ কাৰণে গৈ চিলামৰা পাবলগীয়া হয় আগতে চিলামৰা পাব লাগে মানে অলপ চিভিয়াৰ কেছ হ'লেহে যায় মানে ধৰ ইয়াত নহ'ব হেৰি যাব লাগিব গুৱাহাটীলৈ যাব লাগিব তেনেকুৱা কেছবিলাকত তেতিয়া তাৰ পৰা ৰিফাৰ দি দিয়ে মানে সৰু সুৰা ইয়াৰ হস্পিটেলবিলাক ইয়াৰ পৰাই দি দিয়ে এতিয়া মানে এই সৰু সুৰাবিলাকো গৈ যাব লাগে সেই তালৈ চিনেমাৰ ৰেজিষ্ট্ৰেশ্যনটো এনেকৈ মোৰ বহুত পইচা মানে ৰিইম্বাৰ্চ নকৰাকেই থাকি যায় মানে
on behalf of organizing committee, we announced that we will start very soon this session. Today is our last day of 3 days international webinar. Already our chairperson already joined in this meeting. So, this session, this is the technical track 4. In this technical track 4, how many?
Good morning, Raghunandan.
Okay, sir. Thank you, sir. Good morning.
Good morning.
This is our technical track session. I think 4, technical track 4. The allotted papers. I think here allotted papers for paper code P0152, P112. There is not serial. They called the name of the paper, the code of the paper. P015, P016, P017, P018, P019, P020, P110, P112, P111. So we are waiting for the presenter to enter. Before I hand over the session chair to our invited person, chairperson, Professor Sanat Kumar Mahato, I shortly introduce him. Professor Sanat Kumar Mahato.
Yes, Raghunandan, I can listen you.
Professor
So
Sanat
I
Kumar
will request you to record the
please
paper
participate.
presenters who are present now.
Please, one announcement, please participant mute their mic, also video, if it is possible, and not to go to the presenter mode if it is not necessary. Before hand over the chair to Professor Sanat Kumar Mahato, I introduced him shortly. Professor Mahato currently is professor in Department of Mathematics, Sidho Kanho Birsha University, Purulia. He has completed PhD from Barwan University. He has research area, reliability optimization, inventory management, biomathematics, etc. He has published many articles, books, chapters, and monograph in different reputed journals. He also completed two UGC funded GST project. He contributed different reviewer, contribute as a reviewer in different journals. He also live member of Operation Research Society of India and Calcutta Mathematical Society. Also, one thing I must say, he also connected with us as a editorial board member in different section in our department. Thank you, sir. for your cooperation with us. So, sir, please take this session as a chairperson. Please, sir.
Thank you, Raghunandan, for your nice introduction. I may request now the presenters to get ready and start your presentations. One thing I should mention that what is the time of duration of the presentation?
How many presenters are attend? Please call first. Then we decide how many possible in that time. Duration is 1 hour. In 1 hour, how many are attend in this webinar, in this session? First call, then decide how many. There are allotted number of papers is 9. How many are present? Then based on that, we should given the time. It is your hand.
Okay, I shall announce the names of the presenters. Aditi Vishwas, are you present?
Yes, sir, I am present.
Vinod Chetri, Abhishek Kumar Singh, are you present? Baljinder Kaur,
Yes, sir.
Devlina Banerjee, Devalina Banerjee, are you present? Rajarshi Bibhishan Pandit, are you present? Lakshmi Vishwas,
Yes, sir, I am present.
okay. Munir Nabi, are you present? Dr. Lieutenant
Guna Sekhar. Please participant be wait. I think connection problem is there. Some connection problem. Let him join. Again, I called the paper code. Paper code P015 is present.
Sir. Yes, sir. I am present. I am present.
Okay, thank you. P016 Vinod Chetri.
Yes, sir, I'm present.
Okay. P017 Abhishek Kumar Singh, not dead. P018
Yes, sir, I am present.
P019 Devlina Banerjee, not dead. P020 Rajashri P020 Rajashri not present. Okay.
sorry for disruption. Connection was lost. Now I call Aditi Vishwas to present her paper. Please remember that time allotted is 8 minutes for presentation and 2
Okay,
minutes for discussion. So please,
Oh.
Aditi, present your paper now.
Okay, I am starting. Is it showing?
It's not yet showing. Go to the present now mode.
Yes, sir, I am going through that. Present. Present now.
Enter your screen.
Yes. Share. I think it's showing now.
Not it is a present now. It is it is coming.
Okay, it's coming. It is visible now.
It is visible now.
Make it full screen. Make it full screen.
Make it full screen. Okay. Yes, sir. Now it's okay.
Okay, fine. Continue.
May I start?
Okay. Continue.
Good morning, my respected chairperson and present all of you here. Today, my topic of discussion is on multiplication and division theorems of entire algebraic functions of their relative growth indicators of higher index in the light of periodic analysis. First starts with introduction. First, we define an algebraically closed field of characteristic 0, say K, which is complete with respect to ultrametric absolute value, that is periodic value defined by this for any. Now we define two disks, one closed disk and another open disk, denoted by closed disk is denoted by d alpha capital R, and open disk is denoted by d alpha R minus. Closed disk is defined by all of those x where mod of x minus alpha, that is absolute value of x minus alpha, is always less or equals to R. And the open disk defined by the absolute value of x minus alpha is less than R. Also, we define a circle denoted by C alpha R and defined by all of those x satisfying mod of x minus alpha is equals to R. Moreover, A of K represent the kth algebra of analytic function in K, that is the set of power series with an infinite radius of convergence. For the most comprehensive study of analytic function inside a disk or the whole field K, the references are here. Now we consider an entire function f belonging to ak and r greater than 0. Then we denote mod f of r by the number supremum over mod of f of x on mod x equals to smaller, where this mod of r is the multiplicative norm defined in a of k. Similarly, we consider an entire function g and we may easily define mod of g of r. The ratio mod of f of r by mod of g of r as r tending to infinity is called the growth of f with respect to g in terms of their multiplicative norm on a of k. However, if the function f is not constant, then mod of f of r is strictly increasing function of r and tends to infinity as with r. Therefore, we may conclude that there exists its inverse function, which is denoted by mod of f cap of defined by this mapping with limit s tending to infinity, mod of f of s tends equals to infinity. Now we define log k of x and exponential k of x by this manner, and we also denote log of 0x equals to x and exponential of 0x equals to x. Now we consider the definition of order of f denoted by this and lower order of f. Hello, sir, my voice is coming?
Yeah, coming.
Okay. The above definition of order and lower order does not seem to be feasible if an entire function f is of order 0. To overcome this situation, in order to study the growth of f precisely, one may introduce the concept of logarithmic order and logarithmic lower order.
Continue.
I think connection is lower. Connection is
Aditi, continue.
Thus, once in this case, it is easy to verify that logarithmic order of f is equals to 1 and logarithmic lower order of f is equals to 1. Bosef also introduced the definition of type and lower type of an entire function f having some non-zeros finite order in the following way. That is, when the order of f is finite, we may define the type defined by this and the lower type defined by this. Analogously, if the lower order of f is finite, one may give the definition of weak type and the growth indicated tau bar of f of an entire function f belonging to a of k in the following manner. That is, tau bar of f is defined by lim sup tending to infinity this ratio, and tau of f, that is the weak type, defined by this. However, the concept of relative order in the complex context and as well as their technical advantage of not comparing with the growth of exponential z was first introduced by Barnell. Here we take the relative order of f with respect to g. Both are entire function defined by this limit lim sup tending to infinity this in terms of multiplicative norm. Also, we may define the lower order of f with respect to g. Further, the function f for which relative order and relative lower order with respect to another function g are the same is called function of regular growth with respect to g. Otherwise, f is said to be of irregular relative growth with respect to g. Now we define a k-valued entire algebraic function. First, first suppose capital F be a k-valued function defined by this irreducible equation where all small fk is not equals to 0 and all small fi's are entire function taken from a of k having no common zeros. If at least one of fi is transcendental, then capital F is called a k-valued algebraic function. If small fk is equivalent to 1, then capital F of f is called k-valued entire algebraic function. Now, in this connection, we consider these two following well-known inequalities 1, 2, 3, and 4. The determination of several growth indicators is very much relevant and essential in order to study the basic properties as well as the course of value distribution theory. In this connection, we may state some following results. That is this. Now we consider the definition of relative peak width order, relative peak width lower order, relative peak width type, lower type, weak type, and the growth indicator tau bar of the function defined in a of k. Let f and g belongs to a of k be any two entire functions having index pair mq and mp respectively, where mpq are positive integers. We define relative peak width order of f with respect to g by this and relative peak width lower order of f with respect to g by this. Again, we consider the definition of property is a non-constant entire function is said to have a property A if for any sigma greater than 1 and for all sufficiently large values of R if the inequality holds. Next definition, an entire function f of index pair pq is said to be regular pq growth if its peak width order coincides with peak width lower order. Otherwise, f is said to be of irregular peak width growth. Now we take the definition of relative peak width type of f with respect to g defined by this and relative peak width lower type of f with respect to g defined by this, where p and q are any two positive integers. Obviously, the relative peak width type and lower type of f with respect to g satisfying this inequality. Again, we consider the definition of the quantity tau bar and the weak type tau of f with respect to g satisfying this inequality. Now, aims and objectives. In this paper, we wish to establish some results on the comparative growth properties of entire functions belonging to AK in the light of comparative growth analysis of k-valued entire algebraic function in terms of relative growth indicators from the viewpoint of periodic analysis. The standard definition and notations are available in the references, so we skip it. Now, in this section, there are some lemmas which will be needed in the sequel. First lemma is, under the consideration of if be an entire function and alpha greater than 1, 0 less than beta less than alpha, s greater than 1 and 0 less than mu less than lambda, we have this inequality as our lemma. Similarly, under the same consideration, this equality, this limit equals to infinity is considered as a lemma. Again, if satisfies property A, then for any positive integer n and for sufficiently large values of this inequality, again considering this lemma, we skip it because of lack of time. Theorems in this section, we present our main results of the paper. Let theorem 1, that is our first result, let f and g be any two k-valued periodic inter-algebraic functions relative having relative index pair p and q, defined by these two irreducible equations where fi and gi's are entire functions having no common zeros, and fi's are entire function belonging to ak, also gi's are, and capital G be entire algebraic real functions such that at least one of fi is of relative pqth growth with respect to G, where P and Q are any two positive integers. Also, let capital G, that is the entire algebraic real function, satisfies the property A. If fi is strictly increasing function, then the relative pqth lower order of the quotient fi by fi plus 1 with respect to G is always less or equals to maximum over relative pqth lower order of each fi with respect to G. The sign of equality holds when at least one of fi plus 1 is of regular relative pqth growth with respect to G, and the relative pqth or lower order of fi and fi plus 1 with respect to G both are not equals. Example, if we consider capital F equals to exponential z and capital G equals to exponential z, p, q both are equals to 1, then we see that this equality holds in this theorem. This is the actually trivial case. Under the same consideration as theorem 1, we may easily see that this is also hold for order. First one is for lower order and this is order relative pqth order. Again, we consider the next theorem. Let f and g be any two entire algebraic real functions, and fi and gi's are entire function f is of regular relative pqth growth, where pqth relative lower order of f with respect to gi are all exist, where p and q are any positive integers. We have relative pqth order of f with respect to the quotient gi by gi plus 1 always greater or equals to this. Equality holds when this happens.
Aditi, go to the conclusion.
Okay, sir. I am going. Next is relative pqth lower order of f with respect to the product function. Also, similar result holds if we consider the quotient, that is gi by gi plus 1, which is obviously entire. Next theorem is that, and consequently we have. So here we made a remark. Let f and g be any two k-valued functions satisfying all of these that we mentioned in theorem 1, and order this not equals to this. We have the lower order, pqth lower order of f with respect to this function. We have this, and consequently this. Yes, future prospect and conclusion. Growth analysis of periodic entire functions from the viewpoint of different kinds of higher order relative growth indicators is in fact a progressive field of research, and therefore it needs to be extended with the treatment of some other functions either of slow growth or of faster growth. Therefore, the course of study relating to above may be a virgin land to the future workers in this branch. References.
So, any questions from the participants or audience?
Yes, sir. Hello.
Yes.
Yes. Ma'am, you are using the function f of r, log f of r, I think so. Many times you are using r. Yes. In your many cases, you are not mentioning about r. Suppose log f of r function we are using. Actually, suppose there may be r equal to 0 or r equal to some negative values. Is it possible to have negative values and 0 for r?
Sir, I am firstly considering that r greater than 0 here. At first, I consider that r greater than 0. R is a strictly positive number.
Okay. Throughout the section, r is greater than 0. Thank you.
Yes. Okay.
Any question more? Any more question?
Yes, sir. I have a question.
Okay. Yeah.
What is the relation or difference between the order and relative lower order of relative because lower order?
one we take the supremum limit and another we take the infimum limit. So if in many of cases the supremum limit and infimum limit are same, then we get the relative peak width order and relative peak width lower order are same of a function. But many of the cases, there are some functions where the relative lower order and relative lower order are not same. So basic difference is the taking the limit, relative peak width lower order and relative peak width lower order.
Does there exist any example for your result?
Yes, various. There are various results. For exponential z, we take if we calculate the relative peak with lower order, one function is taking as exponential z and another is exponential z to the power k. Then we see that both limits are different. Both limits are same. And if we take exponential z and another is taking as z z to the power n, then we see that the limits are different.
Thank you.
Okay, thank you.
Thank you, Abhijit, for your nice presentation and interactions. Thank you. Next,
Okay,
I call Vinod Chetri.
So just
Next,
a minute.
Vinod Chetri.
Yes, sir.
Are you present?
Yes, sir. Yes, sir.
Vinod Chetri
Yes, sir. Yes, sir.
from
Can you hear me, sir?
Northeastern University. The
Hello?
title is Validity of Generalized Second Law in Kinetic Corrected Scalar Field Models. Please
Yes, sir.
start
Can
your
you hear
session.
me? Yeah. Can you hear me, sir?
Okay, we can hear you. You present
Yeah.
your presentation.
Yes, sir. Is it visible, my slides?
Yeah. Just rotate it. Yes, fine.
Yeah. Okay, sir.
Okay, continue.
Good morning to everyone. I'm going to present my paper. The title of my presentation is Validity of Generalized Second Law in Kinetic Corrected Scalar Field Model. Outline of my presentation are: first one is abstract and motivation, basic cosmological equation, generalized second law of thermodynamics and equilibrium thermodynamics. Next is thermodynamic analysis and conclusion. Abstract. In this work, we shall study the validity of generalized second law in non-canonical scalar field models with kinetic correction. Here we consider two types of kinetic corrections, namely square kinetic and square root kinetic correction models. For this purpose, we consider FRW universe filled with ordinary matter. Finally, we check their validity and make comparative study of this model.
Speak some loudly.
Okay, sir. We found that modified Hawking temperature plays a crucial role in making perfect thermodynamical system on the event horizon. Motivation. This is a relation between gravity and thermodynamics. There is a profound relation between gravity and thermodynamics. The story started in 1970s. After the discovery that black hole can be considered as a thermodynamical object with temperature and entropy. In 1995, Jacobson first showed that Einstein field equation could be derived from first law of thermodynamics. Later on in 2005, Padmanabhan also able to derive Einstein field equation from first law of thermodynamics. This shows that there is a nice relationship between gravity and thermodynamics. This nice equivalence relation has been extended in the modern cosmology, considering universe as a thermodynamic system. This motivates us to study the universal thermodynamics. Another motivation of studying thermodynamic laws is that even if a model satisfies observation constant, it can be ruled out if it does not respect thermodynamical laws. Basic cosmological equation. The general action of minimally coupled scalar field model can be written like this, where G, R, L, M, and L phi denotes the determinant of the metric G mu nu and Ricci scalar, the matter Lagrangian and scalar field Lagrangian respectively. The scalar field Lagrangian can be considered like this one, V into F of B, where V stands for potential, and this F of B is an arbitrary function of B with scalar field phi, where B can be expressed like this, and X is this one. And one can easily reduce this form into a canonical case if we consider F of B equal to B minus 1. If we vary the action 1 with respect to the FRW metric, one can obtain the Friedmann equation and accelerated equation like this one, where rho m and pm represents the usual meaning of this matter density and pressure, with equation of state Pm equal to omega rho m, with omega as the equation of state, and it belongs to closed interval -1 to +1. And further, the scalar scalar energy density and pressure can be written like this one. And if we consider F is constant, the equation of state reduces to standard cosmological constant. And again, if we take variation of action, we get this field equation like this one. Now we consider power law kinetic correction to the canonical scalar field case given by this one. And corresponding to this scalar field Lagrangian, one we can write this scalar field Lagrangian like this one, where gamma and r are two real parameters, which is well defined if n greater than 0. Here the n gives the correction to the canonical case. In this study, we consider two cases, square kinetic and square root kinetic. Consider square root kinetic correction of non-canonical scalar field corresponding to n equal to 2n, n equal to 1 by 2 for the viability, thermodynamical viability. Next is generalized second law and equilibrium thermodynamics. Like first law of thermodynamics, the second law of thermodynamics has an important role in the cosmological constant. It is extended as the generalized second law of thermodynamics in cosmology. It stated that sum of horizon entropy and matter entropy inside the horizon of an isolated macroscopic physical system cannot decrease. Here we consider two types of horizon, namely apparent and event horizon. Mathematically, they can express like this one: apparent horizon is 1 by h, and event horizon is can be expressed with this improper integral, where h is the Hubble parameter and h can be written as a dot by a. Here a represents the scale factor, and this over dot represents derivative with respect to cosmic time t. This improper integral converges if we consider a equal to 2 alpha for alpha greater than 1, and event horizon exists only in accelerating universe. Equilibrium thermodynamics plays a vital role in the study of thermodynamical laws. In the context of universal thermodynamics, if Sm is the matter entropy and Sx is the horizon entropy, then we must have these two inequalities. First one is called generalized second law, second one is called thermodynamic equilibrium. Here St represents the total entropy of a system, and this suffix x represent x equal to a represents apparent horizon and x equal to a represents event horizon. And the horizon entropy can be calculated either by using first law of thermodynamics or entropy area relation. And the matter entropy inside the horizon can be calculated by Gibbs equation and given by this one, where Em is the energy flow across the horizon and V is the volume, and Rx is the horizon and Tm represents the temperature of the matter. To calculate the matter entropy, we assume that temperature inside the horizon on the horizon and on the horizon must be equal by local equilibrium hypothesis. If the temperature of the matter and the horizon differs, then our assumption then there will be simultaneous flow between the horizon and matter, and which may deform the FRW geometry, and then it will be difficult to study the thermodynamical laws. Next is thermodynamic analysis. To extract the horizon entropy, we extract the horizon entropy, use the unified first law. And this horizon entropy on the event and apparent and event horizon can be written like this two expression. And on the other hand, the rate of change of matter entropy on the horizon can be extracted from the earlier Gibbs equation. And the total expression, that is GSL on the apparent and event horizon, can be written like this one. Due to this complicated expression, we consider the dynamical analysis. So for the study of dynamical,
please speak loudly.
Yeah. We consider three variables x1, x2, x3, and the above system will reduce this system of equation. And here these are these three equations for x1 corresponding to x1, x2, and x3. And for first case, for GSLT for the square kinetic correction, in this case the Lagrangian will take this form. And due to this complicated expression, further we study numerically, and we find that GSLT do not hold during the radiation domination, but it is satisfied during matter and dark energy domination epoch at the present horizon or apparent horizon. On the other hand, GSLT holds only during the dark energy domination, but fails to satisfy during early radiation and matter radiation era at the event horizon. Similarly, on square root kinetic correction, the scalar field Lagrangian can be written like this one. And similarly, if we do numerical analysis, and we find that GSLT, it is found that GSLT does not hold on the for the present model in the both matter and dark energy dominated area. Similarly, at the event horizon, we found that GSLT satisfied only for dark energy domination era and also during earlier late part of the dark matter dominated era. And the final our results. It is interesting to note that our analysis supports the previous result on the cosmological background dynamics of this model. We see that square kinetic correction model is more realistic as compared to square root kinetic correction model from a thermodynamic perspective. The modified Hawking temperature plays a vital role in making Bekenstein system, and one can consider our model as a viable one, at least at the background level. References, these are references, and thank you.
So any question from the participants? Anybody? So if there is no question, then we thank Vinod for his nice presentation. And next I call Abhishek Kumar Singh. Abhishek Kumar Singh, are you present? Abhishek Kumar Singh. Please respond. Next, I shall call Baljinder Kaur.
Yes,
Are you
sir.
present?
Yes, sir.
Okay, Baljinder, you can continue.
आजकल अब ऊ भएर चाहिँ यसो बेमारको लागि सब यसरी नै गर्छन्
Sir, is it visible?
Baljinder Kaur.
Yes, sir.
Yes.
Okay. I'm Baljinder Kaur, and I'm here to present the title of presentation of the study of a system of space-time fractional differential equation.
दाइ पनि अब अलिक राम्रो भएपछि जान्छन् कि के फेरि
Hello.
Vinod, please mute yourself.
The outline of this paper this presentation is the introduction, then dispersion analysis of a system, and then solute solution by using fractional subequation method. So, in introduction, as the theory of modern physics mainly include mathematical structure defined by a certain set of differential equations to find out the result of any physical phenomena. So, the fractional calculus is mainly a branch of mathematical that studies the several different possibilities of defining real number power or complex number power of a differential operator. So, in this paper, the physical phenomena named as space-time fractional by Hamiltonian Basic system involving a Riemann-level fractional derivative is studied. The wave dispersion relation in the linear form of the system is analyzed and further used to obtain the phase velocities and the group velocities. In next section, the fractional equation is studied by the fractional subequation method to find out the solute solution and have obtained the solution in form of trigonometric function, hyperbolic function, and rational function. So, the space-time fractional by Hamiltonian Basic system, which I am considering in this presentation, is given by equation 1.1. The dispersion analysis of the governing system. So, in order to analyze the dispersion relation of the system, I am considering the linear form of the system as in equation 2.1 and the functional equation. So, this is mainly that to analyze the dispersion for linear system, the central dispersion waves are considered to have special linear dispersion waves and which describe the physical phenomena for the relationship between the wave number k and the angular frequency omega, which lead to find out the relation between the phase velocity and group velocity. So I am considering the central form as 2.2. That is 2.2 equation. I have considered that this is the solution of equation 2.1. So I have to calculate the value of omega bar in form of k, and also a1 and a2 relation between a1 and a2. So now applying the Fourier transformation, this one, the dispersion relation of the linearized form 2.1 is obtained in the following form, equation 2.3 and 2.4. And by solving 2.3 and 2.4, I have found out the value omega bar as equation 2.5 and the relation between a1 and a2 in equation 2.6. So expression by using this expression, I have calculated the phase velocity equation 2.7 and group velocity defined by Vg, denoted by Vg as in equation 2.8, and also find the relation between that both values and find out that this value is positive, that is mode value of Vg minus mode value of Vp is positive, then the system is observable. I have obtained And in next section, the application of fractional subequation method. So in this section, the method from references 2 and 3 and 4, I have found out the solute solution. Or for this method, firstly we have to consider that the system has a solution in form of 3.1. So UXT and VXT I have considered, and I have to calculate the value of AIs and value of M and N. That means range of the this sum from 0 to M and 0 to N. So I have to calculate the value M and then also coefficient AIs and BJs. So here the phi is a solution of fractional Riccati Beckland transformation of the fractional Riccati equation 3.2. That means phi is solution of 3.2, where sigma is an arbitrary constant, and phi psi alpha is the fractional derivative of phi xi with respect to xi of order alpha, where alpha is any number between 0 and 1. And also phi xi is given by equation 3.3. Here in equation 3.3, we can see that there are two new constants, A1 and A and B, and psi xi. Psi xi also is a solution of 3.2 is of the form equation 3.4. So in equation 3.4, there are we can see that there are 5 cases, 2 cases for sigma negative, sigma less than 0, solution in form of tangent hyperbolic function, and second solution in form of cotangent hyperbolic function, and 2 values for sigma greater than 0. One is of tangent function and second is cotangent, and third case is for sigma equal to 0, and solution is in form of rational function. So here also we can see that here a function or function trigonometric or hypertrigonometric function are not of single variable. They are two variable, as we can see that there are a tangent hyperbolic of root of minus sigma xi comma alpha. So these function, this geometrical function, trigonometric function are defined by this formula. Where E alpha I xi alpha is a this is a Mittag-Leffler function. Next, now applying this method on our system, so we employ the fractional this sub-equation approach to identify the exact solute solution on our Bosniak system, which I'll consider. So first of all, I am reducing the variable xt to a single variable xi in form of traveling wave solution. So xi is equal to kx plus ct plus xi naught. So for some constant k, now equation putting the value of 3.6 in our equation 2.1, we have 1.1, we have equation 3.7. So from equation 3.7, by using the value of by putting the value of solution which I have considered obtained in equation 3.7, assume in equation 3.7, by putting that value. And again by using the homogeneous balance method, homogeneous balance between the 3.8, we have obtained the value of m and n. There is n is equal to 2 and m is equal to n. That means both values are 2. So u xi and v xi, which I have assumed the value is have only term 3. With constant a naught a1 a2 and b naught b1 b2. Now for the equation 3.10 together with equation 3.9 and 3.7, and comparing the power of phi xi, and by using the software Maple, I have obtained that there are 6 type of set of solution of constants a naught a1 a2 b naught b1 b2 and constant sigma and k. There are 6 type of cases by using the software Maple. So in each case we have obtained 5 type of solution, which we already discussed that for 2 cases for sigma less than 0 and 2 sigma greater than 0 and 1 sigma equal to 0. So here we can see that a1 a2 and b1 b2 are 0. So only constant a is equal to a naught. That means a naught is arbitrary constant and b naught is arbitrary constant. So there is only one type of solution, u1 and v1. In second case, we obtain the value of constant in this set, a naught a1 and so on. So here sigma is arbitrary. That means sigma may be positive, negative, or 0. So there are 5 cases. First is for sigma less than 0, U2 and V2. Second is V3 and U3 for sigma less than 0 in form of cotangent hyperbolic. And fourth one is for sigma greater than 0 in form of tangent hyperbolic solution tangent function form. And fourth one for co-trigonometric function form. And fifth one is for rational function form in case sigma equal to 0. In third set of solution, here we can see that sigma is equal to 0. So therefore, there is only one type of solution of rational function form, and this one is U7 and V7. Here is a fourth set of solution of constants. So here sigma is the arbitrary function and some values of other constants. So here also 5 type of solution: two for sigma negative U8 V8 and U9 V9. 2 for sigma positive U10 V10 and U11 and V11, and 1 for sigma equal to 0 U12 and V12. In fifth set of yes sir.
One more go to the conclusion. Time is over. Huh?
Yes, this is fifth case, and here 5 type of solution, and this is sixth case. Here also 5 type of solution. And thank you.
So, any question from the audience? Any question from the audience? So, if there is no question, we thank Malinder Kaur for her nice presentation. Next, I call Devolina Banerjee. Devolina Banerjee,
Yes,
are you present?
present.
Devolina Banerjee?
First, unmute the mic, then speak.
Devolina Banerjee?
I get from her, she present, she just. Deblina, are you present?
Am I audible?
Yeah, yes, sir. Deblina, হ্যাঁ আনমিউট করে তুমি কথা বলো ওইখানে, তাই তো বুঝা যাবে। হ্যাঁ এই তো আনমিউট হয়ে এবার কথা বলো, আনমিউট না হচ্ছে না শোনা।
So, Devolina Banerjee, are you present? Devolina Banerjee, are you present? If not, then Rajashree Vibhishan Pandit. I call Rajashree Vibhishan Pandit. Are you present? No. Then Lakhi Vishwas, are you present?
Yes, I am present.
Okay, continue.
Deblina is present, is joining here, but his sound is not coming. So
Okay. I shall call her later. Okay, now continue, Lakshi. Lakhi Vishwas,
sir.
you can continue.
Yes, sir. Sir, is it visible?
Visible, but can yeah. Yes, fine.
Good morning, respected sir and madam. First, I am very much thankful to the organizing committee of this university for giving me the opportunity to present my work. Sir, I am working on relative defects of special type of differential polynomial in connection with their integrated moduli of logarithmic derivative. Here is the abstract of this paper. These are the outlines. Now, first we introduce the term differential polynomial. Let f be a transcendental meromorphic function defined in the open complex plane C. A monomial in f is an expression of the form mf is equals to f to the power n0, f1 to the power n1, so on, fk to the power nk, where the indices n0, n1, so on, nk are non-negative integers, and we call the numbers gamma m is equals to n0 plus n1 so on nk, and cap gamma m is equals to summation over I from 0 to k I plus 1 ni, and these numbers are respectively called the degree and weight of the polynomial. Now let us consider if m1f, m2f, so on, mnf denote the monomials in f, then the quantity qf is equals to summation over I from 0 to n ai mi, where I is equal to 1, 2, so on, m not equals to 0, is called a differential polynomial generated by f of degree gamma q and the weight cap gamma q. Also the numbers gamma q lower bar is equals to minimum over gamma mj, where 1 lesser equals to j lesser is equals to n is the lower degree of the order of qf respectively. If gamma q lower bar is equals to gamma q, then qf is said to be homogeneous differential polynomial. Next, we define Nevalina deficiency and Validron deficiency. Let f be an entire function defined in the finite complex plane C. Therefore, any a belongs to C union infinity, the quantity del AF is equals to lim infimum MRF by TRF is called the Nevalina deficiency of the value A. Similarly, we define the Validron deficiency of the value A in the following manner. Next, we define relative Nevalina defect. Milax introduced the concept of absolute defect of A with respect to the function f dash. Later, Jiang extended this definition and he introduced the term del RKAF is equals to 1 minus lim superior R tends to infinity n R AFK by TRF for K is equals to 1, 2, 3, so on. And these are called the relative Nevalina defect of A with respect to the function FK. Now we define the integrated moduli of logarithmic derivative. For a meromorphic function f, the integrated moduli of logarithmic derivative IRF
1 minute,
is...
please.
Yes,
Alok
sir.
Pandey, please stop presenting. Alok Pandey. Who is Alok Pandey? Who is Alok Pandey? Stop presenting, please.
আনমিউট হয়েছে, এবার কথা বলো, আমি শুনি। ফোনটা বাদ দিও। হ্যালো,
All the others will mute yourself, both audio and video. And please don't present while the presentation is going on. Now,
কাটো দিয়ে কথা বলো।
please mute your audio and video. Now, Lakshmi, please continue.
ফোনটা কেটে দাও।
আচ্ছা, আচ্ছা। ঠিক আছে। Sir, may I start?
Continue.
For a meromorphic function f, the integrated module
presentation is not visible to us.
Go to the CMOA presentation now.
Is it visible, sir?
No, you not turn on the presentation now.
Sir?
Go to the present now mode, then you share your screen. Then proceed again.
Start again.
Yeah,
Present now টা আবার করো, কেটে গেছে।
স্যার করছি। Sir, is it visible?
Okay.
Sir, in this paper, we call the following 4 terms by using the concept of IRF. Now, our main objective in this paper we consider the function cap f equals to f to the power n qf, where qf being a differential polynomial in f with n equals to 1, 2, 3, so on, and compare the relative Valiron defect with the relative Nevalina defect of f under the flavor of integrated moduli of logarithmic derivative. These are the lemmas for, in order to achieve our main result, we consider the following lemmas. First lemma, let k be any positive integer and psi is equals to summation over I is equals to 0 to k ai fi, where ai are meromorphic functions such that t r ai is equals to srf. For I is equals to 0, 1 to so on k, then we get this result. Next lemma, let f is equals to fn qf, where qf is a differential polynomial in f. If n is greater or equals to n, then the limiting value of trf by trf as r tends to infinity is equals to 1. Our third lemma is let f equals to cap f equals to f to. Hello?
Continue.
Let f equals to f to the power n qf, where qf is differential polynomial in f, then for n greater or equal to 1, then for any alpha, we get these two results. Our fourth lemma is here. We skip it. Lemma, let f
Okay.
be an entire. Now we go to our main result. First result, that is theorem 3.1. Let f be a transcendental entire function of non-zero finite order row having no zeros in C such that MRF is equals to SRF. If A, B, C are any three non-zero finite complex numbers, then we get these two results. Where the f is differential polynomial in f of the form f is equals to f to the power n qf with n greater or equals to 1. Here it is to be noted that the condition A, B, and C are non-zero finite complex numbers in this theorem is essential, which is evident from the following example. If we take fz is equals to e to the power z and a, b, c all equals to 0, then we see that nrf is equals to 0, trf is equals to r by pi, irf is equals to r square, which is not equals to 0, the order rho is equals to 1. Now we consider n equals to 1, n0 is equals to 1, and all others n1, n2, so on, nk equals to 0, and a1 is equals to 1, so that f is equals to e to the power z is equals to small f. Then calculating, we see that a contradiction arrived. Next, we take fz is equals to e to the power z and a, b, c are equals to infinitive. Then we see that nrf is equals to 0, trf is equals to r by pi, which is not equals to 0, and irf is equals to r square and rho is equals to 1. Again, we see that a contradiction arrived. And the condition f has no zeros in C in the first result is essential, as it is evident from the following example. If we take fz is equals to e to the power 3z, then we see that nrf is equals to 0, irf is equals to 3 r square, which is not equals to 0, the order rho is equals to 1, and we consider n equals to 1, n0 is equals to 1, and all others n1, n2, so on, nk equals to 0, and a1 is equals to 1, then we see that a contradiction arrived. Our next result is that is theorem 3.2. Let f be an entire function of non-zero finite order row with no zeros in C such that MRF is equals to SRF. Also let f is equals to f to the power n qf is a differential polynomial in f with n greater or equal to 1. If a, b, c, d are four distinct complex numbers, then we get del I df plus del I f bf plus del I f cf plus 1 by pi rho is less or equals to 3. The condition B, C, and D are non-zero finite complex number in this theorem is essential, as we see in the following example. For if we take f is equals to e to the power 2z and b, c, d are all equals to 0, then we see that nrf is equals to 0, irf is equals to 2r square, which is not equals to 0, the order rho is equals to 1, and d delta I df is equals to delta I 0f is equals to 1. If we consider n1 is equals to 1, n0 is equals to 1, and all others nk is equals to 0 and a1 is equals to 1, then substituting all these values, we see that a contradiction again arrived. Now we take fz is equals to e to the power 2z and b, c, d all equals to infinity. Then again we see that a contradiction arrived. Also, the condition F has no zeros in C in this theorem also essential. As if we take Fz is equals to the power 3z, then we see that NRF is equals to 0, IRF is equals to 3r square, rho is equals to 1. Then also substituting all those values, we see that the contradiction arrived. Our third result is let F be a transcendental entire function of finite order rho having no zeros in C such that MRF is equals to SRF if A and C are any two distinct complex numbers, and let a capital F is equals to small f to the power n qf is a polynomial in F with n greater or equals to 1, then we get this result.
Please go to the conclusion. Lakshmi, please go to the conclusion.
This is our last result.
Okay.
The sign less or equals to in this theorem cannot be removed by less than only. This is follows from the following example. Further prospect in the line of this work as carried out in the paper, one may think of finding out relative deficiencies of higher index in case of meromorphic functions with respect to another one on the basis of sharing of values of them, and this treatment can be done under the flavor of bicomplex analysis. As a consequence, the derivation of relevant results is still open to the future workers of this branch. These are the references. Thank you, sir.
Any question from the audience? If there is no question, then thank you, Lakshmi Vishwas, for your nice presentation. Next, I call Munir Nobi. Munir Nobi, are you present?
Devlina Banerjee present. She wants.
Okay, I'll call her later. Just
She actually.
Devlina Banerjee.
Yes, sir, I am present.
Devlina, yes, continue.
Today I want to talk about the matter analytical wave solution.
So, show your presentation.
Today I want to talk about the matter analytical solitary wave solution of dust ion acoustic waves.
Show your presentation.
You follow like this
Yes,
procedure. Present now, go to present now, then share your enter screen.
Parameters in the framework of damped modified chaotic device Burger equation. The analytical solution of dust ion acoustic.
Devlina, we can't see your presentation.
Yes, sir. Visible, sir.
No. You go to present now, then enter screen.
Yes, sir. Yes, sir.
In your web browser, you see that there is an icon at the bottom right. Present now. Then.
Yes, sir.
Are you using mobile or computer?
Mobile, sir.
Mobile. Then touch on the three dots. Then you will see share screen.
Oh, share screen. Visible, sir?
No.
Reported in a dusty plasma model considering the dust ion solution using reduction perturbation technique.
We can't see your presentation.
So now visible, sir?
No, not visible. If you have any problem, you can send your presentation to Raghunandan Giri. He will help you.
If you have the mail ID of
yes, sir.
me, then send me. I show from my side. So wait for your chance. Just wait and share it. For the next one.
Next, Munir Nobi. Munir Nobi, are you present? And then Dr. Lieutenant T. Gunasekar. T. Gunasekar, are you present?
Paper number 112.
Share screen option.
Abhishek Kumar Singh. I think Abhishek Kumar Singh is present. Abhishek Kumar Singh. And Devolina is the last presenter. Devolina.
I obtained DMKD damped modified chaotic device Barger equation in some critical composition. The effect of different physical parameters, that is dust ion collision frequency, entropy index, the speed traveling wave viscosity coefficient on dust ion acoustic solitary waves observed. The field of dusty plasma is a multidisciplinary research field. Many theoretical and experimental observations can be found in this field. This is an introduction part. In section 2, we consider.
Can you share your screen?
Sir, I am trying. Is visible, sir?
No, I told you to send it to Raghunandan Giri so that he can present from his part.
Dusty plasma model with Q non-extensive velocity governing equations are 1 to 3. Del n del t plus del x of n u 0 equation number 1. Del u del t plus u del x equal to minus 3n. Del n del x minus nu id mu minus del phi del x plus n del to phi by del x2. Equation number 2. Del to phi by del x2 1 nd plus del 2 Ne minus n. Equation number 3. Nd, number of density of dust. Nd e to the power sigma phi with sigma equal to Ti by Td.
Devolina, listen me. Without PPT, it is meaningless to read out the paper.
Okay, sir. Is it visible, sir?
No, this is not the way to present your paper. You are doing.
Sir, okay.
I told you to send it to the convener or coordinator.
Yes, I am sending, sir. I am sending. Okay.
Send it to Raghunandan Giri in email or WhatsApp.
Okay.
He will help.
What?
Just do it quickly.
Yes, sir. I am sending.
Dr. Raghunandan Giri, please help her to present her paper.
Okay, sir.
গেছে হয়েছে গেছে এখন অফিসে Mail. Sir, I have sent it to the mail.
Okay,
Okay, wait.
May I continue, sir?
it is not.
Wait.
Okay, sir. Okay, sir.
Okay, I think you got this presentation. Just wait.
Dr. Giri.
Yes, I got it. I just downloaded that.
Okay, okay. Okay, Devalina, continue.
Yes, sir. Phi electrostatic potential, any mass
Which
of
page? Which page? Page number?
of dusty plasma is a multidisciplinary research field.
See that in that screen. Then
Can be found in this field. This is the introduction part. In section 2, we consider a collisional dusty plasma model with Q non-extensive velocity distributed electrons and the normalized governing equations. Equations number 1, 2, and 3. Del N del T plus del del X of Nu equal to 0. Del U del T plus U del U del X equal to minus 3n del N del X minus new id u minus del phi del x plus n del 2 phi by del x2. Del 2 phi by del x2 equal to delta 1 nd plus delta 2 ne minus n. Here, nd denotes number density of dust given by nd equal to e to the power sigma phi with sigma equal to ti by td, the following distribution function. Phi, yeah, electrostatic potential, any mass of electron, V velocity of electron, E magnitude of electron, T temperature of electron, KB Boltzmann constant, CQ constant of normalization. If you the distribution that maximizes the entropy. In this section, we have done nonlinear analysis using RPT, that is reduction perturbation technique. We obtain GKVD equation, that is damped Cortis device,
Devalina.
using the stretched coordinate and
Devalina.
variable. Yes, sir.
Need not to read out the paper, you just go to the conclusion. রেজাল্ট কি করেছে সেটা একটু বলে দাও, হ্যাঁ বাস।
Okay, okay, sir. Okay, sir. Okay, sir. Okay, sir. Actually, conclusion. Yes, sir. Yes, sir. Yeah. Now consider 4 parametric value set, that is non-linearity vanishes. As a consequence, we have to consider higher order non-linears to achieve DN-KDB equation. In this paper, we have theoretically investigated the propagation and interaction of dust, ion, acoustic, solitary wave solutions in presence of collisional frequency. Using RPT, that means reduction perturbation technique, we have derived damped, modified Corti device Barger equation. The effect of different physical parameters such as dust ion collision frequency. The speed of in naught and the ratio between the unperturbed densities of ions mu and viscosity coefficient n on the analytical solution of DIO WS are observed. That is dust, ion, acoustic waves. The figures show the significant effect of relevant parameters. Finally, result obtained here should be used to investigate the nonlinear phenomena of dust, ion, acoustic in wave plasma.
Okay, thank you, Devolina. But I shall request you to go through the demos before you going to present any paper anywhere. Next, anybody is present in this session who has been enlisted as presenter? Otherwise, we shall conclude this session. Anybody? So I think there is no more to present their papers in this session. Then I will request Dr. Giri to conclude this session. Dr. Giri?
Okay, sir. So now,
Thank you, sir. Thank you, sir.
Thank you. Morning. How are you?
I am fine, sir.
Okay.
And you all?
We are also fine. You see what are you doing now? We are all very
I can see Dr. Vidyasagar Giri, Professor Vidyasagar Giri. How are you, sir? Professor Vidyasagar Giri. Sir, you are muted. Just unmute.
Hello.
I can see Dr. Kaushik Ghosh also.
Morning, Vidyasagar.
Morning, very good morning.
Very good morning.
So you are running late, so I can request. Dr. Raghunandar Giri, this session is ended, no?
Yeah, now we are just finished the technical session 4. Now we are to start very soon the invited lecture session 7. I request Ganesh. Ganesh, please.
Yes.
Ganesh.
Yes. Okay, dear all. Now we are going to start our invited lecture session 7. And this session will be chaired by Professor Maiti. What actually Professor G. Selvachandran is the invited talk. He will give the invited talk. But due to some, he is trying to join, but due to some technical problem, he is till now not able to join. So please stay joined with us. We will start this session as soon as she joins with us. So now I request Dr. Giri to play our university video, please.
Sorry?
Dr. Giri.
Yes.
For the time being, you please display our university video since Professor Selvachandran is till now is not able to join. She is trying from her end. Okay. So as soon as she joins, we will start this session.
Okay.
Hello, Dr. Giri.
Yes.
Hello, Raghu Giri, Dr.
Yes, sir.
Raghunandar Giri.
Hello, sir.
Can you hear me?
Yes, sir. Hello, sir.
Hi, can you hear me?
Yes, sir. No problem, sir. Your video also we see. Also your voice also we hear. No problem, sir.
Okay.
Now I present in our departmental documentary team. Wait for madam to come. আচ্ছা ঠিক আছে দাঁড়াও, তুমি এই যে শেষ হয়ে গেলে অ্যানাউন্স করে দাও, আমি সেই মার্কেটের সঙ্গে কথা বলি। আচ্ছা
হ্যাঁ বল। হ্যাঁ তাহলে কি ওটা ক্যান্সেল করে দিলে তো কিছু? কতক্ষণ অপেক্ষা করবো? হ্যাঁ তাহলে হ্যাঁ এটা একটা বড় আচ্ছা হ্যাঁ কি
I joined as the Vice Chancellor of the University, infrastructure
হ্যাঁ ঠিক আছে তাহলে
and it requires great work to create an ideal infrastructure for a university like
Professor Maiti.
infrastructure because
Hello, sir.
in this university belong to
Raghu.
okay sir
Hello, Raghu.
hello sir
So, where is Professor Maiti? Is left or here? Sir. So, you may request Professor Maiti to present something on his area. Hello. Hello, Raghu.
হ্যাঁ স্যার বলুন হ্যালো
মাইতিকে বলো না, মাইতি যদি কিছু একটা প্রেজেন্ট করে এই সময়।
আচ্ছা মাইতি স্যার দেখছি স্যার
মাইতি কি চলে গেল নাকি? একটু ফোন করে বলো দেখি।
প্রেজেন্টেশন হয়তো স্যার রেডি নেই, আমি স্যারকে এমনি মুখে বলতে বলছি স্যার।
হ্যাঁ তাই বলতে বলো না। present scenario of inventory control or any other thing like that.
Sir, but inform Maiti said that we don't have much time, only 30 minutes left for the next invited session.
No, he will speak something regarding the modern dishes or modern areas like that.
Okay.
And what is the speaker problem of the speaker?
বলছি আপনি যদি একটু আমাদেরকে সাজেস্ট করেন ওইখানে জিজ্ঞেস করেন আমরা একটু বক্তব্য দেখি ম্যাডাম আছেন যে আপনি যদি কিছু বলতে চান স্যার একটু বলে ভালো না বুঝতে পারলাম হ্যালো
হ্যাঁ স্যারকে যদি বলছি যে যদি আপনি কিছু একটু বলেন আর কি স্পিকার তো জয়েন করতে পারছেন না হ্যালো স্যার হ্যালো
Okay, one announcement. We will start the invited lecture 8 very shortly. Please stay connected.
হ্যালো হ্যাঁ বল না না কোনো দরকার নেই আরে না না হ্যাঁ সেই আচ্ছা আমি তাহলে বেরিয়ে যাচ্ছি নাকি আরে না না তাহলে আমি বেরিয়ে যাবো তো নাকি
Hello.
Yes.
Hello.
Hello.
Yes, sir.
Morning, sir.
Hello. Hello. Can you hear me?
Yes, yes. Yes, sir.
Okay.
I am Professor S. Chakraverty from NIT Rourkela.
Okay. So, Professor
welcome,
S.
sir.
Chakraverty is.
Yeah. Hello.
Yes, the Professor S. Chakraverty joined with us. So we'll start our invited lecture session 8. And the invited talk will be given by Professor S. Chakraverty from National Institute of Technology, Rourkela. Professor Chakraverty will talk about N-based solution of linear and nonlinear system of equations and further interesting results. Professor Giri from Jadavpur University will chair this session. So before start of this session, I'd like to introduce them before the participants. First of all, I will introduce Professor Giri. Professor Giri is working in Jadavpur University in the Department of Mathematics. His research area includes inventory and production planning, scheduling, supply chain management, closed loop, sustainable supply chain management, bullwhip effect, logistic, multi-attribute decision making, etc. He has more than 20 years of teaching and research experience. Professor Giri has published more than 100 reputed journal articles, and he has guided more than 11 PhD scholars. And he has completed 5 projects funded by DST, CSR, etc. Now I'll introduce Professor Chakraverty. Professor Chakraverty is currently working in National Institute of Technology, Rourkela, Odisha, as a full professor in the Department of Mathematics. He is having experience of 27 years of research and teacher. Prior to this, he was with CSIR Central Building Research Institute, Rourkela, India. Dr. Chakraverty received his PhD from Maiti, Rourkela in 1992 and postdoctoral research at the Institute of Sound and Vibration Research, University of Southampton, UK, and at the Faculty of Engineering and Computer Science, Concordia University, Canada. He was also a visiting professor at Concordia and McGill University, Canada during 1997 to 1999 and visiting professor of University of Johannesburg, South Africa during 2011 to 2014. He authored 10 books, published more than 250 research papers in journals and conferences. He is with the editorial board members of several journals. He is also the reviewer of around 50 national and international reputed journals. And Professor Chakraverty is the recipient of few prestigious awards. I would mention some of them, like Indian National Science Academy Platinum Jubilee, ISCA Lecture Awards, CSR Young Scientist Award, Voice Card, PhD, U-Post Young Scientist, Golden Jubilee Directors Award, etc. He has already guided 11 PhD students and 9 are ongoing. Dr. Chakraverty has undertaken around 16 research projects as principal investigator funded by international and national agencies. A good number of international and national conferences, workshops, and training programs have been organized by him. His present research area includes subcomputing and machine intelligence, artificial neural network, fuzzy and interval computations, numerical analysis, differential equations, etc. So may I now request Professor B.C. Giri to start the session, please.
May I audible now?
Yes, sir.
Okay. So thank you, Dr. Gorai, for your introduction. It is, in fact, you have given me a very tough job to chair this session, especially when our honorable speaker, as you heard, that is a very eminent scientist and scholar, and he will deliver his lecture. And you have given the chance to chair this session, so I am very much excited to listen him. Anyway, I would like to welcome all of you to this session 8 of 3-day international webinar on the role of applied mathematics in present global crisis. So without wasting time, may I request Professor Chakraverty to start your lecture, because our participants are waiting more than 30 minutes or 40 minutes, because the previous session it was not organized because of unavailability of the speaker. So please start your lecture, Professor Chakraverty.
Yes, yes. Can you hear me?
Yes.
Okay, okay. Okay, good morning to all of you. Thank you for your so long introduction about me. Although just these are all the result of my PhD students and other researchers, my colleagues. So thanks to all, first of all, and thanks to the organizer for giving me a chance to deliver this lecture. So the title, as has been already communicated, is now I will open my slide. So to see whether 1 minute. So can you see my slide? Can you see my slide? Hello?
Yes.
Yes, yes, it is visible.
Okay. Okay. So first slide I am showing is that about the title of this lecture, namely it is the ANN based solution. ANN means artificial neural network based solutions of linear and nonlinear system of equations and further interesting challenges. So in this, I am going to actually first discuss about little bit about artificial neural network, although many people know this nowadays. Then general model. Here I will show that actually we have variety of methods for linear and nonlinear equations or system of equations. We have different methods. So this is an alternative method that we can apply to find a solution. So I will show by solving transcendental equations, nonlinear system of, linear system of equations using this method, that is artificial neural network. So then I will go to the interval linear systems, that means linear systems having the interval uncertainty. Those also I will discuss. And finally, solving fully interval linear systems using the concept of ANN. So as you know that ANN is a massively parallel distributed information processor made of simple identical units. Actually, this mimic our brain neurons in mathematical model. So neural network models are extreme simplifications of human neural systems. And similar to neurons, nodes, processors, we have the connections, nodes, etc. in this neural network system. So some of the real life applications of ANN are that many people know. We can recognize handwriting, image compression, traveling salesman problem, stock exchange prediction, biological and other pattern recognition, and further extrapolation and estimation. So basic model of ANN has been actually first proposed by Rosenberg in 1950s. So what we do in this neural network, we have different input x1 to xn, and we have corresponding to these some weights w1 to wn, and then we multiply all these x1 w1, x2 w2, x3 w3, xn wn, and add them and add a bias. So this is your input by. This is simple one node means neural network model, and the final output is Z. So when we have two layers, this is one layer actually, two layer, then we will have the activation function, etc. also. So in this you can see in this slide, the architecture is like this. See, this is your input layer, this is your hidden layer, this is your output layer. So we have in the first figure, feed-forward neural network. Actually, we have two types of feed-forward and feedback. So this figure shows the feed-forward neural network. So where I am showing 2 nodes and 3 nodes in the hidden node and 1 as output node. So we may have hidden layer also more than 1 depending upon the requirement. And here in the next figure, this side, right-hand side, we have feedback neural network. So this is backing actually this arrow shows. So there are procedures to handle this type of neural networks. So as I told that when we have layers, hidden layers, we need to use activation functions. And activation functions may be a monotonic increasing function, nonlinear monotonic increasing function. So here it may be identity function, Gaussian function, sigmoidal function. So sigmoidal functions are of 2 types, that is fx is equal to 1 by 1 plus e to the power minus x, or bipolar, that is fx equal to 1 minus e to the power minus x by 1 minus e to the power minus x. Then we may have tangent hyperbolic function, rectified linear unit, etc. There are other also activation functions. So 2 figures here it is shown that unipolar and tangent hyperbolic function. So this activation function, again, it is by choice or by the experience or expertise which one to be used. So we have learning rules also, because from input to hidden to output, how the signals are flowing. So though we have different learning procedures also. Moreover, we have 2 types of learning, that is supervised and unsupervised. In supervised, we have like, we know that interpolation type, that is interpolation where we know from the 12th class or PSC that we have interpolation, we have xi, yi data. Suppose I have 10 data or 20 data, we can find an interpolating polynomial, etc. So it is like that, but here it is done through activation function and through ANN. That is called supervised, means I have the output and input both. So we want to find the function so that I get y equal to fx. Similarly, we have unsupervised where the output is not known, only the input is known. So 2 types of learning are there, and we have learning rules. We have several learning rules: Hebbian, perceptron, delta learning, window off, winner take, all learning, etc. So I have actually used delta learning rule. This gives better result that I have seen. So with this introduction, let us see how we do in backpropagation algorithm. I am giving very simple, only 1 slide for this. Actually, there are many calculations to show that. So see, I have 2 inputs here, 0.05 and 0.10, and 2 input and 2 weights, W1 and W2. W1 is 0.15, W2 is 0.30. This is just a typical example. So I am just showing how to compute.
So please show your slides.
Pardon?
Sir, we can't see your slides.
Slides you cannot see.
No, slide is showing. No, go to another name, because sir is open to from 2 entries. Okay.
Okay,
So
sir.
for another one, search for another name.
Okay, sir. Okay, sir.
There is another entry.
It's okay. Can I continue?
Yes, sir. Yes, sir.
So net H1 in the first layer, it is computing as W1 I1 plus W2 I2 plus, I told bias will be there, B1. So if we compute this, we will get 0.3775. Now I have used this activation function out H1. This is 1 by 1 plus e to the power minus x to 0.5931. So similarly, I can go net O1, out O1, etc. using. So finally, error is 0.0235 and total error like this. These are standard procedures of backpropagation algorithm. And then we have forward pass, reverse pass. Those I am not discussing. It will take more time to discuss. So, according to our target, that is solution of nonlinear system. So we have different work related to this. So just suppose Simley and Chun in 2001, they have used subdivision algorithm, not the ANN. And then the algebraic equation concept of artificial neural network have been used by Margaris and Golianas in 2012. So like this, we have different methods also to find interval system of linear equations that I had done in 2017. Then some other authors also done, Ning and Kerford. Then two books related to this we have written. That is, one is Concept of Soft Computing, Fuzzy and ANN with Programming. So you can get programming also there in Springer. This is published in 2019. Myself, along with my two students, we have written one book on this. So you can go through that book. And the next one is Artificial Neural Networks for Engineers and Scientists, Solving Ordinary Differential Equation. This is another topic, although differential equation I am not going to touch on this time. So this is published by Taylor and Francis in 2017. Again, I have written with my one of the student, PhD student, this is Smita Mott. So this little bit literature review, let us come to this solution of transcendental equations using artificial neural network. So general model just I have written like this, a1 e to the power x, just arbitrary. A2 log x plus a3 root x plus dot dot dot, you have different functions, different coefficients is equal to some constant. Or this may be your system of equation. So these are the two typical examples how we can handle that using neural network that I am going to see in the next slide. So what we'll do, see, and in general, I can have, pardon? So in general, I can have the model that I have shown that as like we can write A151, A252, dot, 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 A and phi n equal to C. Where phi 1, phi 2, phi n are your functions, is transcendental function or any other polynomial or whatever. Means x square, x cube, different degree of the independent variable. So now the input is x here, input is 1, then this x, you can see the next node is x, and this is connected with phi 1, phi 2, phi n, and the output is f. So I have taken all the weights as 1. So this, if I train this, so this weight is here unknown, this x I want for this equation 3.1. So after training, whenever after training it converges, then this x will give the solution of this equation. So starting with some arbitrary guess value that we do in typical numerical methods. So if you see now, the first example that I told that a1 e to the power x, a2 log x, etc. So here I can put these functions e to the power x, log x, root x, sin x here in the hidden layer. And this 1 to x, I have this x as the weight, and here 1, 1, 1. And those coefficients a1, a2, an are here from hidden to output. And this 1 and this 1 are the bias. So when we start this training of this neural network with some guess value, so when it converges, it gives the value of your required value of x. So now I will show by simple example. So let us consider a transcendental equation like this, x square minus log x is equal to 1. So how will you do that? See, which has roots, suppose we have calculated from other known method, traditional numerical method as 0.45 and 1. So let us target these two roots, whether we can get from neural network method. So what I am doing now, here it is one bias. This x is the weight that I want actually, the solution of this. So here you see x is connected to x square and log x. These are the two functions x square and log x. These are connected like this. And this x square and log x are connected with output node. And this 1 and minus 1 are the coefficient of these functions. Plus 1 for x square, minus 1 for log x. So now using that delta learning rule and backpropagation algorithm, we can train this. And when again it converges means at each iteration, it will give some value in the output and will find the error at each iteration. What is the error between this and the previous iteration? So as we do in numerical method. So after converging, whatever value of x comes, that tends to your root. So you can see our result now. See, these are the, and it depends upon the error that you are taking, as we do in typical numerical method. See, if it is 10 to the power minus 1 error, then the value of x, this we have started for the first root, 0.1, suppose guess value. So when I take 10 to the power minus 1 as the error, so 0.2413 is the result. So similarly, we have decreased this error up to 10 to the power minus 10. And see, this is the actually result that we should get. I already told that 0.45 is the solution from the numerical method. So we are getting after 9,402 epochs, means iterations. So it takes time, although, but if it can solve the problems which may not be solved by typical numerical methods sometime. So this converges to the first root 0.45. Just for the second, we started with 0.51, and again you can see the right side table. So it is at 10 to the power minus 1 error, it gives 0.51, 10 to the power minus 2, again 0.51, it is not changed. 10 to the power minus 3, it is 0.9517. Similarly, I go up to here 10 to the power minus 11. I had to go more iterations compared to the first, and then I get the convergency as 1. So I get both the roots as the this iteration proceeds. So this is one simple example. So see, I have another example for the simple equation x e to the power minus x square is equal to 0. So here you see, if one uses this Newton-Raphson method, that is the standard method that we use in general to solve this type of equation. See, if I take the initial guess as 1, x is equal to 1, so it is not converging. You can see this figure, left side, the top one. And we know the root is 0 actually, so it is not converging. But if I use this ANN method that I have already discussed, with the same initial guess, see it converges to 0. Similarly, for the second guess, suppose I take guess x is equal to 2, again it is not converging, but if in case of ANN method, for x equal to 2 starting value, it again converges to 0. So this is an interesting alternative method, I will say, to solve this type of equations. So now I will go to the system of transcendental or linear equations. So see here, the general form of this is given as we write the system of equation as A1151 plus A1252 dot dot plus A1 and phi n is equal to C1. So this so this is actually dot dot, some version problem is there. Anyway, so next equation is A2151 plus A2252 dot dot plus A2 and phi n is equal to C2. Similarly, nth equation is AN1 phi x1, AN2 phi x2 dot dot ANN phi xn is equal to Cn. So this is the system of equation, and how we can convert this to ANN architecture. What I have done, you see this first layer, this one is bias, and first layer we have x1, x2, xn. Those are the unknowns with weight x1, x2, xn. And here, when I have A11 phi 1, so I have taken 1 as the weight. When I don't have this x11 phi x2, I don't have A11 phi x2. So this is 0. Means with x1, no connection with phi x2. So similarly, 1 and 0s are placed for the weights. And similarly, this A11, A12, etc. I placed from phi's to the output. So with this, so after arranging like this, starting with these guess values, if we run that program using that again delta learning rule, when it converges, then we stop and we may get the solution. So now take the again a simple system of equation as y minus log x is equal to 0 and x plus y equal to 1. And we have seen that this has solution as 1 and 0. 1 and 0.
Excuse me, Dr. Chakraverty.
Yes.
I am sorry for interrupting. So the lot of participants. Dear participants, the slide is visible. Please go for another option. Another option of the speaker, Snehashir Chakraverty. Pin on another option. That option, the slide is visible. Okay. Dear speaker, carefully. Another option is there.
Another option means in email they have sent or what?
No. The participants are asking they are saying that the PPT is not showing.
Okay.
So I think they are pinning on your video. I think they are pinning your video. They are saying in video, but not the PPT. So for participant, I am saying that. So go for another name of the speaker, Snehashir Chakraverty, and pin on that option.
Where it is?
No, I am not saying you. I am just informing the participant. Participants are saying that they are not.
Oh, okay. You are telling to the participants. Okay.
Participants. Many participants are sending the message. They are not seeing the your slide.
Okay.
But the slide is visible. Dear participants, go for another.
It's okay. I think it's okay now.
Okay.
Can you see? Everybody can see?
Yes, sir. Please continue.
Okay. Now continue. Okay. Sorry for interruption.
No problem. This happens in online mode. These are the.
This is the problem.
No problem. I totally understand. No problem. Anyway, so that I was discussing system of equations. Already, in general, I told. Now let us take one example. Simple example as y minus log x is equal to 0 and x plus y is equal to 1. So in the first layer, we have put the x and y, the unknowns. In the next layer, I put the functions x, log x, and y. And you see the connections. Connections from 1 to x are x is x and 1 to y is y. So these are the target value, means the weights I have to find here. And see from x to x, in this equation, first equation, no x square is there. So x to x is there. Sorry, x to x is there, so it is 1. But I don't have x to y. XY term I don't have, so I have taken 0. In this way, 1 and 0s are placed for the weights between this layer and this layer, means first layer and second layer. Similarly, from second layer to third layer are the coefficients. For x, coefficient is +1. So like that. For log x, coefficient is -1. You see here, -1 is this. Log x to f1, it is -1. So in this way, we put all these coefficients and these weights. And from this first layer, this x and y, in the computation, we find this x and y. So when it converges, these weights x and y, that will be your solution. So now I can see I can show you the result. So I have already told that this system has a solution as 1, 0. So if we go on with this computation, so this is the plot. This is 0 and this is 1 as the computation proceeds. So around 1500 it converges. Now I will go to solving fully interval linear system of equations using the same method ANN. So till now what we have done, we have solved the linear system of equations where it was all crisp or exact. Means we did not have any uncertainty. Now I will introduce the interval uncertainty, and for that we need to first understand what is interval. So that we know standard interval, preliminary is now into standard interval we define like this: V lower, V upper, lower value and upper value, where this V lower is less than V upper and this V belongs to R, real line. So where V lower and V upper are lower and upper bounds of the interval respectively. So now if I have two intervals, V tilde and W tilde, as V lower and V upper, W lower and W upper. Okay, so V and W, we have two intervals. So how we add? Addition is defined by this. Means V lower, V upper plus W lower, W upper will give you lower you can add separately, and upper you can say add separately. Similarly, subtraction, in the subtraction it will be reverse. V lower minus W upper and V upper minus W lower. These are standard computation. You can see any paper. I have also published many papers on this. And then multiplication D lower B upper into W lower into W upper. See, I cannot have here directly the lower and upper. I have to multiply each combinations. So after multiplying, so this is minimum of all these combinations and maximum of all these computations. So then I will get lower bound and upper bound. Similarly division, we have minimum of all the combinations, maximum of all the combinations. And here one condition is there that this W lower and W upper should not be 0. This is one assumption or condition. So because I am going to solve fuzzy interval linear system, so this is the form of the fuzzy linear interval system of equation. Where you can see that I have written as P11 tilde, Z1 tilde, plus P1 tilde, Z2 tilde, plus dot dot, plus P1n tilde, Zn tilde is equal to P1 tilde. This tilde designates the interval uncertainty. Next, each of these P11 tilde, P12 tilde, it is better to mute by the participants. Please mute. Anyway, so these tildes are designate the interval uncertainty. So remember, all these tilde means each of these tilde. Suppose I take Q2 tilde, that means it has interval. It is written in interval form. That means Q2 lower and Q2 upper. So this is a very complicated system. It is not easy to solve means directly, because it depends upon what is the behavior, means what is the behavior of this interval, means whether it's a plus minus is there, and many things are there. So I'm not going on to these details. Only my aim here is to solve this interval system of equations by artificial neural network. And moreover, you can say this why it is fully why I have written. Some of the authors have solved. See, this I can write as a standard form that we know from linear algebra, that is Ax equal to B. Where A is the coefficient matrix, A is the unknown vector, B is the right hand side known vector. Here you see, if I write the coefficient vector, A is the coefficient matrix having all the elements as intervals. Similarly, if I write the B vector, where all the elements of that vector is all intervals. So people have solved using, suppose B vector is not uncertain, only A is uncertain. This is one case. Second case is A is fixed, means exact, and right hand side vector is uncertain. So this is the second case. And the third is called fully. That I am going to solve here is all are uncertain. That is uncertain means interval uncertain. So this problem I am going to solve by ANN method. So that means, see, I told already that n by n full interval linear system equation I can write as A tilde x tilde equal to B tilde. So I have the form of the equation like this, A11 lower, A11 upper, like that, A1n lower, A1n upper. So this coefficient matrix have all elements as intervals. The unknowns are in interval form. Right hand side vector is also in interval form. So this, sorry. So we have different cases for this, because I told, because if all these are positive, means these elements xi lower and xi upper all are greater than equal to 0. That is case 1. Case 2 is when solution this xi lower and xi upper less than equal to 0, and xi plus 1 lower and xi plus 1 greater than, means combination. And third is all are negative. And fourth is mixed type. So there are 4 type of these things, but we will consider here this only first one, I think. So the algorithm, so there are many calculations, many computations. It will take much time. So just I have written the algorithm. So step 1, see, although this is the first time we have done, as per the literature, I could not find any paper on this that fully interval linear system equation have been solved by ANN. I could not found. So this is the first time we have done. So that is why you can say that initial work. So we have used I will not tell it is an efficient, but I can find a solution at least. So we convert n by n fully interval to 2n by 2n linear system of equations. Select the precision tolerance, learning parameter, random weights, this. Then calculate yi is equal to ai tilde transpose xi x tilde. Then find the error ei. After that, calculate the sum squared error. And then this iteration process you have to use. And after convergence, you print x tilde. Although I have told very in short, there are many things inside that. So these papers are published. You can go through, if you go to the Google Scholar, you just type my name, you will get these papers published also. The details are there if anybody is interested. So anyway, so this theorem also we have developed for the convergency. So this eta actually learning parameter, where this 1 by n into max of this. So this also we have proved because the main problem is with this learning parameter. So this learning parameter lies, if it is lies between these two bounds, you will get the converged solution. So let us take one example. That way you will understand what is actually what we are doing actually, although you may not understand how it is computed totally till you see those papers. Anyway, so let us consider an example of simple 2 by 2 interval linear system equation. I have referred my own paper that is solved by other method, not through ANN. It is through other methods. I have done with other PhD students. So this is simple 2 by 2 equation. You can see this 2 by 2 coefficient matrix is in interval form. First element is 4, 6. Then in the first row 5, 8, 6, 7, next row and 4, 5. I have the unknowns as x1 lower, x1 upper and x2 lower, x2 upper, and right hand side I have the vector elements also in interval form. So this solution in interval form, by that this I already told my paper I have referred, the solution are found to be this. This is the reference of that paper. It is Fundamental Informatica. There we have published in 2017. So you can see there the solution. This is a different method in this paper. So I am going to use this problem by ANN. So as same pattern, same architecture type that we took for the linear system of equations. So I told that this 2 by 2 system I can write into 2n by 2n system, that is 4 by 4 system. And then we input in the ANN, and the solution I am writing here, lower and upper bounds of the interval solution. So you see, this is our previous paper. The solution was x lower and x upper as the first x1 as 3.9286 and x upper is 4.0385. And x2, that means x2 lower and x2 upper are 4.8571 and 5.3462. So now I told that again ANN gives different result as per your accuracy. So if I take error as 0.01, so it is giving for the first one 3.9286 as 3.9899. Similarly, you can see the other values. If I take error as less than 0.0001, so it comes 3.988992, 3.9348. Similarly, if I reduce the error more and more, if I go to the last column, this error, so x lower is 3.9286, and you see this paper. So 3.92686 and 3.9286 are matching. Similarly, 4.0385, 4.0385. See, after so much reduction of this error. Similarly, 4.8571, we got this. So we got the solution by ANN as we got this by this paper Chakraverty 2017. We did by some exact type of methods, not by ANN, but these are the result from ANN. So in conclusion for this is that connectionist learning-based method, sometimes ANN is also called connectionist learning-based method, has been developed here to solve linear, nonlinear polynomial equations and system of equations. Single and system of coincidental equations have been investigated based upon the artificial neural network. I already told the example problems. I also showed the efficacy and powerfulness. Concept of uncertainty in terms of interval I have shown. There are other types of uncertainties also. We have not handled those things. We are in the process of those. And using concept of neural network, 4 cases depending upon behavior of uncertainty, I have not discussed here anyway, so that can be done. And the example problems have been solved. So these are the references related to this. So now, so as I wrote in the second part, means the third line of my title, that's some interesting application. See, actually, I could not found many papers on solving traditional mathematical problems like solution of differential equation, solution of eigenvalue problem, solution of linear and nonlinear system equations. So because we had variety of plenty types of methods depending upon the type of the problems. So maybe people have not targeted that, but I found that sometimes some method for some particular type, it may fail. I have already shown about Newton-Raphson. That's why I actually already guided two students. One worked on differential equation, another has worked on linear and nonlinear system equations and eigenvalue problems. So see, these can be solved very well by these methods. And another thing that ANN actually, see, and these are, ANN actually should be used in general when you don't have the output. Means output means you don't have the mathematical model. So in these cases, what happened, I have used the unsupervised learning because I don't know the solution. That is why it is unsupervised. Suppose I want to solve linear system equation, I don't know the solution. I have to target that. Another means application is when I have the input and output and I want to train like fitting. Fitting means that interpolation or extrapolation or whatever. So what, suppose if I take now a little bit, just I will give the idea of this problem that I have already done, although few of them. I should just explain in very short about this earthquake problem. What happens, see, when the earthquake, see, I have time for 10-15 minutes. I have time for 10-15 minutes. Hello?
Yes, sir. You may continue.
Okay. So see, when any earthquake triggers somewhere, so their wave propagates near to the structure, and then these waves propagates to the building or bridge or whatever. So now these earthquake waves transfers to this building. So now this is a soil structure interaction problem. And till date, as per American Society of Civil Engineers, there is no model to show that how these waves travel to this structure. Okay, so this is very difficult till it is not done. So what I thought actually, why not I take these earthquake waves or earthquake data, that time, and this is the earthquake data, there's acceleration. If you see the below figure, this is time versus acceleration with some particular earthquake real data it is. So if I take the input for this earthquake data, and if I have some equipment here that can measure the displacement of this building, so there should be sensors. So if I have the output here for the building dynamics or building displacement, and here input as the seismic data. So if I can play with that, if I can train with that, then for any future earthquake, what type of displacement this building will have, so that building will be safe or not, so that we can diagnose. So see, this is a multi-story building in the right-hand side I'm showing. So this earthquake suppose triggers here, and then how this building will behave. So it is very difficult to see by any other mathematical model because we don't know how these waves transferred to this building. So I did few using different earthquakes from Chamoli, the Uttarkasi, and all these data I took from IIT Rourkela earthquake department. There I got the data, and I trained this using all these with the building and all. So if you see, okay. So that I will. So I have done. I am not showing the results because it will take long time. So I will go to the next problem that I was telling. I'm just giving the idea now. Actual main thing I have already presented. So here you see this is a simple mass order differential equation, and second one is also differential equation. These also we have solved by ANN, and you see the convergency, etc. And this is already published in Neural Computing and Applications. So differential equation solution also we have done by neural network. This that I was in the below. If you see here, I have actually used that earthquake one that I was showing. So the equation is actually mx double dot plus cx dot plus kx equal to m a double dot. Here a double dot is nothing but your acceleration due to the earthquake. Here I can look at the cap. If I have trained, there are many things M, A, C, mass, etc., etc. And C for I have done from 2-story to 10-story to 5-story, etc. If you see the comparison of the actual and ANN, so it is more or less matching. Similarly for earthquake also, so see the data that I got and computation from the ANN and exactly experimental data, these are more or less are matching and significantly matching. I hope actually, see, we have worked on these many things because, see, suppose an earthquake occurred for maybe 2 minutes. So, warning system also the engineers can develop. If suppose up to 1 minute I have the data, what will be the latter 1 minute? The means the response of the building. So within 1 minute we can know that what earthquake force will be there or acceleration will be there, so that the building will be safe or not, we have to evacuate or not. So that although these are not means my area means to make or to develop the warning system, just my area is to simulate all these things. So I got it. These are all published. Here it is given in the below there, or you can go to my Google Scholar citations. There you can get all these papers. So related publications means the linear and nonlinear systems only. I'm not showing the publications of the earthquake or differential equation. So these are the journals, few, and these are the book chapters. And I should point out that these are all done by my PhD student, and he should have the main credit for these computer science, for these methods, although idea I gave anyway. So that's why lastly I acknowledge him, that is Dr. S.K. Jeswal. He just defended his thesis, and he has obtained the PhD degree. So with this, I will close this, I will finish this, my presentation. So if you have any simple question, then you can ask if you want. Thank you very much.
Thank you, Professor Chakraverty, for a nice presentation.
Thank you, sir. Thank you.
So, dear participants, as you can see that Professor Chakraverty has very clearly demonstrated from the introduction to the artificial neural network to the solutions of a single transcendental equations, solutions of system of transcendental equations, and also solutions of fully integral linear system of equations using artificial neural network. So you may have some questions before I ask on to you. I have very simple questions to Professor Chakraverty.
Yes.
So in your artificial neural network models, so always you are using some weight.
Hello?
Always you are using some weight in your model.
The other should be muted, otherwise it is disturbing. Other should be muted when he is asking question. Yeah. I cannot hear when I am using ANN, then what you ask? Hello? Hello? What is your question?
You are always using some weights.
Weights, yeah. Weights, yeah.
Do the weights have some impact on the convergence of the solution?
Yes. See, I am telling, I have shown around 2-3 types of problems. You leave that last one, that earthquake and all. If you go to the system of equation or whatever for the that linear system of equations, there the weights are the unknowns, x and y. Because in system, suppose I take semi-quadratic equation, x square minus 3x plus 2 equal to 0. So here x is the weight that I have to find. Here it is, the problem is different. Here I am training to convert, to get the convergency of the weights in terms of x. I know the coefficients, I know the right hand side element or the vector depending upon the system. So here weight is Weight we don't know. Weight we take, suppose Newton Raphson, we start with some guess value or not. So like that, here we have to start with some guess value and slowly we go on with the neural computation and see whether it is converging or not depending upon the accuracy. So there we target for the weights. But in the earthquake case, I have input and output. I told input and output I have. There also we are converging, but there we are seeing the convergency with respect to the output. You're understanding? But here in this system of equation, I have only input and the coefficients. Understood? I don't have the value of x, sir. That is our target. You understand? I hope I have cleared.
Okay. And then in case of supervised learning, this may be very good. The result is giving very good. But if
system of equation,
unsupervised learning,
the system of linear equation and system of equation, it is not supervised. It is unsupervised.
Yes.
Supervised is for earthquake problem.
Okay. Okay. Thank you.
I have one question. I have one question.
Okay.
Professor Giri.
Okay.
So this is a very nice presentation and very easily understandable. I think that a lot of participants are benefited from your lecture.
Thank you very much.
But initial 2-3 slides, I have skipped that one. So my very primary question is, AM is a iterative method or direct method to solve the system?
Hello. Not last sentence I could not hear.
This method AAN as a direct method or iterative method?
No, these are type of iterative method, not direct method. Iterative method.
Okay, so what is the advantage? Means with respect to the speed or the rate of convergence, it is faster than Newton-Raphson method to a single transcendental equation.
See, those are. See, I told that nobody has done till now, at least for the that interval linear system equation.
I am
theoretical work till date has not been done. We are on the process of doing that. This is now only computation and simulation we have done. Okay, so and the advantage you are telling, yes, advantage is there. I showed by one example about Newton-Raphson that sometimes Newton-Raphson fails depending upon the function. Then the same guess value I started with ANN and it converges. Two cases I have shown.
Okay. That means we can say that this method ANN is applicable for almost all kind of problems, no?
It should be, because all kind of problems I have not solved till now. Whatever I have solved, I have said that. Okay, I cannot point that all problems can be solved. I hope it can be solved.
Actually my question is it identified which type of problem can be solved by NN or which kind of problem is not suitable or not possible?
See, we have solved up till now linear system of equations. Then we have solved eigenvalue problems. Even integral finding integrals also we have solved. So the differential equation we have solved.
Okay.
So like that. See, suppose I tell
in numerical method, two things are important.
Yes,
one is the error and the rate of convergence.
Yes, that is important. That is important. But those are when one go, we have to see, we have to work more on that. Okay.
So, any other questions from the participants?
And another important issues for interval arithmetic. No, you are considering only the closed interval, or it is also applicable for the open interval?
No, it is closed interval. Always interval means here it is closed interval.
But during the computation, during approximation, no. So upper limit or lower limit may reduce or may extend during rounding of error. Rounding.
Pardon again.
Computation, no. Suppose your interval is 2 to 3. Okay. And after certain iteration,
I cannot hear the question. Yeah.
No, during computation, numerical computation, there must be a rounding of the arithmetic or computation. Rounding must be there. So during round or when rounding is applied in the interval, that means the upper limit may becomes the more than the actual value, or it may be reduced to the actual value. No, hypothetically it is the 2.5, but during rounding, during computation, due to rounding, it may become say 2.51 or 2.5001 like that, or it may be say 2.499 like that. So if it reduces 2.5, it is expected that the exact value is 2.5. But during due to rounding, it's becomes a less than 2.5. Then it is an open interval, and due to rounding, it becomes say 2.5001. So it is the exceed the upper limit. So this type of problem is there in the interval
Yes,
computation.
yes. See, linear that interval is having many. If you can see in the Google, you give interval system of equation. There are many work going on. Till date, it is.
It is very old problem. No, interval arithmetic or system of equation very old. I think there is a famous book
But
written
till now,
by.
till now also people are working in many ways. Means
Yes.
many ways till now also. Professor
So
Kanho
asking
bring
about what is the advantage of AN
which
or
one?
this kind of system. I am asking regarding the advantage of AAN to solve interval system.
Okay.
Because due to that kind of possibilities are there. So I think this type of uncertain cases may be avoided in AN or
Yes.
like in other method.
See, again, I'm telling you, people are working on different method, different using suppose B vector as not interval. A is fully interval is work you can get very less. When left, right, all are intervals. Okay, so but in neural network we can handle that. So that is the main advantage.
Different variations are there, but major problem is on interval arithmetic that one, leave the rounding process actually. So it may be becomes an open interval. The interval may be excess the original interval like that. This I think this can be handled.
Excess means I could not follow. Excess means
more than the actual value.
No. How you know the actual value? If you have
Suppose
linear
that
system, no. If you have linear system equation, you don't know the solution. How you know the actual value?
no. I am asking regarding. So if you calculate analytically, the system of equation we are solving analytically. So the analytical solution is the 2.5. The upper bound of say x1 is 2.5.
Okay.
But in numerical process, when you are
No. 2.5 means you are targeting crisp equation. Not interval is not there.
No. I am considering I am talking about the interval.
So
Okay.
how you get one single number 2.5?
No, not 2.5. I am saying that this is the upper bound. Upper bound of an interval.
Okay. 2.5 is the upper value. Yes. Okay.
So suppose the actual answer is 1.5 to 2.5.
Okay. Fine.
If you calculate, if I go using the any analytic method. But if you apply any numerical method, then what happens during certain rounding during the process, during due to rounding of the numerical numbers, it may become say 2.5001. Say, no, that is the upper limit is more than say actual upper limit.
That may happen. That may happen. That may happen in any problem, not only interval. If you find suppose 2.5 as this also, you may have result by numerical method 2.499.
So that's why I'm asking. That's why I'm asking.
It is not about interval. In crystal, same thing.
No. Yeah, this I am asking whether the any kind of protection is applied or not to protect the upper
There,
limit.
how interval? Crisp is not there. So how you can expect for interval? Interval itself is very
If we apply the analytic method, we are if we not considering the rounding.
If you have 100 by 100 system, can you solve by analytical method?
No, this is another question. That's why numerical method is. That's why the numerical method is acceptable.
Yes.
Okay, even it has error, even then it is acceptable. But I am asking you because you are working a lot on this area. So is there any protection rules or any say termination condition or we can protect it?
Those are there. I'm telling you, those are there for interval system of equations. That is separate. Those are there. But if you are telling about the neural network convergency, how that is not done. That is I'm telling. For interval, every interval, fuzzy, all are there. Those theorems, those are all are there. But with respect to neural network, if you will say that convergency, how those are not there till now. That I take.
Thank you very much for your nice presentation.
Welcome. Thank you. So any other?
Okay.
Professor Giri?
Okay. Any other comments from the participants? Quick comments or? Okay, I think.
Hello, sir.
Okay. Thank you.
Sir, I have a question.
One question.
Hello, sir. I have one question.
Okay, okay. Carry on.
Sir, is an imprecise system of linear equation can be solved by eigenvector method?
Means your question is whether eigenvalue problem can be solved by ANN. That is your question?
No, sir. No, sir. An imprecise system with in interval environment can be solved by using eigenvector method.
No, you can solve, but that we have not done till now. You can solve. See, whatever method you have for other numerical method, whatever, we can mimic in that ANN. But we have to model the ANN like that. But I have not done that till now.
It's okay?
Thank you, sir.
Okay. Okay, since there is no more time,
okay.
So let's conclude this session on the behalf of organizer as well as on behalf of every participant here. I would like to thank Professor Chakraverty for an interesting presentation and stimulating lecture. Thank you, sir.
Thank you. Welcome. Thank you. Okay, thank you very much for giving me the opportunity. So now I can close?
Yes.
Okay, sir. Thank you.
Yes. Okay. Thank you very much.
Dear participant, now we have the technical track 5 parallel session. So interested participant go to the so here only the session in this room, the session 11 session 11 is in this room. Session you have to find room number 1 and room number 2. The participant go to the respective room. Participants, please move your mic. Please move your mic. Participants, please wait and move your mic. This is our parallel session. So, participants are all here and here. So, please wait. So, please move your mic. So, please mute your mic. Professor T.K. Pal, sir. Can I start this session? Professor T.K. Pal, sir.
Yes.
Shall I start the session?
Some disturbing sound is coming. Okay, now it is okay. You could start.
In this technical track number 5, in this room, the session 11 is going on. Sir, in this session, there are 9 participants assigned. One participant from previous session, due to the network fault, he could not present their paper. On behalf of committee, we are informed that join in this session. So in this room there are 10 participants. Please continue the session. I want to introduce previously Professor T.K. Pal. He is our senior former professor from our department. I already introduced him in previous session. Now I introduce shortly Professor T.K. Pal. Is a retired professor in our department. I also student of him. I thanks for that. I got chance to learn from him. He still this age is actively connected with the academic activities and different social activities. I also convey our thanks for that. Professor Pal, please take this session as a chairperson. Please, sir.
Thank you, Dr. Giri. We are very glad that we are in the 11th session. It is in this is the third day and last day of the 3-day international webinar on role of applied mathematics in present global crisis. 9 paper. Now I have learned that one more candidate will present his paper. So after all, there are 10 candidates who will present papers in this session, and we have been allocated only 1 hour. So each student will get only 6 minutes. So I shall request every participant who will present their paper. So please take care to maintain the time because it is a very short time you have to present your paper, and I beg pardon for that on behalf of organization. You will not be able to present your paper. You have to present your paper very hurriedly. Within 6 minutes, you have to finish your lecture. Anyway, just you introduce yourself. What is your designation? You must tell it because in our list we are not getting any designation, whether you are a student, research scholar, or professor or teacher. Nothing is mentioned here. So before starting your talk, please introduce yourself and mention your designation. There are 10 candidates here. Lipika Shaw, Makfura Parveen. We should have whether you are present here or not. Let us see first. Lipika Shaw is present. Is you present?
Yes, sir. Present, sir. Yes, sir.
Okay, thank you. Makfura Parveen. Makfura Parveen from Kingston School of Management and Science. Mr. Parveen, are you here? Okay. Then third candidate, paper number is P069, Muhammad Sadiqur Rahman. Muhammad Sadiqur Rahman, are you here?
Yes, sir, I am here. Yes, sir, I am here.
Okay. Thank you. Then Prashant Pal.
Yes, sir, I am here.
You are here, you are present. Then Rajkumar Bera.
Yes, sir, I am here.
Okay,
yes, sir.
Here. Then Shamoli Ghosh. Shamoli Ghosh. You are from Vidyasagar University. Shamoli Ghosh, you must be present. Shamoli Ghosh. Subroto Panja. Subroto Panja. Subroto Panja, where are you? You are also from Vidyasagar University. Maiti.
Yes, sir.
Sunil Maiti is present.
Yes, sir, I am
Thank you.
present here.
Okay, okay. And Vishnu Narayan Mishra. Vishnu Narayan Mishra. From Amarkanto, MP. Vishnu Narayan Mishra. Who is present? Do you hear me? Vishnu Narayan Mishra. I don't know. And 10th participant, what is the name? Dr. Giri, Raghunandan Giri. Who is the 10th participant?
Munir Nabi. Munir Nabi. Munir Nabi. Paper number 111. Not assigned in your list. He is not attend a previous session, so we give chance him or her. Munir
Okay,
Nabi.
he will get chance. What is his name? Please mention again. What is his name?
Munir Nabi. Kashmir University. Central University of Kashmir.
What is the spelling of his name? Kashmir.
Munir Nabi.
Munir MU?
MUNER.
Okay, MUNER. Munir
Nabi.
Title? NABI.
Nabi. BI.
Okay, he is present.
Munir Nabi present है.
Is he present?
Munir Nabi is present, but your audio is not visible. Munir Nabi, your audio is not visible. Is here over here.
Present. So what about the VIII candidate, the Shamoli Ghosh, Subrata Paja?
I think they will come.
I am here, sir. I am here.
Subrata also present.
Shamoli Ghosh.
Shamoli Ghosh.
Shamoli Ghosh is present. Okay. And what about Subrata Panja?
He also
Yes,
present.
sir, I am present.
Okay, he is also present. Okay. Then only one candidate I have not got. Oh, two candidates. Vishnu Narayan Mishra and Makhpura Parveen. Only this candidate, I think they will join later. Okay, let us start. I call first who will present the paper. Paper number 67, P067. Name of the presenter is Lipika Shaw.
Yes, sir.
Lipika Shaw.
Yes, sir.
Yes.
Can I present now?
Lipika Shaw, please introduce yourself. What is your designation? Then you start your presentation and keep in mind that within 6 minutes you have to finish your talk.
Okay, sir. Myself, Lipika Shaw, and I am a research scholar of Vidyasagar University.
Okay, you are a research scholar. Okay. Okay. Carry on.
Sir, I am going to present my slides.
Hi.
Sir, is it visible?
Not yet. Yes, now it is visible. Carry on.
Yes, sir.
Go to full screen mode. Lipika.
Okay, sir. Yes, sir.
The title of the paper is Multi-Objective Solid Location Allocation Model
for
for
research distribution
under uncertainty.
Yes, sir.
Okay, start.
This is the basic outlines of my presentation: introduction, literature review, preliminaries, notation and assumptions of our model, mathematical model formulation, and solution procedure, and discuss about the numerical example. Then after that, the conclusion and future research scope, and at last the references. At first, we know about the location allocation problem. Location allocation problem is a major part of operation research, which is used to locate a set of new facilities such that the transportation cost as well as the transportation time is minimized and also maximize the demand forward. It is basically used to locate the some facilities like warehouse, distribution centers, and communication centers. This is the basic components of our location allocation problems, like facilities, demand, and supply. Depend on the facilities, location allocation problem can be classified into single facility location problem and multiple facility location problem.
Now, this is the basic definition of solid transportation problem, which is also an extended case of tactical transportation problem by adding in extra constraints like convenience constraints. In this paper, we go through about the maximal covering location problem, as in many real-life situations, the decision maker and the existing facilities cannot satisfy the demand of the customers. So, the concept of maximize covering location problem is introduced. As many real-life situations, we have to handle many objectives, so the location allocation problem can have the following objectives. And we have considered here an uncertain environment, as most of the problems would take place in the situation where the goals and the constraints or the consequences are not known precisely, or they are in imprecise nature. So we take the environment as an uncertain environment. This is the basic literature review related to our paper. As we consider here is an uncertain environment, we take some parameter like the demand, supply, and capacity as a type 2 fuzzy sets. The type 2 fuzzy set is an extended case of type 1, and the basic difference of type 2 and type 1 fuzzy set are that the membership function. The membership function of type 2 fuzzy set are also a fuzzy number between 0 and 1. This is the basic structure of type 2 fuzzy set. Now we know about the secondary membership function of type 2 fuzzy set. The secondary membership function of type 2 fuzzy set is the vertical slice of mu of a tilde x comma mu, and the domain of the secondary membership function is known as the primary membership function. Here we take a triangular type 2 fuzzy number, and this is the secondary possibility distribution function of type 2 triangular type 2 fuzzy number. As the type 2 numbers are computationally very hard, so we have to reduce the type 2 fuzzy parameters into a type 1 fuzzy parameters. We can done this by CV reduction method. This is the possibility distribution of Xi1, which can be obtained by optimistic CV reduction method. And this is the possibility distribution of Xi2, which is obtained by pessimistic CV reduction method. And this is the possibility distribution of Xi3, which is obtained by general CV reduction method. This is the basic notation and assumptions of our model. We take here I is the set and indexes of the relief camps, as we consider it is.
Skip.
Okay,
Next result.
Is it okay?
Okay.
This is our proposed model, which has three objectives. The first two objectives is the minimization function, and the third objective is a maximum function. In the first objective, we have considered the total cost, which is a subtotal of the total convenience cost and the setup cost. And the second objective function is a minimization of the total convenience time, including also a loading time of the jet distribution sector of each item, and also the unloading time of the item relief camp of each item. The third objective function is the coverage function, and in this problem we try to maximize the cover of the demand of the function. And this is our constant. The first constant shows that the amount of shipping amount must be greater or equal to the demand of the each relief camp. The second constant shows that the ability of the each distribution center must satisfy the must be greater or equal to the total transportation amount. These are our coverage constants, and this is the feasibility condition of our problem. In our proposed approaches, we first converted the type 2 fuzzy parameter into a type 1 regular fuzzy parameters by CV reduction method, and then used the critical value approximation, and then converted the problem into a Cripps problem, and then solved the problem by three different approaches. One is novel approaches, second is nutroscopic compromise programming, and third is fuzzy topsis method. Here we consider a real-life based numerical example, which is a post-disaster problem, and then an NGO want to set up the two distribution center and three relief camps. Here the location of the distribution center are taken as a variable, and these are the input data, and this table refers the cost per unit distances. The table to describe the fuzzy and defuzzified demand of each disease. The third table the fuzzy and defuzzified supply of each disease. Then the loading time and unloading time. And after solving the three methods, we get the optimal solution, and the optimal solution given the following table. And by we getting that, the nutroscopic compromise programming gives us the better result among the three results. Now conclusion. In this paper, we try to make a connection between the general solid transportation problem and location allocation problem. And in this paper, we find the optimal location of the distribution center so that they can minimize the time as well as the cost and also maximize the coverage. In this paper, we use the quadratic function for truth and indeterminacy membership function so that we can get the better satisfaction, the degree of satisfaction. And we solve the same problem by 3 different techniques so that we can get the better result and compare with them. These are the future research scopes. As we did not consider the concept of redistribution here, we can also the concept of reallocation in our future work. These are the references. Thank you, sir.
Deepika, very good presentation. Within this very short time, you have presented both the paper nicely. Thank you very much. We cannot have a question here. Okay, thank you. Deepika, thank you very much. You go on carrying your research. Good paper. Next.
Sir, I can hear clearly.
Huh?
I can hear clearly, sir.
I am saying that it is a good paper. Good paper, you carry on your research.
Thank you, sir.
Your presentation is nice. Thank you. Next, I shall request Muhammad Sadiqur Rahman. He is from University of Bardhaman.
Okay, sir. Okay, sir.
The title of the paper, title of your paper, as I see, on type 2 interval number and its application in inherited control. Please start.
Sir, the PPT is visible. Sir, is the PPT visible?
No. Yes, now it is visible. Now it is visible.
Myself, Muhammad Sadiqur Rahman, a research scholar of Department of Mathematics, University of Bardhaman. Now I present on type 2 interval number and its application in inventory control. These are the outlines of this presentation. To formulate the new mathematical models of real-life decision-making problems like economic model, bioeconomic model, engineering design problem, etc. under uncertain situation, the imprecise parameters are generally presented stochastically or by fuzzy set or interval number. In stochastic representation, imprecise parameters are considered as random variable with appropriate probability distribution function, whereas in fuzzy representation, the imprecise parameters are presented in the form of fuzzy set with proper membership function or fuzzy number. On the other hand, in interval representation, a imprecise parameter is represented in the form of interval. In first representation, there arise questions regarding the choice of probability distribution functions or selection of membership function or type of fuzzy number. So it's not an easy task for a decision maker to select the appropriate probability distribution or membership function or type of fuzzy number. Among the representation, the interval representation is simpler and more efficient. However, in reality, there are several situations where to present an imprecise parameter in the form of interval, the selection of both of its bound is a formidable task. For example, in case of the cost of various commodities in developing countries, often to represent an imprecise cost in the form of interval, we problem to fix the bounds of it. Here, some questions may arise. Two fundamental questions are: firstly, how to handle the situation if cost exceeds both of its bounds. Secondly, how to handle the situation if cost never attains either of its bounds. if we ignore both of the question, then we have to face more uncertainty as well as major error in the optimal solution. So we can't ignore either of the questions. To overcome this problem, by considering the flexibility instead of fixity of both the bounds of an interval, we try to introduce an alternative of interval approach. This approach is named as type 2 interval. The concept of type 2 interval was first introduced by us, which was published in the International Journal of System Science of Oceanology. The proposed work was developed with the help of some articles and books. Among them, here listed some of Moore et al., Ramos et al., Swang et al., etc. Now we define what is type 2 interval. Type 2 interval number is a generalization of ordinary interval number, that is closed and bounded interval A, with lower bound AL, upper bound AU, replacing both the fixed bound AL, AU by another interval. So mathematically, a type 2 interval number A is defined as the collection of all ordinary interval whose lower bound AL belongs to another interval and upper bound AU belongs to the another interval. The set of ordinary interval is denoted by 2R. Arithmetic operation on type 2 interval numbers. Let A and B two type 2 interval number, then A plus B is defined as this, and A minus B is defined as this. Scalar multiplication. For any scalar, okay, so for any scalar, A lambda is defined as this, multiplication AB is defined as this. For division, B, so I don't hear you. Sir, please.
Go to the main result. Go to the main result.
Okay, sir. These are the main results. These are the examples for arithmetic operation. Here we define the order relation on type 2 interval. To define order relation on type 2 interval, we first define some function C1a, which is the average of all the bounds, C2a, which is the average of the bounds except lower bounds, and so on, C3, C4. This. Then AL is equal to B, to type 2 interval A is equal to B if and only these conditions are for type 2 interval function and its optimization. Let D subset Rn, a type 2 interval valued function is of several variables, is a function from D to I to R, where the F lower bar L, F upper bar U, and so on are the real. Now we derive the necessary and sufficient condition for this optimization, unconstant optimization problem P. For this purpose, we define the local minimizer and local global minimizer as this. Here are the necessary conditions. A type 2 interval functions of the form this, with the condition that all the function all the function G1 or minimum conditions necessary condition of
Dr. Raghunandan Giri, it is not audible. Disturbance in sound.
Connection problem, sir. Connection problem. Okay. Rama, your audio is not visible.
Okay. Audible, sir? Is it audible?
Now it is audible.
Audible, sir? visible or invisible?
Visible but not
Invisible, but audio is not.
People say,
Okay, it is your last slide. Prasanto Pal, Dr. Prasanto
yes,
Pal, please,
yes, I'm present.
please mute your mic when you call, then you unmute.
Okay.
Sir, I think this the connection is problem. So to call next one, sir.
Okay, then I must thank Mr. Rahman and beg pardon for the disturbance that he has to face and we have faced. Okay, we are very sorry, Mr. Rahman. We are very sorry that this disturbance cannot be managed. Anyway, I thank you. Your presentation was very good and the topic is also nice. And the new concept of type 2 interval number, regarding that you have also tried to apply it in the inventory control system. Anyway, thank you. Mr. Raman, thank you. Then the next speaker will be Prasanto Pal.
Yes, sir, I'm present.
You are from Barasat Government College and your topic is information measure in the context reliability theory. You start your presentation.
Okay, sir. Sir, is it visible?
It's coming here.
Not yet. Yes, it has come. Now it is
Sir?
visible.
Visible, sir? Okay.
Start. Yes,
Okay.
it is visible and audible. It's all right. Start.
Okay. Okay. Thank you, sir. So myself, Dr. Prasanto Pal, and I'm an assistant professor of Barasat Government College.
Assistant professor. Thank you.
Yeah, assistant professor. Okay. Today I am going to talk a very interesting matter that is called information measure, and in the context of reliability theory. The outline of my paper is like this. First of all, I will discuss about the Shannon information measure, or rather Shannon entropy. Next, I will discuss about the residual entropy, afterward generalized residual entropy, next the burst entropy, and then I go to the generalized burst entropy. Okay, the concept of entropy was originally developed by the physicists in the context of equilibrium thermodynamics, as all of you know that. However, a general concept of information entropy to quantify the statistical nature of lost information in phone line signal mathematically was developed by Shannon in 1948. Apart from the communication theory, information entropy has found applications in many social, physical, and biological sciences, for example, economics, statistics, accounting, language, psychology, ecology, pattern recognition, computer science, and fuzzy set, etc. This is the definition of Shannon entropy. Suppose X be absolutely continuous non-negative random variable representing the lifetime of a component with distribution function ft and survival function f bar t. The Shannon entropy is defined by hx equal to expected value of minus ln of x, where this ft is the probability density function of x. And this gives the expected uncertainty contained in ft about the predictability of the outcome of the random variable x.
Shannon entropy was originally defined for discrete random variables, and it is positive, and it is increased by the additions of an independent component. The continuous counterpart of the Shannon entropy may be negative. As HF increases, the distribution function approaches to the uniform. HX, that means Shannon entropy, is a measure of uncertainty associated with the density function. Next, I will discuss about the residual entropy for used item. That is, if a unit is known to have survived up to an age t, then Shannon entropy cannot be useful for measuring an uncertainty about the remaining lifetime of the unit. Ibrahimi in 1996 has proposed a modified form of Shannon entropy, and he named this as a residual entropy function and defined residual entropy function as hxt equal to minus integration t to infinity fx by a bar t ln fx by a bar t dx. These are few properties of residual entropy function. Verma in 1966 generalized the concept of Shannon entropy in the following manner. H of x alpha beta equal to 1 upon alpha into beta alpha minus beta ln integration 0 to infinity f to the beta by alpha x dx, where alpha and beta both are positive, alpha not equal to beta. And note that if we take alpha equal to 1 and made beta tends to 1, then this definition reduces to the Shannon entropy. Myself in 2016 generalized this concept for the residual entropy function, and I generalized this definition for the residual entropy function as hx alpha beta t equal to this 1 by alpha into alpha minus beta ln integration t to infinity fx by f bar t to the power beta minus beta by alpha dx. And we name this as generalized residual entropy of order alpha beta. And note that if we put alpha equal to 1 and take the limit beta tends to 1, then this generalized residual entropy reduced to the residual entropy defined by Ibrahimi. And if we also make a limit t tends to infinity, then this entropy, that is the residual entropy, reduces to the Shannon entropy, original Shannon entropy. These are few properties of alpha beta residual entropy. Due to shortage of time, I am not going through all these properties. Okay, in many realistic situations, uncertainty is not necessarily related to the future, but it can also refer to the past. Based on this idea, Professor De Crescenzo and Longobardi in 2002 have defined a new concept of entropy and named this as a past entropy, and that is defined over 0 to t. And they define this past entropy as h to xt equal to minus integration 0 to t fx by ft ln fx by ft dx. For some stochastic ordering and aging properties of this past entropy, we refer the paper by Professor Nanda and myself that published in 2006. In 2015, I have created another type of generalization of this past entropy, and I named this as generalized past entropy of order alpha beta. And this is defined as h star x alpha beta t equal to 1 by alpha minus beta ln integration 0 to t fx by a bar t to the power beta minus alpha plus 1. And here also note that if we put alpha equal to 1 and make a limit beta tends to 1, this generalized past entropy reduces to the past entropy defined by De Crescenzo and Longobardi. And also if we take a limit t tends to infinity, then this past entropy reduces to the Shannon entropy, original Shannon entropy. In this paper, we have defined a new non-parametric aging classes based on generalized past entropy, and we also characterize the uniform distribution in terms of generalized past entropy. And we have shown that a random variable x that defined over a and b has uniform distribution if and only if the generalized past entropy h star x alpha beta t equal to ln of t minus a, where t lies between a and b. A non-negative random variable x is said to have increasing uncertainty of life of order alpha beta, shortly IUL alpha beta, if generalized past entropy is increasing in t. If x is IUL alpha beta, then we develop a upper bound of the reversed hazard rate function. Reversed hazard rate function is defined as mu f t, denoted by mu f t, and defined as proportion of ft by small ft divided by capital FT, that is density divided by the distribution function in terms of the generalized past entropy. And we give that mu ft is less equal to the upper bound of mu ft is beta minus alpha plus 1 to the power 1 by beta minus alpha into e to the power minus h star. It is wrongly written here, not as h bar, it is h star x alpha beta t. These are the references of my paper. Thank you. Thank you, sir. I have finished.
Sorry to disturb you. Sorry to disturb you, Chairperson. Sorry to disturb you, Chairperson.
Hi.
Please, can you hear me? Can you hear me?
Yes, I
Sorry
can hear you.
Actually, one of my candidate, Sai Kirtana, his paper number is 113. But in your, you didn't mention in your list of participants. So I wanted to know whether she is going to present or not in this room. Her number is 113. Please let me know.
113.
I already informed her to that. Okay. Hello. I already messaged her. I will call her. I think.
I am not able to get it. What you are saying?
Okay, I already messaged her. I will call you.
Okay, right. Okay, thank you very much. Thank you. Thank you. Hello, sir. Please inform her to present in this room. The organizer will call her again. Okay.
Raghu.
Yes, sir.
Dr. Giri,
Continue, sir.
Her paper number one.
P 113.
113, no? He's Munir Nabi, isn't?
No, sir.
He's different.
Sir.
Okay, you take care of him, eh? You take care of that.
Okay, so we continue with the last.
Professor Prashanta Pal, your work is very nice and your presentation is also very nice. And you have defined a new concept and you have generalized it gradually and it is a very nice talk. Thank you. Professor Prashanta Pal, thank you on our behalf. Now I will call Rajkumar Bera.
Yes, sir.
Are you here?
Yes, sir.
You start your talk. You are from our university, Vidyasagar University.
Yes, sir.
Okay,
myself, Rajkumar Bera, from Vidyasagar University, working under the guidance of Professor Samal Kumar Mondal. Now I am going to present my research work entitled Credit Linked Two-Stage Multi-Objective Transportation Problem in Rough and Bi-Rough Environments. Transportation problem is a distribution type problem, the main goal of which is to decide how the goods are transferred from various origin to various destinations so that the total transportation cost is either minimum or total profit is maximum. In multi-objective transportation problem, more than one objective functions are optimized. Credit period means a time frame between when a customer purchases a product and when a customer payment their dues. Here we firstly describe the interval form of a rough set. The first one is about the lower approximation set and the last one is about the upper approximation set. And here this is the interval form of a bi-rough set. Here A bar is a bi-rough set and K1, L1, M1, N1 are the real numbers. These are the previous research works. The main aims and objectives of this research is to formulate a multi-objective transportation problem so that both the sources and destinations are benefited, and to investigate the impact of credit period policy in a transportation problem. Moreover, another objective is to formulate a transportation problem in rough and bi-rough environments. This is the structure of the model. Here the production house send their own products to different distribution centers according to their demands. Then distribution centers send these items to different retailers according to their requirements. For this purpose, distribution center demand a certain amount of cost which is more than the actual transportation cost. To formulate this model, we have considered some assumptions. The first one is about the credit period policy, and the credit period is depending on the requirement of the retailers. That is, if the requirement is more than a threshold value JAI, then that retailer get a credit period of 3 days. And in this problem is a two-stage multi-objective transportation problem. In the second stage we consider unit transportation cost as problem parameter, and while in the first stage we consider distance as a parameter. And in the system, the independent parameters like actual transportation cost and requirement of the retailers are considered as RAP, while dependent parameters such as demanded transportation cost and demand of the distributors are by RAP in nature. This is an example of a RAP set, and second one is about by RAP set. This is the objective function of my model. First one is about the
skip. Go to the main result. This is your objective function. What are the constants?
These are the constants. So this uncertain model, to convert this uncertain model, we propose two different approach. The first one is expected value approach, and in second one is RAP by RAP programming approach. In expected value approach, we use this expected values formula, and in second one we formulated a programming approach, namely RAP and by RAP programming approach, to convert the deterministic form. In RAP by RAP programming approach, the constants containing RAP parameter converted into deterministic form using trust measure, and by RAP parameters including the constants are converted into deterministic form using chance measure. And the deterministic model is solved using a non-dominated sorting genetic algorithm. For numerical example, we consider the following numerical data, and using this numerical data, we solved using two different approaches, and we have observed that the second approach is better than the first one. In RAP by RAP programming approach, alpha, beta, gamma are the parameters, and for different values of these, we in this table we have listed these results. And in the second table, we have seen the effect of credit period policy. With increasing JAI, we have seen the increasing of JAI would be better for the distributors, but decreasing of JAI is the better of retailers. Conclusion: this model would be helpful in any business system for the purpose of transportation, and our proposed approach to convert the deterministic form is better for the first one, and the effect of credit period policy has been showed properly. These are the references. I would like to thank my guide, Professor Saman Kumar Mondal, and my institute, Vidyasagar University, and for financial helping Department of Science and Technology. Thank you.
Thank you, Mr. Rajkumar Bera. Your presentation is very nice and clear. Conception is very clear.
Thank you, sir.
Thank you. Next speaker is Shamoli Ghosh.
Yes, sir. Yes, sir.
Shamoli Ghosh. You are also from our university, Vidyasagar University. You start your presentation.
Yes, sir.
Shamoli Ghosh.
Yes, sir. Yes, sir.
Okay. Our topic is an intellectual multi-objective fixed charge solid transportation problem on fully intuitionistic fuzzy environment. Nice paper.
Today my presentation is an intellectual multi-objective fixed solid transportation problem with fully industry fuzzy environment.
under the guidance of Professor Shankar Kumar Rai. This is the outlines, introduction, literature review, preliminaries, notation, assumptions, solution procedure, numerical example, conclusion, feature research scope, and requirements. In introduction, first we define MOTP. MOTP, multi-object transportation problem. The traditional transportation problem consists only single object function, but in competitive economic conditions, there is more than single criteria. In such a condition, single object transportation problem transforms into multi-object transportation problem. Fixed transportation problem is an extension of general transportation problem, whereas fixed consider as renting cost of vehicle, landing fees, and airport toll charges on a highway setup, cost formation, etc. Solid transportation problem consider three-dimensional property with three constants: source, demand, and convenience constant. Why uncertainty appears on transportation problem? Uncertainty appears on transportation with various situations such as market condition which fluctuate all time and the demand cannot clearly determine. Decision makers is not conscious about related transportation cost. Sometimes decision maker cannot make up the delivery time for some critical situation. These are the literature review. In a definition section, first to define the interesting phases. Interesting phases are defined by one is membership function. Sir?
Go to the main result. Time is very short. Go to the main result.
Okay.
Sir, after that 1 hour break, sir, you can continue, sir.
This is our model. This is the formulation model. We consider three objective functions with fully justified number. First one is the transportation cost with fixed charge. Second one is deterioration rate. Third one is time. And this is the source, demand, convenience constant with feasibility condition. And this is the feasibility condition. And since this our problem is an interesting fuzzy number, therefore you use alpha beta to transform the fuzzy problem, interesting fuzzy problem into interval problem. And thereafter use accuracy function to transform the problem into Cripps problem. And there in model 2, here we define the Cripps model. Here we three solution procedure to find a compromise solution. One is fuzzy programming defined by Zimmerman 1978. Another is intrinsic fuzzy programming defined by Angelo 1997. And another is gold program 1957. Here we consider a numerical example with two source and two destination with food supply company, which all data are intrinsic fuzzy number. And these are data given in table from table 1 consists transportation cost with fixed charge, table 2 consists deterioration rate, and table 3 consists time. And here we use alpha equal to 0.8 and beta equal to 0.1. And solving the numerical example with the programming approach, we find the compromise solution. And here we define the objective values as Z1, Z2, Z3 in table 4. In conclusion part, here we say that in this paper we have analyzed a fully intrusive fuzzy multi-object fixed solid transportation problem. Next, we transform the intrusive fuzzy problem into interval problem using alpha beta chart, where alpha beta are chosen by decision maker own choice. Therefore, there exists a scope to allocate a better solution. Next, the interval problem reduced into Cripps problem by using the accuracy function, where accuracy function satisfies the linear property and help the ranking to all intrusive fuzzy number. A numerical example has been illustrated to demonstrate the applicability of our model, and a comparison has been drawn from table 4, and we see that intrinsic fuzzy programming defines the better result than fuzzy programming, gold programming, and it is more flexible and highly significant to apply in realistic multi-object transportation problem or any decision-making problem. In future research scope, the future researcher may extend our proposed method related on following topics such as study or nonlinear or fractional transportation problem with all the parameters are intrinsic fuzzy number, or study of multi-object multi-choice fixed transportation problem or unbalanced transportation problem with intrinsic fuzzy number. Also, this problem can be extended for finite time control problem or multi-item problem in uncertain environment. These are the reference. Thank you, sir.
Thank you, Shamoli. Actually, you have presented in very hurried manner. We are very sorry.
Okay, sir.
Anyway, presentation is very good. Topic is very good. Idea is very good. You do very good research and carry on your research. It is a nice paper. Okay. We have enjoyed it. Okay, Shamoli. Thank you. Next, Subrata Panja. It is your turn. Subrata Panja, are you here?
Yes, sir.
Yes.
Yes, sir, I am present.
You are talking from our, you start your presentation.
Sir, is my PPT visible?
Not yet. Now it is visible. Okay. Now it is visible.
Good noon, sir. Myself, Subrata Panja, working under the guidance of Professor Samal Kumar Mondal. My title is a two-level green supply chain model with credit link,
demand and markup under revenue sharing contract. So before we forward to my topics, I briefly discuss about supply chain. We are all concerned about supply chain in recent days because our PM is also discussing about supply chain activities, because during lockdown there are the flow of materials, or suppose flow of products from a manufacturer to customer should be smooth, so that we can enjoy our smooth lives. So these are the supply chain where the products from manufacturer to a market customers shares between a retailer, or there may be any other supplier. Basically, my paper is based on some green supply chain problem. Interested about the impact of credit period. So first we give some literature review. These are some basic in green supply chain papers which are studied by very renowned authors. And these are my model structure. The first model is there is only manufacturer and retailer, and there is no credit period from retailer to customer. And these are the model structure I have shown in. Then these are the second model, and where credit period is there from retailer to customer, and the demand is there is shown in right hand side. Now I am going to the decision making process. Here we only used two decision making. One is decentralized scenario and another is revenue sharing scenario. Decentralized scenario means the manufacturer and retailer are taking individual decision, but there are no negotiation between them. That is, and this decision is obtained by using Stackelberg game. And next is revenue sharing contract. Revenue sharing contract means in this contract, retailer shares a certain portion of revenue from to the manufacturer, and in turn manufacturer sells a certain product retailer in a lower selling price. So under this, our objective is to impact of credit period. Actually, impact of credit period in the is win-win outcome for the credit period. We are discussing about the win-win. Mainly, we are discussing about the win-win situation of the due to the credit period. These are some model one, and these are the objective function. These are the optimum outcome for decentralized scenario for model 1, and these are the optimum outcome revenue sharing scenario for model 1. And these are the objective function for model 2 when credit period manufacturer's profit, retailer profit is pi r, and total supply chain profit is pi SC. These are the optimum outcomes for decentralized scenario for model 2, and these are the revenue sharing scenario for model 2. And these are the numerical outcomes. Here we can see that under model 1, when there is no credit period, there is no win-win situation in the when credit period is not offered. From the retailer, you can see that there exists win-win situation for both manufacturers. As you can see from the figure, the left hand figure is showing the retailer's profit for decentralized scenario for model 1, and right hand side is showing the retailer's profit for revenue sharing scenario for model 2. As you can see, for the first scenario, the retailer's profit is lower to the decentralized scenario, but when the credit period is offered, retailer's profit is upper to the decentralized scenario. That is, there exists win-win region for the manufacturer. Next is say manufacturer profit. Actually, you can show that actually the manufacturer is always wins for both the cases. That is, whether credit period is offered or not. Any amount of credit period from him to her, from him to customer. So this is not always possible, because as you can see, when the opportunity interest loss due to the credit period is increased, the retailer's interest is lower to the decentralized scenario. That means in this case, retailer cannot win, but manufacturers also although the wins. So what we can conclude manufacturer and retailer. These are our main outcome. There are some feature research tools. We are only considering about the crisp credit period, but one can consider the credit period, etc. These are some references. I want to acknowledge for supervision. Thank you.
Thank you, Subrata Panja, for your nice presentation. It is a very good work. And okay, you carry on your research.
Thank you, sir.
I hope you have good future. Thank you, Subrata Panja. Now it is the turn of Sumon Maiti.
Yes, sir.
Yes, you are from Raja N.L. Khan Women's College. The paper that you will present is entitled A Study of an EOQ Model with Backlogging using Intuitionistic Dense Fuzzy Demand Rate. Intuitionistic Dense Fuzzy Demand Rate. Okay. Thank you. Start. Sumo, you introduce yourself. In what position you are in Raja N.L. Khan?
Sir, is my slide visible?
Yes, it is visible.
Okay, sir. Thank you. Good afternoon, everybody. Myself, Sumon Maiti. I am doing my research work under the supervision of Professor Madhumangal Pal. The entitle of my presentation is A Study of a Backorder EOQ Model for Cloud Type Intuitionistic Dense Fuzzy Demand Rate. In 1983, Atanasov first defined intuitionistic fuzzy set. After that, in 2016, incorporating learning experience, they first defined dense fuzzy set. In this paper, we have introduced denser property in intuitionistic fuzzy set. We have defined here nonlinear intuitionistic dense fuzzy set with its new defuzzification method. We have considered a backorder EOQ model with nonlinear intuitionistic dense fuzzy demand rate, and we have also given a comparative study with trapezoidal pentagonal dense fuzzy number. Triangular dense fuzzy set. A triangular fuzzy set is said to be a triangular dense fuzzy set if all the components are sequence of function converges to a Cripps number for n tends to infinity. This is the general form of a nonlinear triangular dense fuzzy number whose membership and non-membership function are given in 1 and 2 respectively. The green color picture indicates the membership function over learning experience of a linear intuitionistic dense fuzzy number, and the right one picture indicates the non-membership function over learning experience of a linear intuitionistic dense fuzzy number. Here, these two pictures indicates membership function of a non-linear intuitionistic dense fuzzy number. First one for fractional power and right one for integer power. And here, these two pictures indicates non-membership function of a non-linear intuitionistic dense fuzzy number. First one for fractional power and right one for integer power. This is the new defuzzification methods based on alpha cards. Now we consider a backorder EOQ model, and these are the notation which we have used to develop our proposed model. These are the assumptions of our proposed model, and the right hand picture is the diagram of the backorder inventory model. For a case study, we have visited a toy producing company situated at Kolkatta. After long discussion with the manager, we have collected some important data regarding our model. This table contains optimal solution of the model under different environments such as Cripps, trapezoidal dense fuzzy, pentagonal dense fuzzy, intuitionistic fuzzy, and intuitionistic dense fuzzy. This is the graphical representation of the previous table. From this figure, we see that intuitionistic dense fuzzy gives finer optimum comparing with Cripps and other fuzzy environments. For sensitivity analysis, we have changes fuzzy deviation parameter rho, sigma, rho dash, sigma dash from -20% to +20% and get this result. This is the graphical representation of sensitivity analysis table, and we have seen that all the fuzzy parameters are low sensitive within this variation. This 3D figure represents the variation of cost function under learning forgetting scenario. From the figure, we see that for learning experience value 2 and forgetting experience value 1, we get the minimum inventory cost. The main merits of this model is the decision maker can reduce inventory cost by applying induction-stick dense fuzzy approach. Learning forgetting process is an emergent situation that usually occur in any inventory problem, so we can't ignore it. The less qualified decision maker can also find an accurate decision with the help of induction-stick dense fuzzy approach. The main demerits of this model is that this model is not applicable for newly set up inventory system. In this approach, adequate manpower required to collect more information about the model. From this study, it is seen that the CRIPS approach is inferior to the dense fuzzy approach. Also, it is observed that when the learning frequency gets more value than that of forgetting, then the extreme optimality exists. These are the references which I have followed to prepare my paper. And finally, thank you.
I also thank you, Suman Maiti. It is a very nice paper and you have very hard working done.
Thank you, sir.
And the fuzzy set in my time only it was a fuzzy set. Now it is non-linear induction-stick dense fuzzy set. So many adjectives are going on, adding.
Yes, sir.
Okay, it is a very good work and carry on your research. Nice paper.
Thank you. Thank you, sir.
Thank you. Now, whom should I call? Dr. Giri?
Munir Nabi, sir.
Munir Nabi, okay. Munir Nabi, it is your turn now. Please, you come and you join and start your presentation. Munir Nabi is from Kashmir University, as I have noted. Kashmir University, he is presenting his or her.
I see.
Munir Nabi, you first introduce yourself first, clearly. Then you start
Munir Nabi, you are present here. Munir Nabi, I think he left from this meeting. Sir,
Munir Nabi, are you here?
I think he left from this meeting, sir.
He was there.
It's connection problem. I think he left. So next one, sir, P113.
Okay.
Saikir Thana.
Yes, sir, I am here, sir.
Okay. Acha.
Okay,
thank
Thana,
you.
please introduce yourself. Your details is not in your chairperson. So please introduce yourself. Then you start your presentation.
Sir. Good afternoon, sir. Myself, Sai Kirtana, doing MPhil under the guidance of Dr. Radhakrishnan, DG Vaishnava College, Chennai. Am I audible?
Yes, you are audible. Clearly audible.
My presentation is about new method for solving fuzzy sequencing problem. Let us move on to the presentation. Operation research is used successfully in almost all the fields. It helps us to make better decisions in complex scenarios. The main objective of operation research in practical application is to maximize the profit, performance, or yield and to minimize the loss, risk, or cost. There are many applications of operation research. Here we specified sequencing problem. Generally, in sequencing problem, the processing time are valued precisely, but in reality, it is observed that the processing time are imprecise and uncertain. In order to handle this uncertainty, we use fuzzy numbers and fuzzy intervals. The concept of fuzzy set was proposed by Zade. In this presentation, we consider the trapezoidal fuzzy number, which is the generalization of triangular fuzzy number and intervals.
And then we solve the sequencing problem by converting the processing time, which is given in terms of trapezoidal fuzzy numbers, into intervals using AlphaCut. An algorithm is provided for obtaining an optimal sequence and for determining the minimal total elapsed time and ideal time for each mission. Next is sequencing problem. It is the problem of determining an appropriate order to minimize the total time taken for completing all the jobs. Johnson has proposed an algorithm for scheduling jobs in 2 missions. Furthermore, Johnson's method has been extended to M-mission problem with an objective to complete all the jobs in a minimum duration. These are the principal assumptions are made while solving a sequencing problem. The processing time on different machines are independent. No machine can process more than 1 job simultaneously. The time required in transferring a job from one machine to another machine is negligible. Each operation, once started, must be completed. Processing time are known and fixed. Operation must be completed before a succeeding operation starts. No passing through is allowed. These are the terminologies we use in sequencing problem. Then we move on to the basic concept. Here we define an interval number. Where beta 1, beta 2 are real number. They are the lower and upper bounds of the interval respectively. Arithmetic operations of interval are given here for addition, subtraction, multiplication, and for division. Then we move on to ordering of intervals. Any interval number can be expressed by its center and radius and is denoted by AC and AW, where AC is equal to beta 1 plus beta 2 divided by 2 and AW is equal to beta 2 minus beta 1 divided by 2. If any 2 intervals are given, then the relation on the interval is defined as follows. Then we move on to the fuzzy set. Fuzzy set is a generalized function of the crisp set such that the value assigned to the element of the universal set X falls within the specified region. That is, mu A tilde is a mapping from X to 0, 1. The assigned value indicates the membership grade or degree of the element in the set. The function mu A tilde is called the membership function and the set A tilde is defined by mu A tilde. It is called the fuzzy set. And fuzzy number is a normalized and convex fuzzy set of the real line whose membership function are piecewise continuous. Here we define the trapezoidal fuzzy number with its membership function. This is the definition of AlphaCut. Using this definition, we convert the trapezoidal fuzzy number into intervals. They are given here. Using this formula, we can solve the sequencing problem. Here we are given the algorithm for solving fuzzy sequencing problem. The algorithm is the fuzzy inversion of Johnson's algorithm. Processing n jobs on 2 missions. First, we convert the processing time, which is given in terms of trapezoidal fuzzy number, into intervals using AlphaCut, and we use the ordering of intervals to identify the minimum processing time from the mission 1 and 2. After that, if the minimum processing time is on mission 1, then we do the pth job first in the sequence, and if it is in mission 2, then we do the qth job last in the sequence. If there is a tie occurs, then we can do the step 4. After that, cancel the jobs already assigned and repeat the steps from 2 to 4 until all the jobs have been assigned. The resulting order will minimize the total elapsed time, and it is known as optimal sequence. And after obtaining an optimal sequence, we determine the total elapsed time and ideal time for each of the missions, and they are calculated as follows. Next, we move on to the end jobs on 3 missions. Here, the processing time for 3 missions are given. There is no standard procedure to obtain an optimal sequence for end jobs on 3 missions. So we convert this 3 mission into a 2 mission problem by satisfying any one of the following conditions. If these conditions are satisfied, we can convert this 3 mission problem into a 2 mission problem, and the processing times are obtained as follows. After that, we can proceed to determine the optimal sequence using the previous procedure. After obtaining an optimal sequence, the total elapsed time and ideal time for 3 missions are calculated as follows. The formula is given here. Then we move on to processing n jobs on 3 missions. As we done for 3 missions, we can do it for m missions. First, we have to convert this processing time, which is given in terms of trapezoidal fuzzy number, into intervals. After that, we have to identify the minimum of first job and the last job, and we have to identify the maximum of intermediate job after intermediate missions, and we have to, after identifying the minimum and maximum, we have to check the conditions. If these conditions are satisfied, we can convert this m mission problem into a 2 mission problem, and we can proceed to determine the optimal sequence by using the previous procedure. After obtaining an optimal sequence, the total elapsed time and ideal time for each of the missions can be calculated. Then we move on to numerical examples. Here, the example is given for two machine problem. The processing times are given in terms of trapezoidal fuzzy number. Our job is to find an optimal sequence and determine the minimum total elapsed time and ideal time for each of the machine. First step, by the procedure, we convert the trapezoidal fuzzy number into intervals using alpha cut. The converted value is represented in the table. With the help of the procedure, we have order of cancellation. After that, we obtain an optimal sequence as follows. Using this optimal sequence, with the help of the procedure, we can determine the total elapsed time and ideal time for machine 1 and machine 2. We get an solution in terms of intervals. Using this, we can draw the graph. The graph is represented here. This graph represents the trapezoidal fuzzy number. Therefore, we are denoting this values in terms of trapezoidal fuzzy number, and they are given here. Then we move on to the second problem. This is a 3 machine problem. The processing time are given in terms of trapezoidal fuzzy number. Our first step is to convert the trapezoidal fuzzy number into intervals using alpha cut. The converted value is represented in the table. Since the problem is a 3 machine problem,
Presenter, your presentation not visible. Someone raised the question. Your presentation is not visible. So to present now mode.
Screen not visible, Sai Kirtana.
Sorry, sir. I can't.
Present your screen once again. Sai Kirtana, present your screen once again.
From which side, sir?
No, you go through the same procedure. However, you present now mode. Then enter your share your screen. Then we can see. Okay, it is coming now.
Is it visible, sir?
Now it is coming. Yes, now it is visible.
Shall I continue?
Continue.
Okay. This is a 3 machine problem. We cannot do it directly. We cannot obtain an optimal solution directly. Therefore, we are converting this into a 2 machine problem. Further, it has to satisfy any one of the following conditions. If these conditions are satisfied, then we can convert this problem into a 2 machine problem. Here, second condition is satisfied. Therefore, we are converting this into a 2 machine problem. After that, we obtain an optimal solution using previous procedure. And we determine the total elapsed time and the ideal time for machine 1 and machine 2 and machine 3. The corresponding plot for the minimum total elapsed time and ideal time for each of the machine are given in the following figure. This figure represents the trapezoidal fuzzy number. Therefore, the minimum total elapsed time and ideal time for each machine given in terms of trapezoidal fuzzy number. Then we move on to next problem. This is the example for M machine problem. As we done for 3 machine problem, we can do it for 4 machine also. The first step is to convert the trapezoidal fuzzy number into intervals. After that, we obtain these values. To find an optimal sequence, we convert the 4 machine into a 2 machine problem. Further, it has to satisfy any one of the following conditions. Here, both the conditions are satisfied. Therefore, we are converting this problem into a 2 machine problem. And the processing time are represented here. After using the procedure, we have the order of cancellation and we obtain an optimal sequence and we determine the total elapsed time and ideal time for machine 1, 2, 3, and 4. We get these values in terms of intervals. After that, we plot the corresponding values of minimum total elapsed time and ideal time for each of the machines, and they are given here. This figure represents the trapezoidal fuzzy number. Therefore, we are giving this in terms of trapezoidal fuzzy numbers. Finally, the conclusion. In this presentation, we propose the fuzzy version of Johnson algorithm by converting them into an interval and obtain an optimal sequence, and we determine the total elapsed time and ideal time for each of the machines. Thank you.
Thank you, Saikathana, and your guide, Dr. Radhakrishnan. It is a very nice work, and your presentation is very good. And
thank you, sir.
Thank you. Stay with us. Okay, very nice, very nice. We are very glad to hear you.
Okay, thank you, sir. Thank you, sir.
Thank you very much from my part and from our university part, and on behalf of the organizers. Okay, Dr. Giri,
Sir,
Who is left?
Munir Nabi just message me. He joined in this room. Please call him.
Okay. Let him come and join us.
Munir, you are present.
Munir Nabi.
Munir, your audio is not clear, visible here. Munir,
Make your microphone on. Munir, we can't hear you. Make your microphone on. Munir Nabi, we can't hear you. Take care of your microphone. Make it on. Munir Nabi, do you hear us? Some problem is there.
today had 3-4 times he trying to present, but he could not. I don't know why. He just Munir, you open your headphone. I think there is some problem in your headphone. I seen in your picture you wearing the headphone. Please open your headphone, then you start. I think Munir.
Can somebody help Munir? Some technical problem is there, I think. Dr. Giri, on the screen, whose paper we see?
Yes, sir.
In the screen, what? In the screen,
Munir Nabi is presenting, but his the audio not coming. Also, I think a network problem something. Munir, your audio is
just come in the screen. Central University of Kashmir.
anyone can help him. What kind of problem if you face, you suggest him. I did not understand what is the problem of him. Anyone, if you face such type of problem, if you can suggest him. So, I think
Munir Nabi, you go on presenting your paper on the screen. We will see. We will see your paper on the screen. If it is not audible, you show your paper in the screen. Munir Nabi, do you hear us? If it is not audible, then you present your paper on the screen. We will see.
Someone suggest him disconnect now, then join from another ID. Munir Nabi, disconnect now, then join from another email ID. If it is audible, you just disconnect now, then join another ID. Munir Nabi, are you joined? Otherwise,
Dr. Giri, if there is sound problem, ask him to present his paper on the screen.
he left from this meeting. I try to connect now, I think.
Sir, please call next one.
Someone left. They want to present the paper, but still not present. Some problem. Some types of a participant is there. If they are want to present, then we can give chance here. If someone want to present paper, not present due to some problem, we will give the chance.
Mathura Parveen. Mathura Parveen, you are enlisted in the.
Sir, he is already presented.
No. Mathura Parveen.
Professor Paul, he is already presented.
Acha. So, his paper number was P68, isn't it?
Yes. He is already presented. Okay, no problem. Next one, sir, please. Anyone left, sir?
So, sir, this session, sir.
Yes.
So nobody is left then. Nobody is there.
No.
Dr. Giri, should we finish?
Yes, sir.
Conclude.
Yes, sir.
Yes, sir. You can conclude, sir.
Okay, then we thank on behalf of our university and organizer, all the participants who have presented their papers. Nice we have heard and we have enriched, and all the participants, I believe that they have got their experience from your presentation. And you keep contact with our university. In future, we will need you. Okay. On behalf of our university and from my part, we thank you very much, all the participants, for your nice presentations. Okay, with this, we conclude this session.
Thank you, sir.
Now it is break time, isn't it?
Yes, sir. Break time. Our session will start at 2:30. Please stay on line, or you may join at 2:30.
In which room? In main room or this room?
Yes, sir.
Okay. Okay, then have a lunch.
Okay. Thank you, sir. Thank you for it.
Thank you all also. ওটা তো শোনা আমার কাজ হলো থার্টিতে আবার হবে, কিন্তু ওখানে আমার কাজ নেই, আমার কাজ হয়ে গেছে। বন্ধ করে দিচ্ছি, তবু কেন আওয়াজ হচ্ছে?
When I joined as the Vice Chancellor of this university in 2011, the infrastructure was very underdeveloped and it was in shambles. And it required great effort on our part to create an ideal infrastructure for a university like this. We were also working on the creation of the right infrastructure, because most of the students
in this university belong to backward castes and communities. We need to prepare our students for the competition they may face in the future. We want to see them successful in life, and we have to respond to the needs of the hour, because the jobs are scarce, and in order to have them a better placement in life, we try to gradually make our courses more in tune with modern requirements. Our teachers, my esteemed colleagues at this university, they wanted to see their university as one of the best in the country. And we seriously, we are trying to put the name of Vidyasagar University in the national and international academic lab. And in this job, we are partly successful. We believe in performance. I personally, as the leader of this esteemed team, believe in performance.
Ismendu, Ismendu,
Okay, once again, we welcome you all to this 3-day international webinar on behalf of the organizing committee. Our invited speaker and chairperson has already joined with us. So now we will start the invited lecture session 9, and the invited talk will be presented by Professor Haidar Ali Biswas from Science, Engineering and Technology School, Khulna University, Bangladesh. Professor Biswas will talk about biomathematical model in understanding the transmission of global COVID-19 outbreak for possible control strategy. And Professor G.C. Laik from Bardhaman University is the chairperson of this session. So first of all, I'll introduce before the participants very shortly. Professor G.C. Laik is a professor in the Department of Mathematics, Bardhaman University, Bardhaman. He has completed his PhD from IIT Kharagpur. His research area includes laminar and turbulent flows, dynamical system, chaos, and fractal physics. He has published more than 100 articles. Professor Laik completed 3 projects and he supervised more than 10 PhD students. And Professor Haidar Ali Biswas is currently working in the Department of Mathematics, Science, Engineering and Technology School, Khulna University, Bangladesh. He has completed his PhD in Electrical and Computer Engineering, University of Porto, Portugal, 2013. More than 20 years of teaching and research experience in applied mathematics as well as in optimal control and application to biology and biomedicine he has. 3 books and 3 book chapters are published by him. More than 100 research publications in the referred and peer-reviewed international and national journals have been published by him. And his main goal is to apply mathematical technique to obtain necessary conditions of optimality for optimal control problems with constant to real-life problems arising in biology and biomedical engineering, emphasizing on the mathematical epidemiology of emerging infectious disease. So, with this short CV, I would now request Professor G.C. Laik to start the session, please.
Hello. Welcome to the. Can you hear?
Yes, sir. Please.
Okay. Welcome to the international webinar organized by the Department of Applied Mathematics, Vidyasagar University. So, first of all, good afternoon, everyone present in the international webinar. We are going to start inverted lecture session 9, and the speaker is Professor H. Ali Biswas, Professor of Mathematics Discipline, Khulna University, Bangladesh. It is my great pleasure to introduce Professor Biswas. He is very well known to mathematics community. Professor Biswas works broadly in applied mathematics, in particular the area of optimal control and applications to biology and biomedicine. He published more than 100 research papers in national and international journals. Above all, he is an most experienced teacher and researcher, more than 20 years teaching and research experiences in applied mathematics. With this very brief introduction to Professor Biswas, I now invite Professor Biswas for deliberation. Professor Biswas, please start.
Thank you, Professor Laik. Am I visible?
Okay.
Is my slide is visible?
Yes, sir. Yes, sir. Please continue.
Okay. Is okay, right?
Yes, sir. Please
Hello?
continue. Yes, sir.
My
Please
slide
continue.
is okay. My slide is visible.
Okay.
Yes, sir. It is visible.
Okay, we continue. No problem. Okay.
Okay, thank you everybody. And first of all, I would like to warm thanks to the organizer for inviting me to this prestigious international webinar means for the 3 days to share my research among the young researchers and scientists working in the area of biomathematics and mathematical modeling. So during this pandemic situation, actually everybody are mostly is restricted in our home. During this period, this type of international webinar is actually very significantly inspire all the researchers, though we are in this pandemic situation. So these topics of my presentation today is biomathematical model in understanding the transmission of global COVID-19 outbreak and its possible control strategy. So as the topics, the title is actually, it consists of 3 parts. First of all, I'd like to discuss about the applied mathematical role in connection with optimal control, some theoretical discussion. And second part, some application of biomathematical model in infectious disease and its transmission. And lastly, its application in constructing a transmission dynamical model of COVID-19 to understand its basic transmission and then apply the control strategy for a possible prevention and control until, because still now a vaccine is a dream. We are waiting, the whole world is waiting for that. So this is the outline. First of all, the role of mathematics. Here I will discuss about some theoretical and the basic notions of optimal control problem. What kind of problem is this and how is connected with mathematical model in biology or medicine. Secondly, this is the part of mathematical epidemiology and some different models, disease transmission and its basic reproduction number. And thirdly, the control, application of optimal control in this modeling and some numerical results with the validation of analytical findings. So, very beginning, I would like to say a very important quotation given by Leonard Euler. He says that nothing happens in this universe where some form of maximum or minimum does not appear. So this is a very real situation about mathematics globally. Mathematics has diverse applications indicating this great quotation of Euler. So in this connection, we can divide mathematics, some rising area, science, because all area of sciences, basically natural science, biological science, social science, it is impossible except mathematics. Technology, modern technology, and the sustainability mostly depends on mathematics. Engineering is very important area where mathematics is applied, space flight engineering, robotics, because robotics is now used in very dangerous environment where man cannot go and even man cannot walk. Even in some important operation for the human disease and industry production, all areas actually depends on mathematics. Business, you can say in banking or all others in business, financial sector, it depends on mathematics. Biomedicine is a very large portion of this global, which is driven by mathematics, such as epidemiology, immunology, drug discovery, vaccine trials. So a lot of things are mainly described by using mathematical model. So this is actually how we can explain this biomathematical model in applications. Biomathematics addresses actually biologically driven questions by utilizing appropriate mathematical and computational technique. And its scope is actually, it depends on some mathematical models which can be analyzed and understood for the theoretical and numerical examination by using a variety of mathematical techniques. And this biological system actually, it goes from our human genome to population level genetics, or cancer cell to ecologically invasive species, from the immunosystem to regional and global epidemics, like the current epidemic, and more other countless other applications. So recent research in biology, including medicine, has increasingly become intertwined and dependent on mathematics and some computational techniques. All others in the universe, we can see there is a lot of non-linearity. It's in the complex system of our planet. So this non-linearity phenomena from our Earth system to human physiology, it actually described by this non-linear mathematical model. And these non-linear mathematical models also actually dependent on mathematical model in the interface of biology and medicine. So non-linear ordinary differential equation actually the key ingredients for modeling the mysterious and complex mechanisms of the dynamics of infectious disease in human body. And optimal control actually fuels this mathematical model. It has a long history in modeling this nonlinear phenomena, nonlinear behavior of human physiological system, and significant role in obtaining optimal control strategy for the prevention and control of human disease. So it has been challenging to understand the mysterious mechanism of host pathogen interactions of such disease inside the human body. And only optimal control technique can be applied to modeling this type of system, modeling this type of phenomena, and designed to understand the evolution of the disease dynamics. And it is actually the very most important extensive area of research for in the connection of biology and medicine. Here we can see some rising area and applications where optimal control in connection with a mathematical model in biology and biomedicine can be applied. So a lot of application you have seen the aerospace, robotics, the renewable resource, and the vector-borne disease or cancer or many other infectious disease, ecosystem management or fishery management, forest management. A lot of applications is not possible without mathematics or mathematical model. So what is the history about some optimal control? Because we need to know actually about some basic description, basic information about optimal control. Optimal control actually the breakthrough of calculus of variations. The calculus of variation is a long history because a very old area of research, old area. It is the first application. Actually, it is regarded as Drag-Christopheron problem, which is called the path of least time, and it was proposed by simultaneously at the time of Bernoulli and the Jacob brothers, Newton's, Leibniz, and Bolsa. What kind of problem is this? This is actually if you slide a ball under the influence of gravity, what is the path it produced to reaching its destination at a minimum time? So this is actually called the cycloid. We know everybody. So this is actually the first application is regarded in optimal control theory. But actually, what is the solution technique of this type of problem? It was Pontryagin, the Russian mathematician, and its collaborators first invent some set of necessary conditions for solution of optimal control this type of problem. And this problem is actually known as maximum principle or minimum principle in the 1958. And later on, this problem also developed for non-smooth case by Francis Keller in 1973. So, non-smooth optimal control has another vast area of research in this connection of biological system. So, I would like to first, very beginning, just to see some basic problem of calculus of technique. You can see here the basic problem of calculus of variations is actually the finding of an arc. It is x star, which minimizes the integral function like this. So this is actually the integral function. Each function has three arguments: and time, state variables, and the derivatives of the state variables. Actually, these derivatives is dependent on the state over some class of arcs satisfying the boundary conditions like this. Here, all this interval is fixed, and all these functions are defined in this similar way. So this is actually the calculus of variational problem. Under the basis of this problem, we can define a dynamical system with optimal control. The dynamical system actually is the technique which is evolved over the time and is described by this x dot, the difference of the state variable with time under some initial condition. So this actually the initial value problem in our differential equation. We know all the research are working in the area, everybody knows it. X is here is the state variable and it is the time. But what happened when we can control this dynamical system from an external force using some additional force or some additional system? This is called actually the control variable. This dynamical system can be controlled using this type of dynamical equation. X dot is now is a function of x, t, and u. And as usual, this is also a initial value problem. Here u is the control. So what is the main aim of this u? That is the control. The control aims to maximize or minimize the objective function like this j. So this objective function, and also u has some constraint. U is constraint with some set u. It is called the measurable set. So under this basis, a very preliminary fundamental optimal control problem, this is called actually the very general form of optimal control problem is like minimize some objective function subject to some dynamic constraint x dot and some other constraint is like a state or mixed constraint, and under the constraint of the control with some initial condition, boundary condition, and the terminal condition. All these functions and variables are explained here very rigorously, and we can take these values and we can state this. This is optimal control problem in the standard form. This problem is called actually the Birsha type optimal control problem. Here the objective functional j has two parts. You can see everybody. This is the first part. This first part is called actually the terminal cost or endpoint cost. Also it is called the salvage cost. In economical model, this salvage cost is frequently used. In the terminal, this is the second part, that integral cost. Integral cost is called actually running cost. This is the integral part of this objective function. So this is two parts. This is the standard form. But when one part is absent, somehow, this problem is called actually when the Lagrange, the integral part is absent, the part, only the first part, it is called the Mayer type optimal control problem. And when the Mayer type, this part is absent, then we have only the integral part. And this integral part actually we call the Lagrange type optimal control problem. And the both part, this is actually the Birsha type optimal control. So this is the three optimal control problem. But interesting is these three points are very correlated. We can convert one problem, one system to another for using the solution technique smoothly. So what is the target for this type of problem? It is our target to find the small set of minimizers as the optimal solution, X star and U star, over all feasible solution. So this figure looks like this. Here the red one is our optimal solution, and the magenta color, this is actually the all feasible solution. So we want to pick this optimal solution from this optimal control problem. So how is it possible? We need a necessary condition actually. This is the set of necessary condition. We want to define Hamiltonian function with respect to a state variable, control variable, and the co-state variable. This co-state variable actually is known as Lagrange multiplier because we know optimization problem. Many of us work on optimization problem, and Lagrange multiplier, this Lagrange multiplier actually the co-state variable, and another lambda is constant. This lambda actually for the normal case, the lambda is considered 1. So this is the Hamiltonian. So under this Hamiltonian, we have a set of conditions. It is called the necessary conditions. First condition is the optimality condition. Second condition actually that adjoint equation. This adjoint equation has the state equation and the co-state equation. And this part is the transversality condition. So this is the set of necessary condition for solving this type of problem. But this optimality condition have a limitation. You can see when this condition we apply, there is no constraint on this control. So in that case, if the control is bounded, then the condition may not hold. In that case, the optimality condition is replaced by Pontryagin maximum or minimum principle. And this is the maximum or minimum principle, this one. This is the star because the optimal solution. The optimal solution always lays without optimal, with a feasible solution. And here it is interesting that the Pontryagin minimum principle, it is actually both necessary and sufficient condition, while the optimality condition only necessary condition. So this is a very strong evidence for solving this type of optimality problem. Under the basis of this technique, we develop a theory for the existence of optimal solution. So this theory says all the things I already discussed. Here all the functions L, small and capital, F and G, and the state constant, it should have continuous in X. That is under a state variable. And with some scalar value m greater than 0, of course this function involving control is bounded, is less than this. And the set U is compact, so both closed and bounded. And the function U and the function L with respect to U is convex. In that case, the L is greater than equal eta. Eta is as constant. And if all these things are satisfied, then there is at least one admissible process XY. For that, the objective function have a finite value. And if everything is happened, then the solution has a unique solution, exists an unique solution. So this is the all theoretical basis of optimal control problem to be applied in this biological model. So now I am showing here some biological model and its applications in medicine and in medical science. We know that pharmacodynamics, that is the drug distribution in the body, it is mostly applied by using mathematics because this is the dose and response relation. We can find this type of very simple differential equation, that is the dynamical system. And after a certain time, the concentration of drug can be obtained, this type of function. It is very simple, but this is the real application of mathematics, how a drug works inside the human body. This is another very important, very dangerous for the kidney failure. You know that kidney is a very essential part of our body. And if it fails, because the patient is not recovered anyway. So at the last test is only possible the kidney dialysis. This is dialysis machine, and this actually happened by using a coupled differential equation. We can describe this type of phenomena. So this is the application of mathematics in biomedical system. Another application communicable and non-communicable disease, a lot of application. I just put here immunotherapeutic treatment is the latest treatment strategy. This is the most variety of chemotherapy using a heart that is highly active antiretroviral therapy for the HIV patient. And for the cancer treatment, we are using the adaptive T-cell therapy. This is called the engineered T-cell therapy. This is the most promising treatment strategy now for the cancer. We can use mathematics here. And another is MIR for the brain. We know that everybody is a very important magnetic resonance imaging, and it depends on mathematical, some mathematical model we can apply, and we can find this type of results using mathematical model. So now, how mathematical model is used in infectious or non-infectious disease. So we know that emerging and non-emerging disease have become a serious public health globally. And infectious disease is mostly three kinds: epidemic, endemic, and pandemic. I will discuss in the next slide. And all these infectious diseases are like SARS, MERS, Nipah virus. We are mostly known, Nipah virus is in India and Bangladesh, and Ebola, Zika, novel coronavirus, and the recent outbreak of COVID-19. All these are very infectious diseases. And these infectious diseases are mainly vector-borne. It may be vector-borne. Some infectious diseases may be vector-borne, like dengue, malaria, chikungunya. And some infectious diseases are transmitted with some other way. I will discuss in the next slide. So there are two kinds in chronic infections like HIV and TB. And other infections is non-chronic, chronic but non-infectious. Long-term is sustaining. It is like cancer and diabetes, very important. And these diabetic patients have a very health hazard during this pandemic situation. And another is blood disorder, leukemia, liver cirrhosis. All these patients are very vulnerable during this COVID situation. So we should make very careful about those type of patients, either they are elderly or some or other middle-aged patient. So now, how this infectious disease is spread? Infectious disease actually is spread by either a bacterial or viral agents. We know these major agents are bacteria, virus, fungi, and parasites. And parasites is disease. How it transmitted in the society? It is called actually outbreak. So when more cases of a disease than expected are recorded in one area, it is called actually outbreak. And who actually declared pandemic COVID-19 as a outbreak? An outbreak can last for a few days or week or even several years. So outbreak can be transmitted through person-to-person contact and even animal-to-person contact from the environment. So everybody is, I am audible is, hello? Hello?
Okay, audible, okay.
Okay, thank you. So now, the three kinds of disease actually, endemic, epidemic, and pandemic. Actually, this is a very important for our researchers, young researchers who are working now in this area, like some MSc students or some PhD students, some other researchers. They should have important information from this type of epidemic disease. Endemic actually describes a disease in the present permanently in a zone or population, and it continues at approximately constant level within a society, and it never disappears from the society. So this type of disease is called endemic. And epidemic, actually, it is an outbreak. A sudden outbreak affects many people at one time and can spread through one or several communities. So this situation has rapidly to a large number of people in a given population for a short period of time. And actually, this epidemic is not just used for the infectious disease. It also used any other scenario that leads to for the health risk within a society, like the rise of obesity globally. It is also an epidemic. Like the disaster cyclone, it may happen some global health hazard. This is also epidemic. So this epidemic, now the COVID-19 was an epidemic first time when it was detected in China. But recently, it is now both in pandemic. What is pandemic? Because the pandemic spread globally for certain period of time, and it continues for a huge death of mortality. It describes the epidemic when the spread is global. So actually, World Health Organization declared an outbreak of a new pathogen that spreads easily from one person to another person across the globe is called pandemic. So our COVID-19 actually is now a pandemic. It is not now an epidemic. So this pandemic, there is a lot of information. So how it is transmitted, the mode of transmission actually the H2H transmission. H2H means human to human transmission. Human to human transmission are recorded as two kinds. This is horizontal transmission, and the horizontal transmission actually occurs direct contact between the infected and the susceptible population. So this is the major factor for this transmission of the COVID-19. So we should minimize or we should stop this direct contact from to him, so that the disease cannot transmit from human to human. Because in Bangladesh or except China, all over the globe, this type of transmission is happening, human to human transmission now. And this horizontal transmission may be another transmission, vertical transmission. Vertical means it is actually transmitted from parents to offspring. So usually in maximum cases, horizontal transmission is happening. Also some vertical transmission, some disease. And the other transmission is animal to human transmission. Actually, our COVID-19, it was first transmitted from animal to human. It was recorded in China, in Wuhan. There is a zoonotic virus and zoonotic disease. So it was transmitted from an wild animal to human and then human to human. So our COVID-19 actually, this is a zoonotic virus, and it has, in very beginning, it was transmitted from animal. And now it is transmitted all over the world from human to human. So all these type of things is actually the coronavirus is a family, and it has already some different variety for this different strain. Last, it is called COVID-19 in the last genetic stage, strain of this coronavirus family. So this is the incidence is another important thing to formulate mathematical modeling. Incidence is an epidemiological model. It defines the rate at which susceptible becomes infectious. So this incidence is important and for the modeling case. And we use two types of incident case. One is bilinear mass action, or it is called the simple action mass action incidence, and another is standard incident. Usually it is nonlinear incident. And it is evident that standard incident is actually more realistic for the human disease than the simple mass action incidence. So now we can formulate, we can show here, we can show some basic model is usually used in mathematical biology or biomedicine. This is called compartmental model, because all the populations under the disease we are considering, the population groups are divided some compartment. The first model was actually SIR or SI, this basic model of epidemic disease, or it may have some endemic disease. So epidemic case, I will explain first epidemic case. Epidemic in the next, in the figure in the right side, you can see susceptible all people after birth or giving birth. By birth, we can, everybody become susceptible and goes this type of compartment. And after for a certain incident case, it is infected by some virus or some bacteria or some infected person, so it goes infected compartment. And when it is recovered, some case, in some parameter gamma, we call it this recovered case. And this recovered may happen, some disease has recovered and then it goes immediately again for the susceptible. But we are not considering here. But for the COVID-19 case, a lot of evidence exists where people become cured and then again infected due to uncareless behavior. So this is the epidemic case. But when it is endemic, I already discussed, endemics continues in a society for a long time and it does not disappear. So in that case, we consider demography, that is that birth rate and death rate and we use this birth rate and death rate, and also disease-induced death and natural death. All these natural death and disease-induced death we consider. Then this type of model looks like this, and also some initial conditions. So this all these equations actually the initial value problem, and you can see that beta is the incident coefficient representing the average rate of adequate contact, and then we can use this contact rate, and we can use this contact rate as the standard incident for the horizontal case. But this model have developed further as the SEIR type epidemic model. EPE is actually the exposed or some latent period, because every disease have some latent period, because when virus is entered the body, it takes some time to syndrome to show the syndrome or to become infectious for the patient. So this incubation period is called the exposed. So introducing this term, we can formulate the SIR model in terms of SCIR model. So the SCIR model is looks like a similar way, but this infected term is immediately goes E compartment, and the E compartment has some natural address transmission from E to I, then it will appear here, and it subtracted from E, and it immediately enters in the I group, and as usual this is the recovered. So this is the basic SCIR type of model. So now our intention here, the analysis of basic reproduction number, because basic reproduction number is very important for analyzing this epidemic model, and actually this is the threshold condition which determines the infectious disease, either it will continue in the society or it will die out from the population. So this is very important. We denote it or not. This basic reproduction number actually the average number of secondary infections produced when one individual introduced into the host population, or everybody is susceptible. Sometimes we use another threshold quantity. This is called the contact number, this sigma. So this sigma is defined as beta divided by gamma. You know, beta is actually the rate of incidence and gamma is the rate of recovery. So when we use the average infection period, we use 1 by gamma, and it is multiplied by beta. So this basic reproduction number and sometimes the contact number is same. So we can formulate basic reproduction number is a very simple deterministic way, look like this. But for a complicated case, we need a next generation matrix or some other technical analytical method to find this basic reproduction number. So basic reproduction number, when we analyze the basic reproduction number, it gives a very important message, because sometimes people may think when a disease starts, when an epidemic starts, everybody can make and say that it never will stop or it never will die out from the society. But mathematics says differently, because we know that basic reproduction number, if it is less than 1, then actually the disease epidemic, it is die out from the society, and while it is greater than 1, then actually it continue in the society for a long time. So our intention here to make this basic reproduction number less than 1, and for this is we need some preventive measure until any vaccination or any proper drug is not introduced or is not discovered. But what happens when the basic reproduction number is equal 1? But if in that case, when it is equal 1, in that case it is a steady state, and then herd immunity can happen. But herd immunity actually a very dangerous case, because mostly 70-80% population should be infected and then get immunity for this herd immunity system. So we don't want this type of thing. We want to minimize our basic reproduction number always less than 1 by applying different control strategy as our government or all right health professional and society, they are taking different preventive measures. So here our objectives, actually our objectives to understand this basic transmission mechanism of COVID-19 using mathematics. And we propose, we introduced this type of model when actually in Bangladesh or India, this epidemic was first identified in Bangladesh especially, because in that case, people came from outside or even from the other country to their home country, and at that situation, government tried to make them quarantine, to put in quarantine, home quarantine in some different case. So we consider here this SIRS type model for the susceptible, quarantine, infected and isolated. This isolated actually, it is the hospitalized and then recovered. So this 5 compartmental model we consider, but actually this is actually SIRS type model because it mostly susceptible and infected and recovered, and this recovered goes again from the susceptible. And then we apply optimal control strategy, because what is the optimal control strategy? I already discussed, and then I will apply in the next model, because our government or all the government of different country, they tried to put the people from the separated from the other mass people. That is, in that case, they maintain the social distancing, and so they make a huge educational campaign by using social media or TV or some other technique, so that the people cannot go to close contact with the infected population. So here we use 3 type of control, and then we make another preventive strategy for the gaining self-immunity, because self-immunity, another important thing, when people get infected, it become recovered when he stay in the home and take the necessary preventive strategy. So self-immunity is more important to get recovered by self using without going to the hospital. So now here we consider a model, this is the 5 state variables. You can see the state variables S, Q, I, S and R. And we use 3 control, E1, E2 and E3. This 3 control actually educational campaign, social distancing. Actually the social distancing is actually the physical distancing, because social distancing, it means if you don't go very close contact with some people who is infected, this is physical distancing. Another, when a people is already infected, we should take a great measure for the treatment or minimizing his horrible sufferings. So treatment is another, though it has no full treatment package, but the existing treatment is still working very good until a very fundamental or very effective treatment is not available in the society. So we use this type of 3 controls. One is before infection, other 2 is after infection. So before infection is called the educational campaign, and after infection actually with the social distancing, and another is for the treatment for the patient, depending on the symptom to minimize their suffering. So under the basis, we draw a very diagram, important diagram on this type of model. You can see here from easily, it is the source term. You can use a very source term. It immediately goes into the compartmental stage is susceptible, and then when it is some susceptible, where it comes from outside the country or outside the one district to another district, we can make it quarantine for the home quarantine like this at the rate of alpha. And then some susceptible, when it is identified that it is infected, then it goes to the infected group. And when the quarantine people are identified or it is tested, and if after test it is identified as the infected, it immediately goes to the infected class. And if it is not infected, it immediately goes to the recovered. And infected goes when it is at the severity stage, it needs to go to the hospital, and this hospitalization, we call it isolation for the intensive care. So there are also some natural death or some disease-induced death. So this is the very clear diagram of this 5 compartmental model. Now we use 3 control. First control is the educational campaign. When we use the educational campaign and when people become aware, then susceptible people cannot be infected by other people and it immediately goes to the recovered. But when it is already infected, we use second control for the physical distancing because our healthcare provider is mainly doctors, nurse, and some other healthcare providers. We know that in the globally or even in Bangladesh, in India, many doctors and healthcare providers died or infected, become infected when it gives the healthcare service. So infection is very important when we need physical distancing and intensive care. And the second one is isolation. Isolation also here, we need the intensive care for the treatment using some different treatment what is in existing in medical science until it is not discovered the very effective vaccine. And at the same time, also need the social distancing. So two controls at a time can be applied here. So applying all these control, our model looks like this 5-compartmental non-linear ODE, and it is SIS type model we can consider here with this some initial conditions. All these already discussed in our previous slide and in the diagram. And you can see here this control immediately it goes from S and it come in the R group. And it is the infection group, it goes in the R, and also in the isolation, it is also from minus here and it goes in the R compartment. So this is actually our model with control. And this model with control, so what is the aim of this model? Our objective function, as I discussed in our optimal control problem, because we should have an objective function. This objective function actually we need to minimize the infected class and also at the same time susceptible in the isolation class, because we need actually to minimize all the class, susceptible, quarantine, and all the others. But here we mainly emphasize infected and isolation class we need to minimize. At the same time, we need to minimize all these cost of the control variable because there is a huge cost for the educational campaign, for the physical distancing, because we need physical distancing for need some medical materials, equipment, and also some treatment for the drugs and some other treatment strategy. For all these have a lot of cost. We need to minimize this cost and also at the same time minimize the infected and isolated class. And all the controls variables are actually the set of measurable function AU. And it takes actually the values from 0 to 1 because when all this control measure is effective, this is we use this control variable is 1. But when it is not effective, we don't use any control measure. This control, the value of this control may be 0. So it should take the value from 0 to 1. So under the basis of this dynamics and objective function, we can formulate optimal control problem looks like this. As you remember in our previous discussion, we described our optimal control problem like this.
Professor Birsha.
Yes.
Please summarize.
Okay, so I will finish very quickly. This is the optimal control problem, and this optimal control problem actually the theory. I already discussed this theory because under the basis of this theory, we have the numerical results for this solution. Because this is the solution actually the U1 star, U2 star, and U3 star. This is actually the optimal solution, and we get this optimal solution analytically in the compact form looks like this. And now how our numerical graphs looks like when we don't use any control, no control. This is the graph, the actual figure because this is actually the function of the increasing function because the point dynamic model is actually increasing. So when we go to the comparison, we can find the comparison after using the control, because you see with control and without control, we have a huge difference for the quarantine population because quarantine population is going down after using the educational campaign and social distancing. So with two control. And again, the infected class, if you see the infected class, we are using 3 controls at a time: educational campaign,
Thank you very much, Professor Birsha. Professor Birsha has explained whole thing very nicely, starting from the basics. So time is over, almost over. So I can allow 1 or 2 questions from the young researchers.
I have some questions.
Young faculty members.
Hello?
So please questions. Hello?
Hello?
Yes.
Am I audible? Am I audible?
Yes, audible, please.
Yes.
Okay, sir. So, sir, it's a great opportunity to me to attend your presentation once again because I have attended your presentation during the conference held in the Tripura in last year.
Yeah, thank
and
you.
You had given a nice presentation also there. So from the beginning of this presentation, you have delivered that this model is based on Bangladesh and India, right?
No. The model actually, I am talking mostly about Bangladesh and India, but the model is global because we can set this model for the any country depending on the data. Because if we use different data for the different countries, we can use this model for any countries globally.
Okay, but sir, my question is that since you have divided your model into several 6 or 9, 5 or 9 compartments, but the problem is most of the countries is that the data set for each of the compartment is not available, right? Quarantine data, exposed people data. Then for this kind of situation, what should be the solution? How can we
actually quarantine? Actually, this data is you can. There are some limitation also, but if we consider the regular news from the TV or newspaper, we can have the regular data. How much people are going to the quarantine? How much people are coming from quarantine to the recovered from the home to hospitalized? So there is a regular data from the World Health Organization or odometer. So we can use this data, but though this data actually have some limitation, but we may have some not exactly, but we can tentative data we can take and then we can measure, we can prepare this data and calculate this data for our parameter. You can use this one.
But sir, actually, you have mentioned the two names, that is Worldometer or World Health Organization. But unfortunately, these two websites or these two organizations does not provide any kind of data except death, recovered, and infected.
Actually, I'm talking about odometer and the health organization for the global case. But when we feed the data for our specific, suppose from Bangladesh or India, then we should have this type of data from our disease center, for the center of the disease, epidemic disease, or daily news, or for the daily television. We can use this data, we can collect this data, and we can make this data for our parameter calculation for the estimation of the parameter.
Okay, sir. Okay.
Any other questions?
Professor Shankar?
Yeah. I am there. Yeah. It is very nice your presentation. Just you have prepared the presentation based on the present scenario, and it is totally matched with the title of the 3 days international webinar. It is nice presentations. Yeah, it is very nice. I am really happy to see all kinds of pictures and all kinds of data, all kinds of factors you have included in the mathematical models. My one question is there. So if there are 5 equations, a system of equations 5, or more than 5 or 6 variables is there, then how do you solve the problem? It is very much complex.
I already mentioned another model. This model is under submitted, and this submission already we get results for some minor correction. So I did not show this model, but this model is for the 9 compartment. The 9 compartment model a little bit complicated for analysis of the stability, of the disease free and the local stability, but it is possible, and we already did this for our publication for journal. So I just show the results. We have a very good result for this 9 compartmental model.
Indeed, I have a curiosity to see the solution procedure for 9 compartmental model.
The solution actually, the analytical solution, sometimes we take hand by hand, and then sometimes we use Mathematica for the solution of the, and then for the numerical case, we use the solver. There are some nonlinear solver for this type of solution, and also Mathematica or MATLAB. We also use MATLAB for this solution because it is not so much deal to handle this type of model.
Okay, very nice. Thank you. Thank you, Professor Birsha, for your nice presentation.
Professor Shankar, we have analytic solution till equilibrium points, and thereafter being a highly non-linearity of the model, one can go with Maple and MATLAB.
Yeah, ma'am. You can also use Maple because there are a lot of now software we can deal this type of stability or the solution of equilibrium point. So we can use Mathematica, we can also use Mappel, and also Axial MATLAB. So all these software have the technique for solving this stability and the local
It is sure, it is sure, it is sure. My curiosity is, if you design a mathematical model contains more than 5 variables, so without using any computer simulation technique, how do you find the solutions by applying some theorem or something like this?
We need, of course, we need the computational technique, and I already discussed in my first 3-4 slide that mathematical model and computational technique are now very important to handle this type of biological model. So of course we need some mathematical computational technique.
Okay, thank you, thank you.
Okay.
Yeah.
Okay. Thank you very much, Professor Birsha, for your nice deliberation. Thank you very much, all of you.
Thank you, everybody.
Yes. Okay.
Thank you.
Okay.
So thank you very much, Professor Birsha, for your nice presentation. And thank you, Professor Lai, for chairing this session. So now we are ready to start the next invited lecture session, that is lecture session 10. And the invited talk will be presented by Professor Itai Saha from Gujarat University, Ahmedabad, India. His title of the talk is Inventory Policies for Non-Instantaneous Deteriorating Items with Advanced Sales, Advertisement Efforts, and Effect of Static versus Dynamic Rebate. So may I now request Professor Shankar Kumar Rai to chair the session, please.
Thank you, Dr. Gorai, for sharing the share in this session. Good afternoon to everyone. It is our great pleasure that Professor Nita Saha accepted our invitation for delivering a speech on inventory management in this 3-day international webinar. Before starting her lecture, I am shortly introduce Professor Saha. Professor Saha is now HOD of the Department of Mathematics in Gujarat University, India. Indeed, Professor Saha received her PhD in statistics from the same university, and thereafter he visited University of New Brunswick, Canada, as a postdoctoral fellow. Her research interests are inventory modeling in supply chain, robotic modeling, mathematical modeling of infectious disease, image processing, dynamical system, and applications. During her period, Professor Saha completed 3 UGC-sponsored projects, and she published more than 13 monographs, 5 textbooks, and more than 475 research papers in different national and international journals with very good impact factors. And also, Professor Saha published this paper in variety of journals like Elsevier, Inter Science, Taylor and Francis, like this. Up to June 2020, his total number of citations is 293, and citation item index is 76, and age index is 24. Till now, she has guided 28 PhD students and 15 MPhil students, and now 8 students are pursuing their PhD program under the guidance of her. And also, Professor Saha holds the post President of Operational Research Society of India, Ahmedabad chapter, and she is also Vice President of Operational Society of India. With this short introduction, I request to Professor Saha to start her lectures with the title Inventory Policies for Non-Instantaneous Deteriorating Item with Advanced Sales, Advertisement Efforts, and Effect of Static and Dynamic Rebate. Just I say that, Professor Saha, please start your presentation now.
Yes, sir.
Please start.
Yeah, yes, sir. Can you hear me?
Yes, of course.
Can you see my screen also?
Of course, no problem.
Thank you, Professor Shankar.
Just a minute. 1 minute. I request all the audience, all the participants, please do not share any kind of information to the sharing option. It will be indirectly disturb to the speaker. I request all of them, please do not share any kind of slides or something like this in the sharing option. Yes, please, Professor Shah, start your presentation now.
Thank you very much, Department of Applied Mathematics and Oceanology, for giving me opportunity to explore my research paper under communication. In fact, I want to dedicate this lecture to veteran respected Professor Manoranjan Maiti. He was the first person to pull me in this research area in 1995. So thank you, veteran Professor Manoranjan Maiti of Department of Mathematics, Applied Mathematics, Vidyasagar University. In fact, title is on my slide. So let us have 4 words, non-instantaneous. It has been observed that whenever item comes in the inventory, because of their good quality, they do not start deteriorating instantaneously. It starts after some time. Advanced sales, but if retailer is knowing about the product and start advertising, then advancement sales can be improved. That is what it says, advanced sales using advertisement efforts. But we want to discuss about static versus dynamic rebate. Whether rebate for the deteriorating items is to be constant or it should change with time. That is, if for 14 days, this much is rebate. For next 14 days, this is rebate, and so on. So we will be comparing the effect of static versus dynamic rebate. This is teamwork of myself, Pratik Shah, and Milan Patel. Milan Patel is a research fellow and getting fellowship under SODH. Promotion of the product has become one of the essential tools for trade, as proper execution can give new heights to the sales of the product. That means, in another way, promotion of the product increases the demand. It helps to introduce the product to a larger level and helps to sustain in the competitive market. At an earlier stage, if promotion is done, then it will encourage more and more customers to go for the product. Promotion of the product can be done in various forms, such as advertisement, instant cash discounts, buyback, and many more facilities. Advertisement of the product has achieved maximum attention in modern marketing due to its effectiveness of reaching to many people and attracting them to buy the product. Now, this statement is not only for inventory maintenance or inventory controlling, but from March 22nd, we had huge advertisement of following social distancing using sanitizers, and many more preventive measures to be at home through media, through newspaper, and that has helped India to reduce the transmission rate of COVID-19 at a larger scale. We have only 20 lakhs plus infectious COVID-19 individuals. If you compare it with USA, they have more than 1.35 crore at present. So various types of advertisement such as retailing advertising, trade advertising, institutional advertising, industrial advertising, product advertising, online advertising, etc. are different modes. Because for next 2 days, you must have received mails or messages. Amazon Prime is advertising, online advertising to buy the product and have a huge discount. Lee in 2013 studied price and advertisement dependent stochastic demand for inventory models in a supply chain. Now, when advertisement is done, obviously demand should be considered, or real experience is stochastic demand. Vertical cooperative advertising in a manufacturer retailer supply chain, where the retailer runs local advertising and the manufacturer pays for a portion of the entire cost of advertisement. And this vertical cooperative advertising is mainly done by automobile industry and high-tech industries, maybe of mobile, maybe of TV and all. Similarly, studied inventory model for pricing and two-tier advertising with one manufacturer and one retailer. Here, when you talk about two-tier advertising, manufacturer does advertisement from his end, and retailer does from his end. Neither of them are going to share any type of information. Z in 2009 studied coordination of advertising and pricing in retailer manufacturing supply chain. Whenever there is advertisement, obviously demand will increase, and economics rule says that when demand increase, price should be decrease. UATEL in 2006 also considered two-tier advertising policy between one manufacturer and one retailer. Next is advanced booking. Advanced booking is a handy tool that can be used to generate revenue in advance. Because by having revenue in advance, manufacturer can earn interest on the generated revenue. It gives retailers probable ideas of the product demand in the market. And advanced booking also gives us the idea about the demand pattern, whether there will be a good demand of the consumer or not. Products books in advance are delivered to the customer as soon as they arrive to the system. And hence, the retailer can get rid of deterioration problem for these products. Not only deterioration, but it also reduces inventory holding costs of the retailer. And that is what automobile industries, particularly for the cars, they are using. It is also an effective tool which is used to be assured of sales of the product. I already said how it assured. Further, offering products at a discounted rate during the advance booking phase gives boost to the demand of the product and helps us in generating revenue in advance. So all the tools which have been said till now boost the demand. Market demand of the product is influenced by many parameters, which I said. Dietel investigated inventory model for deteriorating items under joint pricing and ordering policy for advance booking system with partial order cancellation. If after advance booking, customer wants to cancel order, that should be allowed, because it might have happened that in intermediate time phase, customer might have come across a better product as compared to the booked product. So, Dye et al. Allowed partial order cancellation. No doubt they will lose, consumer will lose some percentage of advance booking payment. Tassav et al. Studied retailers' optimal ordering and discounting policies under advance sales discount and 2 economic trade credit. 2 economic trade credit means supplier gives credit period to retailer and retailer gives in turn part of trade credit what he has received to his consumers. Selling price plays a key role in the sale of many products. It has been observed that for many products, sales is affected by retail price on a large scale. And this is what we had observed. If you have two branded iPhones and say Samsung, depending upon the price, and you may have to compromise, but it is getting affected, particularly in post-COVID phase. Higher selling price may result in increased total revenue, but it reduces the demand of the product. On the other side, lower selling price can increase sales, but it may reduce overall profit. So we need to have a trade-off between price and demand. Deterioration is defined as decay, spoilage, waste, damage, fungus, or evaporation of the product. And huge amount of literature is available, even review articles are available on deterioration and inventory modeling. Bardhan considered an inventory model for non-instantaneous deteriorating item with preservation technology investment under stock-dependent demand. So deterioration, this paper suggests that deterioration rate can be reduced if proper preservation technology investment is used. Dye in 2013 studied the effect of preservation technology investment on non-instantaneous deteriorating items. Mishra et al. Developed an inventory model with controllable deterioration rate, considering time-dependent demand and time-varying holding cost. So Mishra went for a more realistic situation where they considered time-dependent demand and obviously holding cost, because every year there is a contract for a retailer to have holding costs depending on the rate of interest, and it goes on changing or it goes on increasing after 11 months if it is residential and after 3 months if it is rental. Pal et al. In 2018 gave optimal replacement policy for non-instantaneously perishable events. In the study, they considered random sort time of deterioration and also used preservation technology investment. In most of the products which are getting deteriorated, it is very difficult to tell with certainty that this is a time at which deterioration will start. So uncertainty got catch up by Pal et al. Shah et al. Gave optimal inventory policy for single supplier, single buyer supply chain where demand was price and stock dependent. Trade credit from manufacturer to retailer and from retailer to customer were offered. Shah studied inventory policies for non-instantaneous deteriorating items for inventory models. The time when the deterioration starts, it affects sales of the product due to poor quality and may cause drop down in overall profit and goodwill of the firm. And to reduce the goodwill of the firm, rebate is very important factor. Offering rebate on selling price to sell deteriorating products can help the retailer to stop loss from deteriorating items and generate revenue by selling the product at a reduced rate. Price rebate is unlike the discount, which is deducted in advance of the payment. So it turns out to be beneficial. That is what it says. Customer needs to pay full amount for the product, and after a certain specified time, customer gets a price rebate in terms of cashback in his wallet. And that is what is the scheme followed by good number of online sellers. They say if you use SBI card, you will get cashback off. If you get Citibank card, you will get cashback, and so on. It comes after 30 days. Once the deterioration phase starts, it is necessary to clear stock as soon as possible so that profit can be maximized. Offering price rebates in terms of cashback helps to increase the demand of lower quality product or reduce quality product and works as a stock clearance surge. And that is what generally we get. It comes in stock clearance sale of winter, stock clearance sales of summer in molds. Dietel in 2018 studied the effect of dynamic versus static rebate in the study of investigation on price, displayed stock, and rebate-induced demand using hybrid BAT algorithm. So they optimize problem using naturally inspired algorithm. Then Sasan et al. In 2017 studied optimal rebate strategies under dynamic pricing. In their study, they developed an inventory model with mail-in rebate policy. So it is as good as cashback policy. In this talk, we will have demand as price sensitive and influenced by promotional expenditures. In first phase, products are booked in advance at a discounted rate together with production of the products. Delivery of the product booked in advance is given as soon as the product arrives to the firm for sale. Obviously, there will be some lead time, but customers are asked to take patience so delivery can be made. Products are considered to be non-instantaneously deteriorating. Once deterioration starts, low quality product may harm to good product, also to the goodwill. So it is advisable to sell off deteriorated product at the earliest. So it can be separated out and play card can be kept for reduced price. Keeping this in consideration, once the deterioration starts, a price rebate in the form of cashback is offered to the customer on purchase of the product. Effect of dynamic versus static rebate is analyzed. Also, the case with no price rebate is compared with static and dynamic rebate cases. Preservation technology investments in order to reduce the deterioration rate is incorporated. Standard assumptions are M stands for advertisement, P for normal price, T cycle time, decision variable, Xi preservation technology investment per cycle. And cost are as usual, ordering cost, cost for purchase cost, discounting factor in if you go for the advance booking, obviously it should be less than 1, holding cost H, and some inventories. Okay, and now let us go to the model. This is the pictorial graphical representation of inventory stream. This is phase, that is 0 to T1 is the phase of product as well as advance booking is considered with discounted price. That means here consumer is getting product in time with advance booking. T1 to T2 is the sell phase with no deviation. That means during 0 to and T2 to T deviation phase with price rebate on selling price because item has started deteriorating during at time point T2. So we need to know what are the demands during each phase. R1 depends upon the advertisement selling price and advertisement. Advertisement increases demand, so it is plus sign, and demand decreases with increase in selling price, so it is taken as negative sign. In T1 to T2, once again, it remains almost same. But in T2 to T, we have to go for two different cases, that is static and dynamic. For static case, we will have and in dynamic case, rebate depends upon time. So we have R into T. Now next is, what are the inventories? With some calculation using differential equation, in phase 1, which is production and advance booking phase, inventory level is given by Q0 into T by T1. In second phase, which is sales period with no deterioration, it is Q2 plus R2 into T2 minus T. In third phase, static rebate, that is R3S by theta, because deterioration has already started. No doubt here once again a limitation is that we are taking constant deterioration because of static case. And next is for dynamic rebate. So for dynamic rebate, last term plays a vital role. So total profit per unit time in dynamic case is this, and for static case is this. Now, how to find out the optimal values? Use simple algorithm. Allocate values to all inventory parameters other than decision variables. Work out decision variable partial derivative of objective function with respect to decision variables. Just recollect decision variables were advertisement effort, that is M, selling price B, cycle time capital T, and how much preservation should be done per cycle, that is psi. So these are the necessary conditions. Substitute values of the decision variables, static case and dynamic cases to get optimal values of the production quantity and profit. Let us see numerically. With this data, we have compared static case, static rebate, dynamic rebate, and no rebate. One can see that dynamic rebate and no preservation technology investment incurs higher advertisement cost. Because time is considered into picture, it reduces advertisement. Because once I know that now I don't have units which are getting deteriorated, obviously I will not be using preservation technology. Then here we have once again compared selling price in three cases: static rebate, dynamic rebate, and no rebate. Dynamic rebate and no preservation technology investment incurs high selling price. And if selling price is high, we will have more profit also. So this is total profit. And it says dynamic rebate and preservation technology investment incurs higher profit compared to other strategies. And reason is quite obvious, because we are giving rebate also. So giving rebate increases profit. And we are giving rebate in the sense cashback may be there. So cashback increases demand, and that will increase the profit. Here, dynamic rebate and static rebate are compared for cycle time, and we see that cycle time gradually increases with increase in ordering costs. Price sensitive index, that is the markup generally in call, and cost price. Moreover, increase in demand factor, rebate advertisement, sensitivity index, rebate sensitivity index result decrease in cycle time. And this is once again quite obvious, because in that case, you will have to, because your demand has increased, you will have to order again and again, and that will reduce the cycle time. Here, promotion cost is compared, and it says that advertisement cost is very sensitive to almost all inventory parameters. If we offer more discount in the advanced booking phase, then we need to invest less in promotional efforts. Because depending upon the demand, retailer will order for, and he will reduce his holding cost. So conclusion is, the inventory model is designed for non-instantaneous deteriorating items. It advises for preservation technology investment. And the purpose of giving rebate in third phase is not only to reduce the cycle time, but it is to preserve goodwill of the firm and generate more revenue. For example, in Gujarat, the mango season is going on till August end. And organic mango vendor, at the end of the season, when mango starts deteriorating, provide some cashback to customers so as to clear stock as soon as it is possible. Because once mango start deteriorating, it loses its value. It just have to throw back or to dump, and that is loss for organic mango farmer. Providing price rebate increases the demand, which is useful in generating revenue at a large scale. Providing price rebate for a product which is slightly poor in quality than the fresh one helps to preserve. Good retailer can simply say that this is first time that we had a poor quality, next time this will not occur. And that is what we have experienced a lot. The retailer should wisely decide the advertised investment amount to be spent for the promotion of the product, and also should take care of the discount provided for deteriorated items so that the overall profit can be maximized. No doubt here there are huge number of conflicting decision variables which needs to be trade-off. The retailer needs to take care of investment made in promotion of the product and advance booking discounts. So present research model can be extended by allowing shortages, because when there is a spoilage, obviously shortage can be there, and which may be much realistic to work with. In present study, we have not discussed about redemption of rebate money obtained by customers. Therefore, an extended model can be developed considering utilization conditions of price rebates. This is from my end. Questions are welcome.
Thank you, Professor Shah, for your hello.
Yes, sir.
Am I hearing?
Yeah, audible.
So thank you, Professor Shah, for your good presentations. And you have covered a lot of things by considering deteriorating and different types of advertisement, and incorporate all these things in the inventory model, and thereafter you solve it and shows about the profit maximum. Now I open this talk for discussion. So any question from the audience, please? Hello?
Yes, I can hear you.
So I asking question from the audience.
Yes, sir.
So any questions from the audience, please? Any questions from the audience? I mainly target to the young researchers. I think you have learned this, all the slides, and she already described different types of advertisement and deteriorating items, something like this in the inventory design, inventory model. So at least one question or two questions I need from the audience. particularly look to the young researchers. Please. Hello? Is there any question from the audience? Okay, if not, just I'm asking one question. You have considered preservation technology in your model.
Yes, sir.
Where you choose the preservation factor xi, and it is you mention it is greater than or equal to 0. If it is zero, then what happens? I think
if it is 0, then deterioration rate will be the one which was constant. But by adding preservation technology investment, deterioration rate got reduced by 30%. So
that
now 30% reduction in deterioration was observed when preservation technology investment was made, and that has increased the profit.
But to use the preservation technology, some cost must be added.
Yeah, it is added. Preservation technology investment for a cycle, it is added. It is PTI in the profit function.
Then still profit will be better.
Yeah, because you have to use preservation technology investment for the whole cycle. Cycle may be of 2 weeks, maybe of 4 weeks, and once setup is done, you don't have to pay. You don't have to invest more in preservation, and that is what cold storages are doing.
Just I am considering a real life situation. If we consider the preservation technology for storing perishable items,
yes,
isn't it? Then some power cut or something like this will be there. Then
Professor Shankar, they have backup.
Yeah,
I had done this through a live case. We had visited cold storage.
Yeah,
they were storing mango. As I said, Gujarat is famous for mangoes, and they have backup for power cutoff for almost 12 hours. For almost 12 hours, so it can continue for 12 hours.
Oh, that means if there is no power cut, something like this, it has happened to your effect in your model.
Yeah.
Okay, no problem. Another question from my end. You have incorporated many decision variables in your inventory model. So without computer simulation or without using any kind of package, Mappel or Mathematica, can you analyze this whole system theoretically?
Up to necessary conditions, I can do manually. But then to show the sensitivity, I have to go down to mathematical softwares.
This is the most important question nowadays in research program.
Yeah.
Actually, in good journals, they want to solve the model by considering the theoretical discussion, not using any kind of computer simulation like Mathematica, Mappel, or MATLAB, something like this.
No, yeah, my my team is using analytical results. That is through pen and paper.
Yeah.
Because I belong to the department which was established by Professor P.C. Vaidya, and he was believing only in chalk and duster. And same thing I am using. Only I am using pen and paper instead of chalk and duster.
Okay. So I must thank and appreciate your efforts for delivering the slides and the designs and something like this. I congratulate to you for your nice presentation. Thank you, Professor Saha. Thank you.
Thank you. Thank you.
Okay. So
thank you, Department of Mathematics.
Yeah, thank you. Now I go to the organizer, Ganesh. Please, Dr. Ganesh, you say something. What will be happen after this session?
Okay, thank you, Professor Shah, for your nice presentation. And thank you, Professor Rai, for chairing this session. So now we'll go to our last session of this 3-day webinar. That is the valedictory session. So once again, we welcome all participants throughout the world in this valedictory session. In this session, Professor Madhumangal Pal, Vidyasagar University, Department of Applied Mathematics, will act as a chairperson, and Professor H.S. Rahane from Karnataka University, Dharwad, is the chief guest. Professor A. Bharali from Dibrugarh University is the special guest. On behalf of the organizing committee, I welcome all of you in this session. So now I will request Professor Madhumangal Pal to conduct the session as a chairperson. So sir, please start the session.
Thank you, Dr. Godai. So this is the last session, that is the valedictory session of 3 days international conference or international webinar organized by Department of Applied Mathematics, Vidyasagar University. So in this session, we have two guests already declared by Dr. Godai. One is Professor H.S. Ramani. He is the head of the Department of Mathematics, Karnataka University, Karnataka, and Professor Ankur Bharali. He also the head of the Mathematics Department, Dibrugarh University, Assam. Both the professors have organized the international webinars few days back. So they have a lot of experience of organizing this kind of webinars. So in online conference, there are some merits and also demerits, A lot of merits are there. The main merits are, we have observed that the gathering of huge number of participants and also the speaker from many parts of the globe. I see that in our conference, the participants are from in our country, say from the east part Meghalaya to west part Gujarat, so north part Kashmir to south part Tamil Nadu and Kerala. So the entire region, from the entire region of the country, a lot of participants are joined here. Also the speaker from the different states of the country and also from the other countries, say like Canada, Poland, Iran, Malaysia, Saudi Arab, Nigeria, Bangladesh, and many other countries. The participants and also the speaker are joined here. So this is the big advantage of the online webinar. And another advantage is that it is very cost efficient, very less cost is very less money we are using to organize this kind of conferences. Or this is another advantage and cost effective we can say without spending the travel time. Also, there are participants are joined here. Also, the speakers are presented their work for the benefit of the society. And another important thing is that the live telecast. That means we have streaming the program, our program in YouTube. And this program is available for a long time in the YouTube, and hence we can or anybody can watch the program in any time, anywhere using any media. That means using mobile or a laptop, etc. It has also some drawbacks. Say like we have see that the connection problem, the network connection problem is a big issue. Lack of physical interaction with the speaker and other participants. This is another drawback. And we are highly depending on the technology. So there are some more drawbacks are there. But I think it is a very good gathering of the good participants and speakers. So now we start the technical parts of the session. So we have two guests, Professor Ramani and Bharali. So I will request them to say a few words about the international webinar, its prospects, its challenges, etc. like this. And after that, we will call some the participant to share their experiences or the suggestion or queries like that. So first, I will request Professor Ramani to say a few words about the conference like that. So I welcome Professor Ramani in our university, Vidyasagar University. Professor Ramani, please.
Okay. Thank you, sir. Good evening to all of you. Nice to see you once again on this online platform and to meet the people and to interact and all that. Very nice. So just a few, I'll say some few words about this. Okay, so respected Professor Madhumangal Pal, Professor S.K. Mondal, the head of the department, the special guest, Professor Ankur Bharli, joint conveners, Burman and Giri sir, other participants, invited speakers, faculty members. A very good evening to all of you. First of all, let me congratulate the organizers for organizing such conference. And the theme is the role of applied mathematics in present global crisis. Okay, in the memories of Pandit Ishwar Vidyasagar on the eve of his bicentenary birth anniversary. As Professor Madhumangal Pal explained, the plus and minus points of the online conference and all that. Plus point is that we can meet many people with our convenience and all that. There is no cost and all that, less cost will be there. But as a negative point, other side, if we say, means if a network connection problem or something is there, then some kind of shortcomings are there. But one way, looking to the current scenario, this is a nice platform to continue our activities, to keep our activities, academic activities on that, to interact the people, to exchange the ideas, to exchange the knowledge and all that. So one way it is good also. Okay. So the theme chosen by the organizer is fitting correctly with the present scenario. Okay, in this COVID-19 pandemic. Okay, and all of we know that due to this COVID pandemic, many sectors are affected, including education sector, transportation, all that. Okay, so we are experiencing all these kinds of these facts and all that. The Julia Gog, an epidemiologist at the University of Cambridge, rightly said that life is not going to be same for a long time. It is going to change. Okay, it is going to change. So role of applied mathematics in real time pandemic response is the how basic models can work, how the techniques, what we mathematicians do, how it is useful for the society. So one can see, and I think this conference is the best one that looking to the list of the speakers and all that, their titles and talks. Okay, so this conference is, I think it will be fruitful to tackle the real scenario word problems and all that. So these models can be used or can be analyzed for the further studies. So normally it is not obvious instantly that what methods can do, but we know that the mathematical functions can be applied to as a tool to describe the dynamics of how crisis propagate in the society and how to overcome on it, how these models can be used to control those crisis or to overcome about the things which are going nowadays and all that. So we can use these models for better life. Okay, so these models helps to identify the factors and actions that may enhance the global economic security also. So COVID-19, as I told, it is affecting almost all sectors, okay, including transportation, education is there, health is there, economy is there, even day-to-day life of the people. Okay, so it is affecting much. So these such types of conference and deliberation or your discussions, it may help to overcome all these issues. So many global challenges we face are multidisciplinary. Okay, so overcoming these requires the collaborative work with other people like scientists, engineers, okay, sociologists, then psychologists and all that. So together we have to work and we have to come out with the good solution or good methods to tackle these current problems. So, okay, so I hope that the knowledge received from this conference by the audience, by the researchers and all that can be used to analyze and forecast the information so that it is very meaningful to the people who need it. So I hope that this conference will be helpful to everybody. With these few words, I will conclude my talk, and I thank the organizers for giving me an opportunity to say few words about this in this occasion. Thank you, sir.
Thank you, Professor Raman, for your nice coordination or combined thought in these critical situations. So thank you very much. Now I request Professor Ankur Barali from Dibrugarh University to say a few words regarding the conference or international webinar. Professor Ankur?
Yes, thank you, sir. Can you hear me?
Yes, yes, yes.
Respected Chair, Professor Paul, Chief Guest, Professor Ramani, HOD of the Vidyasagar Department of Mathematics, Vidyasagar University, Professor Mandal, and the other members of the organizing committee, eminent invited speakers, and the participants of this conference. It is indeed an honor for me to have an opportunity to say a few words in this international webinar on the role of applied mathematics in present global crisis, organized by the Department of Applied Mathematics, Vidyasagar University. The selection of the conference team, that is the role of applied mathematics in present global crisis, is very timely and in line with the common global objective of human civilization. Amid of the COVID-19 pandemic, when the world is in turmoil, the economies are at nosedive, we must remember that tough times never last. Only tough people and tough institutions do. So to celebrate this untamed human spirit, it is a praiseworthy effort of the department. I really want to congratulate the entire organizing team for this. The eminent invited scholars like Professor Weber, Professor Jagi, Professor Chakraverty, Professor Bhattacharya, Professor Jacob, Professor Brower, Professor Shah, and many others have added a different dimension to the conference. When I say the role of mathematics in present global crisis, one can straightaway recall the various fields where the application of mathematics is inseparable. And during this conference, we hope we have a fairly good idea about it. The mathematical models that help us to predict and analyze outbreaks are like familiarity with the various concepts. For example, what we have in the news currently, the R0 value, flatten of curves, even the design of future public health policy. In the current situation, people are very anxious about when will this outbreak end. Rather, we are more interested in an optimistic question like, why do this outbreak eventually end? And over the years, mathematical epidemiologists sometimes use predictive curves and sometimes they use various theoretical thresholds like R0 to address these questions. I hope the participants have a great experience attending this conference, and I would again like to thank the organizers for putting up a nice show. With these few words, I conclude. Thank you. Thank you all.
Thank you, Professor Barali, for your nice summarization of our theme, the conference theme. You have nicely summarized the theme in this critical situation or critical time. So thank you very much for your presence in our conference. So now the guest has said something, but I would like to listen some words regarding the conference from the participants. So I request the interested participants, 2 or 3 participants, to say a few words. What is the merit, demerits, and what problem they have faced, how much they have benefited from the lecture. So in this direction, the participant can say a few words. So any participants? Hello? I am asking some participant to say a few words about the conference like this.
Hello?
Yes.
Hello?
I'm speaking Dr. D. Narasimulu from Central University of Tamil Nadu, sir. So
Yes, yes.
I thank to all those who have been organizing this conference. In the since 3 months onwards, I have not seen this kind of conference. So during this COVID-19 situation, so you have organized a very good conference, but sometimes we have faced some technical problem. But I have known that many participants attended this conference. So like invited talks, some invited talks are very good, and also some research scholars have presented very good work. So at this time, those we have presented good works in applied mathematics. Therefore, those models are very useful to construct and study future scope of this COVID-19 also. So thank you to all of you, and thank you to VC for Vidyasagar University, and thank to all faculty members for Vidyasagar University. Thank you, sir.
Thank you, sir. Thank you very much for your nice words. So anybody else? Any participants from West Bengal, from other state? Lot of people, sir, participated from Tamil Nadu, Kerala.
Sir.
Hello.
Yes, sir. A lot of people participated.
Hello. Yes. Hello. Hello.
Hello.
Hello. Yes, yes.
Sir, this is Keshav Kumar, sir, from
Yes.
Hyderabad, G. Narayanma Institute of Technology and Science.
Okay, thank you, sir.
Is it audible, sir?
Yes, yes, audible.
Yes, sir. I want to thank all the organizers of Vidyasagar University, which gave me the opportunity to present my paper, and I got a lot of knowledge. Okay, and maybe during this COVID-19, this has been opportunity for me to present my paper at this Vidyasagar University. Otherwise, I could not come to Vidyasagar University and present my paper. Only COVID has given me the opportunity to present my paper. I think this was my advantage, and I could see that all efforts are being made by the members. I would like to thank everybody, all the members of Vidyasagar University, for giving me the opportunity to present my paper. Thank you, sir.
Thank you. So a lot of the problem we are facing during this COVID, but even we learn a lot of things. No, we are organizing webinar. We have no idea about how we can organize the conference online. So and a lot of people from different parts of the country and other country, they are attending our conference, and they knows the Vidyasagar University. And the inauguration session, one speaker, one dean of arts of our department, he explained about the life of Vidyasagar. He is a great social reformer. So it is the extra profit from the participants' point of view. No, he knows about the Vidyasagar. Has a great personalities, great social reformer. So anybody from audience?
Hello, good afternoon, sir.
Yes.
Sir, I'm Mini Nair from St. Joseph's Academy, Delhi. Sir, it was very wonderful to attend such a session. I would have never imagined to come to your university or attend such 3-day session. But the way you all conducted it, the way you all, the papers were presented, that was very commendable. And really, I would be longing and wanting to attend more of such sessions. Thank you so much, sir.
Thank you for attending our conference from a long distance. Okay. So any other participants?
Hello, good afternoon, sir.
Yes.
Hello, good afternoon, sir.
Yes.
Hello, good afternoon, sir.
Slightly loudly.
Hello, good afternoon, sir.
Yes. Now audible.
Myself Supriya from this department, Vidyasagar University. Good afternoon, everybody. Thank you once again to the organizers for organizing this type of international webinar. I am privileged as a paper presenter in this webinar. I am thankful all the distinguished speakers from day one to today for enriching us with valuable talk. This type of talk will help us as young researchers. Thank you once again.
Thank you very much. Thank you. Any other participants? Do you want to share your experience? Hello, any participant? So I think nobody are interested to any participant here because they are tired. I think they are tired to attending the 3 days conference. So a lot of programs are there, with compact schedules. We have prepared because a lot of speakers are there, a lot of paper are presented. Around 90 paper have been presented during this conference. I think it is the last we have reached at the end of the 2 days program or the entire program. So now I would like to hand over the mic to our organizer. Yes.
স্যার আমাদের হেড চেয়ারম্যানকে কিছু বলতে বলুন।
Oh, right. I think head is with us, no? Our head, Professor Shyamol Kumar Mondol. So I request you to say a few words at the end of the conference. Professor Mondol.
Yes.
I mean, his experience, his journey, I would like to.
He faced a lot of things, no?
Good afternoon, everyone. Especially, I want to thank chief guest of this session, valedictory session, Professor H.S. Ramani, Karnataka University, to attend this valedictory session. Actually, he is busy. In spite of that, he attended here to grace these occasions. So thank you, sir.
Thank you.
Next one is our special guest, Professor A. Bharali, Dibrugarh University. Thank you also, sir, to present here to grace this occasion as a special guest. First of all, as a head and chairperson of this webinar, I thank you all those persons who help us to conduct this webinar. First of all, our invited speakers from Poland, Canada, F. Brouwer. I think he is the oldest persons, those who are attended in this webinar, about 80 years old. He delivered his lectures. 88 years old. He discussed his lectures about COVID-19 at this age. At what time? A time actually early morning. Early morning, he's out his country, with respect to his country. Early morning, I think about 5:30 a.m. in the morning. So early morning, he participate with us to deliver his knowledge among those persons who are participant, young researchers, who doing research, or those who are attempting to do research for those persons. That person inspire how to work, how energy. So I think students are motivated from that person. I thank Weber from Poland as a keynote speaker. I thank K. Jacob, Malaysia, I thank Christie, Saudi Arab. I thank Professor Haidar Ali Birsha, Khulna University, Bangladesh. I thank invited speaker in our country from Delhi, Professor C.K. Jaki, from Gujarat, Madam Nita Saha, S. Chakraverty, NIT Rourkela, S. Bhattacharya, ISI, Kolkatta. Oh, thank you all. And thanks, actually, our two joint convener, Dr. Raghunandan Giri, Dr. Krishnendu Barman. Actually, they are two very junior. They had no knowledge previous how to conduct such types of webinar. Actually, till now, we are not conducting a 3 days conference physically also. We just organized before 2 days conference, but a 3 days conference and in online system. So it is very difficult. So I apologize to all participants for technical fault. There was some technical fault due to online. I thank our senior teachers, senior Professor Madhumangal Pal, Professor Shankar Kumar Rai, Professor Dilip Kumar Maiti, Dr. Ganesh Ghorai. They are always advising me and also our joint convener how to conduct, what are we doing, what is the present situation, everything you are looking carefully. And if you see there is any fault, they knocking me and our joint convener. So thank you, sir. Thanks our large participant, about 1,600 participants. And paper presenter, I think 9,200 paper presenters. They attend this webinar to success. Without her participation, it would not be fruitful. Actually, we are now passing through a critical situation, critical atmosphere due to COVID-19. We do not know what should do. So, in such situation, our department feel that one such a webinar like this on applied mathematics should be occurred, from which different young researchers can get some information about applied mathematics. How we can assist, how can do research using mathematical tools to overcome different physical problems which are occurring around us every day, like corona, like economic crisis, like atmospheric imbalance, like this. So I request all participants, please you think to do something. Your work, actually, you have to elevate it to upper positions. You give some new idea, new innovative idea by which our nation will be benefited, by which truly we can overcome our such types of problem. So you do not do research just to get a PhD degree. It is my humble request. It is my humble request. Please, you do not do just such types of research to get a PhD degree. You do such a research by which our nations, our world is benefited. Our human beings are benefited from your research works. Please you try. It is our humble request. If you do that, then that will be success of our such types of webinar. So, first of all, I thank our Honorable Vice Chancellor, without whose permission, it is permission and his encourage, it would be not possible. So thanks our Vice Chancellor, sir, and thank you to all. Thank you.
Hello?
Thank
Hello?
you, sir.
Hello? Hello?
Hello.
Hello? Sir, respected HOD, sir.
Yes.
Sir, just have to know, sir, one question. How many members presented papers, sir, in the total conference? Just I have to know, sir. 200.
Actually,
130, 113. 113.
113.
Yeah,
13. Number of participants, sir, total 1,000, more than 1,000?
1,600.
Oh, 1,000?
600.
Okay.
1,600.
600. Okay, right. Thank you, sir. Thank you.
thank you all. Thank you all. Sir.
Next agenda, the vote of thanks. No, that one
Sir,
will be given by.
Sir.
Yes.
I request, sir. Madhu. Just to call our Professor and Dilip Maiti, sir, please. Okay.
So, Professor Maiti, you say a few words, very few words regarding your experience in new kind of program to organize as a organizer. What experience you have together?
Okay, thank you, sir. I don't need much time also. First of all, I should thanks to all the guests, esteemed invited speaker, and to all these participants who have remembered or get to know, or they have attracted or they have attended our conference, and hopefully probably physically they would not have come to our university to attend this conference. In that sense, I must congratulate and thanks to HOD sir taking initiative to organize this webinar. And in that way, our name of the department, name of the university, it has been, conveyed to many people, and by that way, I think 1,600 participants have attended or registered. That is a great achievement, at least for me, being a faculty member of this university and the department. And what I will say, and probably the theme of the conference to the participant, I can tell, from our side, we have arranged 10 invited talk by which we could manage to cover present global crisis like economic, safe supply chain management, COVID-19, and then, cyclone, whatever the present crisis we are facing, many of them has been covered by the esteemed, invited speaker. So in that way, probably, at least as a member of the faculty, I feel we have covered and we got a success. And in that way, I must congratulate HOD and all other team members. Thank you all.
Thank you, Professor Maiti. Then I request Professor Rai to say a few words. Hello, Professor Rai, Shankar Rai.
Thank you, Professor Pal, for giving me the opportunity to say a few words at the end of this international webinar. First of all, I would like to thank all invited speakers from outside of my country and inside the country also, and all dear participants. The theme of the international webinar is appropriate in the present scenario. We are totally confined at home. In this stage, at least from our department, especially HOD, Professor Mondal, and two joint conveners, Dr. Giri and Dr. Bormon, and other faculty members, other professors, Professor Pal, Professor Maiti, all of us supported to organize such an international webinar for offering the use of mathematics in this present scenario. We have learned many lectures from COVID-19 also, or mathematical biology model, where we have seen a reproductive number are not less than 1, equal to 1, greater than 1. What will be the situation is coming now, or is going on, or already happened? This factor is very important. That is clearly described by many researchers in this platform of the webinar. Especially participants are not rich here, although they remember all things, all lectures, what presented in this webinar. I hope, especially to the young researchers or young participants, you have gathered not lot of knowledge about the present situation, how mathematics will play to analyze the situation, and expect that they will return to utilize this concept in their research papers in such a way that the country, that means our country, India, as well as around the globe, some mathematical model can help us to recover the present situation. And this situation not only on biomathematics, it is also affected several things, and that model by the operation research. Many concepts, many topics of operation research are discussed here based on the present situations by using the applied mathematics. I again repeat to young researchers and my dear young participants, please utilize this platform and to reflect this thing in your research paper. With this few words, I must conclude my talk, looking to all invited speakers, all participants, and last but not least, my HOD, our departmental HOD, Professor Mondal, Professor Pal, Professor Maiti, and Dr. Ghorai, and Dr. Giri and Dr. Bormon for their constant support. These types of webinar, I think it is successful, and this carry some information to the participants. Thank you all.
Thank you, Professor Rai, for your nice summarization regarding the different kind of models. namely on biological models. So can I request Professor Kaushik Ghosh from Bardhaman University? He is attending all the session during these 3 days. Professor Ghosh, can you say something about the webinar? Because you have a lot of experience to organizing many international conferences. Professor Kaushik Ghosh. Hello. Hello, Professor Ghosh. Hello. Hello, Professor Ghosh, Kaushik Ghosh. So something is wrong with him. So anybody interested to say any words, 3 words regarding the conference? Your microphone is not working, Professor Ghosh.
Hello.
So, yes.
Sir, I'm a participant in this webinar actually. Can I say some words on this?
Yes. What is your good name?
Sir, I am Velan Chandrasekhar. I am a software developer actually. So I'm not a pure mathematician or a research candidate actually. But anyway, I got very much interested in this webinar actually. After seeing the last 3 days, I have learned so many things actually. So since when I was a student, I always had the feeling like, mathematics and science, what is the application of this in our normal life actually. And I always wanted my professors to teach that in a practical way so that we can get it applied in the normal life actually. And this seminar actually gave me a hope, this is going in the right direction. Like people are actually applying mathematics and science in the normal life rather than just being a theoretical subject actually. So I was very much enlightened in this actually. And I also gave a very good feedback in the WhatsApp forums. I want to write up on this in an elaborate way. So I spoke to some of the professors there in the WhatsApp group. So they said, no, I can do the write-up actually. So I'm going to write that actually. So actually what you're doing is a very good opportunity for all of us actually. So once the academicians and the normal people interact, then they will be able to come up with very good results. I think that's my humble opinion actually. And this is a very good platform for that actually. And what you are doing is an excellent service and excellent opportunity for all the researchers and also the common people. Thank you very much, sir. And it's a great pleasure to be present there.
Thank you.
Hello, myself, Dr. Ghosh. Can you hear me?
Yes. Yes.
Yeah, at that time, perhaps some problem was there in the system. I am being blocked in the camera as well as in the voice also somehow anyway. So thank you very much for giving me the chance to say some words in this particular valedictory session. It was a really wonderful session throughout for 3 days, last 3 days. I've seen that very efficiently you have managed. Some glitches are there, of course, technical problems are there, some network issues are there. Some of the particular members, perhaps from the Jammu Kashmir, they're having the problem in network issue, 2G network are there. That's why some problems obviously are there, but still you've managed a lot. It's very superbly and efficiently you managed. And also I've seen that in WhatsApp group, there are so many queries, so many problems are there. Some changes for scheduling are being requested, and you have actually throughout for the last 3 days, you have taken care of all these issues. So it's a very nice one. All the speakers, invited speakers, they were very good, and different perspectives have been taken into account. You covered a lot of areas in applied as well as pure mathematics. It's a nice one. I feel really that it's a very wonderful session I have experienced for the last 3 days, and I learned a lot. Thank you very much.
Thank you, Professor Ghosh. So you have a lot of experience, to organize a different international conference and the heading of Calcutta Mathematical Society or other institute. So thank you for your nice words and your presence. Thank you. So,
thank you very much. I'm honored.
Thank you, sir. So anybody interested to say a few words? No. So I am requesting our organizer go for the next session or next item or next agenda.
Sir?
So what is the next step? Next steps, vote of thanks or like that, or announcement?
Hello, sir.
Yes.
Sir, I am Dr. Kumar from Tamil Nadu, sir.
Yes.
Sir, we are actually
I
we are
will request
working in a.
Dr. Barman.
Sir.
Yes.
Actually, we are working in a pure mathematics only. This is the new platform for me. I have learned many things, sir. Now onwards, I am very much interested on this kind of real life situation problems. I am very much thankful to organizers and all. And one more request is kindly share all the PPTs as much as possible, sir. Thank you.
Okay, if the PPTs are available, then we can send the participants. Okay.
Okay, sir. Okay, sir. Thank you.
And one announcement is we will prepare the certificates. Those who are attending the conferences, okay, attending the conferences, not registered. Those who are attending the conference, we will provide the certificates, but it takes 3 weeks. Okay, within 3 weeks, you will receive your certificate by email. Now, Dr. Ghodai, let's start the next session, next item.
Professor Paul, can you invite Professor Birsha to say some few words about the conference?
Sure.
Just to invite Professor Hyderali Birsha. Can you invite him to say a few words? Professor Birsha.
Yes, thank you, Professor Rai.
Yeah.
And thank you again to giving me an opportunity to say something about the international webinar. Actually, this is a very great opportunity to all the researchers, especially for the young colleagues and young students, scholars, during this pandemic situation, because I already mentioned in my talk that we are now all are restricted in to stay in our home, but though this pandemic situation, research cannot be stopped. It proves 2 days, 3 days international webinar, because a lot of participants are attending this webinar and enjoying the a lot of talks, especially relevant to use of mathematics and application of mathematics in diversified area. So in this situation, I think, though I have not yet the opportunity to visit your university physically, but this is a great opportunity to meet you on the webinar, online, but hopefully we can meet physically and the pandemic will die out, and depending on the reproduction number, as I discussed, reproduction number, when it should be minimized less than 1, then immediately the disease should be done out and we get a better world to stay for our lives and to work together. So I again congratulate the organizer for these great and wonderful events, and also thanks to all of you, especially head of the department and Professor Roy for telephoning discussion before this webinar, and for the invitation me in this event. Especially yesterday, I was very much surprised and also inspired from the talk of Driver, because he is still 88. What about us? Because we are still young so much compared to him. In that case, I will say to the young scholar, young researcher, or our young colleagues, to take the inspiration from him and to do the research for the application of mathematics in real situations, and it makes us for doing better collaborative research, because I believe that individual research cannot make a fruitful a platform. It takes a collaboration with all directions of application of mathematics. In that case, it will be more fruitful if we have some collaborative research in diversified areas. So thank you again, and thank you very much to you for giving me the opportunity to taking part this webinar, international webinar. Thank you again.
Thank you, Professor Adar Ali Bishesh. And anybody interested to say any few words? Otherwise, we will go to
Yes,
the
sir.
end agenda.
Good evening.
Yes.
Good evening, sir. This is Sweta from Chakraverty College, Madurai, Tamil Nadu. I'm a PG student, sir. I would like to thank the organizing committee for arranging this informative, knowledgeable, and precious webinar. This is really motivational for me, and it also provides a lot of interest on real life mathematics too. This is my first international webinar, sir, and I will do it on future too, sir. Thank you, sir. Thank you so much for arranging this kind of webinar. These 3 days are really more precious, sir. Thank you, sir. Thank you so much.
Okay. You are from Madurai?
Yeah, sir.
Are you from Madurai? Okay. What's your good name?
Thank you. I'm Shweta.
Sweta. Okay.
Hello, sir.
And
Hello.
anybody else? Yes.
Can you hear me, sir?
Yes.
Good evening, sir. I am Munir Nabi, research scholar from Central University of Kashmir.
Slightly loudly.
I am Munir Nabi, sir, research scholar from Central University of Kashmir.
Okay. Thank you.
Yeah, it was a very nice webinar, sir.
Yes. Continue.
Sir. But the time was very less, sir. 3 days are less for such a wonderful webinar. It could be for at least 7 days, sir. But due to some technical problem, I could not present my paper, sir. So I just shared the slides. At that time, I was not audible, sir.
Yes. This is a very big problem for online conferences. No. And
Yes,
your
sir.
Kashmir, there is a big problem for internet communication till now.
We have only 2G here, not 4G.
Yes.
So that's the problem, sir. And I'm very thankful to everyone. Thanks to the organizers for conducting such a wonderful webinar. It was very knowledgeable, very informative. Thank you, everyone, sir.
Thank you for your participation in our international conference from a long distance. Okay, thank you.
Thank you, sir.
And now we are at the end of the session.
Yes,
so there is a vote of thanks. So can I call our joint convener, Dr. Krishnendu Burman, to give the vote of thanks?
Yes, sir.
You start.
First, Dr. Ramakrishna, please stop your presenting. Dr. Thakur Ramakrishna, please stop your presenting. Good evening to everyone. Respected chairperson, eminent professor, our most valued invited chief guest and special guest, ladies and gentlemen. I'm privileged to have been asked to propose a grand vote of thanks on this auspicious occasion. I, on behalf of the organizing committee for this 3-day international webinar organized by our Department of Applied Mathematics with Oceanology and Computer Programming, Vidyasagar University, and on my own behalf, extend a very heartfelt thanks and gratitude to our Honorable Vice Chancellor, Sir Professor Ranjan Chakraverty, for his nice and inspiring inaugural speech. He is also patron of this webinar. We are all inspired by his great words. I am very thankful to our Honorable Vice Chancellor, Sir, for his continuous support and advice, which have greatly helped towards the grand success of this 3-day international webinar 2020. Thank you very much, sir. I may express our sincere thanks to the guest of honor, Professor Subrat Kumar De, Dean of Science, and Professor Sivaji Pratum Basu, Dean of Arts and Commerce, for kindly accepting our invitation and gracing the inaugural function. I am also thankful to our respected Professor Sivaji Pratum Basu, for his kind consent to deliver the memorable speech on Pandit Ishwar Chandra Vidyasagar. I am very much thankful to our chief guest, Professor Gerard William Weber, Poznan University of Technology, Poland, and our special guest, Professor Manoranjan Maiti, former professor of our department, for kindly accepting our invitation and gracing the inaugural session. A big thank you to Professor Weber for his kind consent and great efforts to deliver the keynote lecture. I am also thankful to Professor H.S. Ramane and Professor Ankur Bharali for accepting our invitation to be the chief guest and special guest for the valedictory function. I must mention our deep sense of appreciation for all plenary speaker, esteemed session chairperson, and the delegates for their enthusiastic participation and gracing our important work and sharing with us your findings and opinions during this webinar. All well, an event like this cannot happen overnight. The wheels start rolling few months ago. It requires planning and a bird's eye of for details. We have been fortunate enough to be backed by a team of very motivated and dedicated colleagues. I take this opportunity to express my sincere thanks to respected senior professor, Professor Madhumangal Pal, Professor Samal Kumar Mondal, Professor Shankar Kumar Roy, Professor Dilip Kumar Maiti, Dr. Ganesh Ghodai, and Dr. Raghunandan Giri for their outstanding contribution. Honestly, I have no word strong enough to express my deep gratitude to Professor Samal Kumar Mondal, chairman of this webinar and HOD of our department. He has been a constant supporter and real performer of his responsibilities. Thank you, sir. I also wish to express my gratitude to all faculty member, officer, non-teaching staff of this university, especially Mr. Surendra Mollik, Executive Director, Computer Center, and Mr. Biplab Chakraverty, Information Scientist, for providing us with all possible logistic and technical support towards organizing this event. I am also thankful to Mr. Asakul Babu and Mr. Nandan Mondal for their all-time helping hand and continuous support. Finally, I would like to convey a very hearty thanks to all participants who have come from different schools, college, universities, and other institutions with India and abroad. The participants are very enthusiastic and exceptionally helpful to and very, very supportive of any kind of obstacle that we face. So my heartfelt thanks to all of you. I thank all of you. I think all of you deserve a huge round of applause. I am sure that the participants must have benefited by attending this webinar. Stay safe and good health. Thank you everyone and have a wonderful evening.
Okay, thank you.
Thank you,
all participants.
Thank you very much.
Thanks, our joint convener, Dr. Krishnadu Bormon, for your vote. Thanks to the organizer, to the participant, speakers. So now I request Dr. Ghodai to say something, or if you have any announcement, you may announce here. And
okay, sir. So once again, I congratulate all of you, all the participants, all the faculty members throughout the world. So with the permission of the chairman, may I now declare the close of this 3-day webinar on the role of applied mathematics in present global crisis.
Thank you, Ganesh.
Thank you to everyone.
74. Okay. Thank you.
155.
Thank you, everyone.
Hello. Hello, hello. Hello. Hello, Krishnandu.
Yes, sir. Yes, sir.
I think the session is finished, no?
Yeah, yes.
Is there any more announcement?
No, sir.
No. So thank to the participants, and lastly, I can say that the PPT, lot of participants are asking for the PPT. If we get the PPT from the speaker, then we'll distribute it through email. Okay.
Okay, sir.
So thanks to all the participants, all the my colleagues and other members for their presence and patiently presence here and their valuable comments in the conference and greatly participated. So thanks to all of you, and I declare the session here and also the end of the 3 days international webinar. Thanks to all of you. And feedback form, you will receive, the participant will receive the feedback form shortly. Our conveners will send the link of the feedback form within short time. Okay, there is no problem. And if anybody filled up at least one feedback form among 3 feedback forms, then he or she will get the participation certificate as well as the prepared presenter certificate. There is no problem. But I need on at least one feedback form. Okay.